check. Can you guys hear me? Oh yeah, that's loud enough. Okay, well it's 9 o'clock and I was told I had to kick this thing off, so camera person? Is there a camera person back there? Is it okay if I wander around? Will you be able to track me on the camera? Is that okay? I don't really like to stand in front of the podium unless I have to. It's too constraining. Well, good morning and welcome to Dakotacon. I get the honor of starting the conference off, which is really great. I'm really excited to be here and do that. It's been a couple years since I've been here. Was at a lot of the early ones, and I'm really excited to give this talk in particular because I think it will really round out the view and learning and a lot of the stuff that a lot of the students who have taken some of my courses get in the 844 and 848 and some of the deeper technical stuff. This is kind of a step back from that to kind of come up for air and, see the whole forest, so to speak. So how many people have either taken a class that I've taught or are going to take a class that I'm going to teach? Raise your hand. Quite a few. Okay. Interesting. Yes, I know. Well, good. Anyway, that's great. So I am the Chief Hacking Officer at VDA Labs. When you own a small company, you can give yourself random titles, which is really fun. So also obviously teach here at DSU and involved in a lot of other great stuff in the industry. So I will just, if I can get this to go, jump right into the talk. So this is kind of a slide. I'll come back to this slide throughout the talk, but just to give you sort of a view of the process of how to conduct a product security test and how it sort of fits into the larger security strategy that companies have. And that's really important to think about because you have to think about what's our overall strategy, what's our budget, at what level can we secure things. For example, if you own a network, I feel like this is pretty hot. I'm going to move this down just a little bit. If you own a network, can you dump the firmware off your Cisco router and start reverse engineering the Cisco router image to find zero-day vulnerabilities in your network infrastructure? Yes, you could. Maybe. I don't know that you'd be successful in that, but you could try. Is that the most effective use of your time and resources? Maybe not, right? Especially if you're kind of a normal sort of mid-sized business or whatever. You probably have bigger fish to fry. You probably need to train your staff on social engineering awareness, and you probably need to make sure that you have a robust strategy from endpoint security to network security to application security to all this stuff. So kind of understanding what your organization does and where you're at and where your security strategy fits in to all of that is kind of what this talk is about, is really kind of setting the stage for all the talks you'll have today and really everything you'll learn hopefully throughout, whether you're a student here at DSU or in your own career as you go deeper into particular topics. This talk is sort of meant to set the stage for that. The other thing I like to tell people right off the bat when it comes to doing product security testing and finding vulnerabilities and getting a pen test done and all that kind of stuff is it's a good thing, right? Sometimes, particularly developers are a little nervous about it. They don't always want to get their code audited because, well, what if they find vulnerabilities and they realize that there's problems in my application I wrote? And that's kind of a silly mindset because of course there's bugs of course there's vulnerabilities in the application you wrote. Everybody has that. Nobody's immune to that. So don't let that stop you. We always tell clients that, let's see if I can get to, it's basically trying to figure out where you're at on the security spectrum. You're a 5 out of 10 this year and you want to get to a 6 or a 7 next year or whatever it is. It's more about assessing that and understanding that than it is about kind of pointing the finger and realizing that you're not very smart at managing a network or you're really bad at writing applications. It's never about that when we do a security test. It's about how do we help the organization improve and be safer and be more secure. That's kind of what it's all about. Okay, so about me, again, founder of VDA Labs, former NSA, built next generation endpoint tech, teach on Pluralsight and here at DSU, often in the news. The two classes I teach right now are 848 and 844 if you're interested in the cyber program here, the PhD program at DSU. So that's a quick little rundown, I guess, on me. You probably knew some of that. So I want to kind of set the stage before we get into how to actually do a product security test, right? How to do static analysis and dynamic and some of the different things as far as how to actually find bugs in a product. I kind of want to continue to set more of the stage up just so that you have a broader view of how I see things. Because, again, there's these high-level goals. Don't skip the strategy when it comes to security appetite, leadership, budget, risk assessment, organizational maturity. There's all these different pieces that fit into what a product is doing, a company is doing, and kind of the overall strategy of security rather than, hey, let's just find bugs, right? There's a lot of other things to do besides that, and we're going to talk about some of those things. I also want to talk about how products have changed a little bit. So when I first got into this field over 18 years ago, it was all fully compiled, native code, right? So everything was written in C and C++, and the vulnerabilities you were looking for were buffer overflows. That was the thing. Everybody was looking for buffer overflows, right? And that's changed a lot because products have changed a lot. So now, when you think about products, what's a modern-day product look like? Well, think of something like your Nest cameras or a connected vehicle or anything like that where from your mobile app, you can see what your cat's doing at home while you're at work, right? That's the cool stuff that today offers us. And how does that work? It works through a lot of different things. It's not just one particular C++ app that makes that happen, right? There is C and C++ involved in that. The kernel on all the operating systems, the kernel of your mobile phone, there's the kernel of the routers and the firewalls and everything. And there's the whole sort of fabric of everything that makes that work has sort of C and C++ fully compiled native code at its core. But there's also a web app somewhere that wireless camera or whatever at home talks to through an API, and that same API, your mobile phone talks to that, and that's how you can see the picture of your cat when you're at work, right? So when you think about how am I going to find vulnerabilities in that product, it's like, well, what product? The network, the credentials, the mobile app, the web app, the API, the router at home, the firmware of the camera. Which part of the product would you like to audit, right? The whole product, the whole ecosystem, or just particular pieces of it? So with that, I set the stage of how the world has changed and how it's different than it used to be. So when you talk about security and hacking and vulnerabilities and all this stuff, I really want you to be thinking more broadly than just any particular, not just a malware sample or not just a buffer overflow or something like that. I really want you to think about this whole ecosystem of a product, because that's how everything works now. That's how cars work. That's how cameras work. That's how all the home automation, IoT especially, we see it so much. All these embedded systems and stuff. They're a mixture of everything. So as security professionals, that means we are supposed to know everything, kind of. And that's kind of a tall order, right? Like, do you really know everything about mobile apps, as well as web apps, as well as APIs, as well as things written in C and C++, like operating systems and kernels and stuff like that? No one knows all of that. And so, in my mind anyway, one of the most effective ways to audit a product is to design it right in the first place, and we'll talk about that, how to do that. But then you also need a small niche kind of ninja team to really do the product test. No one person probably knows all of that, right? You probably need a small team of 4 or 5 people or something like that, somebody who's really good at web apps, somebody who's really good at mobile, somebody who's really good at APIs, somebody who's really good at C and C++, stuff like that. I think these smaller sort of cyber ninja teams can really be the most effective at auditing any of today's products or ecosystems. Maybe one person could do all that, but it's a tall order for sure. So the other thing I want you to think about is whether it's that product or the service or the network or the app or whatever it is, there's probably somebody in charge of the whole thing, either the makers of that product or the users of that product. There should be somebody in kind of a chief security officer type spot. And again, they're not just thinking about how do I get a pen test done. That's a really important part of it, and that's kind of what we're going to talk about today. But that's just, let's see if I can get it to highlight. There it goes. It's just testing. Pen testing is this part, very important part. But it's only one small piece of the overall picture. And that's the one thing that I think if you've ever taken highly technical class, like malware reversing class or anything like that, awesome stuff. But sometimes, maybe as students, we forget that there's this whole broader picture we need to know about. There's GRC, there's governance and risk. There's all the new GDPR laws in Europe as they talk about how do we deal with privacy. Citizens want more of their privacy back. They want both, right? When you're driving down the road using Google Maps, you want to give up a little bit of your privacy so that your map knows how to get you from A to B. But then once you arrive, you'd like your map to forget about that so that your privacy is regained. There's a lot of stuff going on in that world of security and privacy. It's all very separate from some of the highly technical things that we study. And they're all very important. So you've got governance, risk, you've got all these new strategies. If you're the chief security officer of a business, you're thinking about user analytics and behaviors. UEBA is it's kind of a hot area right now. It's sort of insider threat detection. There's all these different initiatives and strategies and things outside of just a pen test, right? And so as the keynote speaker, I wanted to be the one to make sure that we laid this foundation for today before hopefully some of the other speakers after me today will go into maybe more niche topics and kind of drill down into some of these areas. But I at least wanted to make sure everybody had this foundation in mind as they think about concerns, strategic goals, and tactical efforts to deal with those, right? Keep that in mind as you think about any particular activity. So I kind of already talked about this. This is the idea of a small team that does testing the best. And I also wanted to lay the foundation of what an enterprise network pen test looks like and how it's maybe different from, I'm trying to get it to click through all the little things on my slide, how it's a little different from a corporate product pen test. So a typical enterprise pen test includes some or all of the following: an external pen test of your IP addresses and open source intelligence gathering and looking for maybe breach data and trying to hack into a network from the outside in. And then it also includes maybe an internal network assessment, so finding all of the different vulnerabilities inside a network, whether it be HVAC controllers that have default creds or a domain controller that you can breach using Responder by passing a hash or cracking password hashes or all this different kind of stuff. There's wireless hacking and all the different things that you can do to assess the strength of wireless protocols. There's social engineering testing, phish testing, and all the kind of testing that's really, really interesting. We do all this on a regular basis. That's part of what my company does. So we do all these different services as well as application testing, and that part of it's actually a lot closer to what I'm talking about today, the whole product security testing. Actually, the process of doing a product security testing is very much similar, whether it's an enterprise pen test or an app test or a code audit or a product test. The process of how you do that, how you gather requirements from the customer and do the assessment and report on vulnerabilities. It's very much the same. It's just that the skills and the techniques and stuff are different. There's physical pen testing, there's reporting, all this different stuff. So a lot of you, if you're familiar with pen testing, have maybe heard about all that. So one of the other things I wanted to point out today is if you don't know all that, you should. So go learn about all that stuff, each one of those domain areas, drill into each one of those topics and learn about each, because each one of them is very deep and very technical. But it's also a little different than product security testing, so I want to point that out too. Okay. I feel like my thing must be running out of batteries or something. I might have to do this. Okay, so yeah, these are sort of the steps associated with a product security test that are a little bit different than the corporate test, which would be, so secure development lifecycle, designing the product right in the first place, developer training, architecture review, and there's at least 3 or 4 major models as far as how to do that, what the best approach is to design a product securely from the get-go. So that's really important. All of the domain ramp-up, so learning the knowledge of if you're going to design a product in the ICS space, the industrial controls versus the banking or the automobile or whatever, there's different domain kind of tribal knowledge that you'll want to learn about. Like in the auto space, it's all about the CAN bus, right? That's a special thing to the auto industry that they get really excited about, where the medical industry doesn't care about that, and neither does other industries. So kind of learning what's special to each particular niche industry, and why is that important to them, and what are you going to do with that? How does that help you either secure it or it's not secure or whatever, based on that domain knowledge. And then when it finally comes to testing, so all the other engineering work, the testing is just a part of it, and it's an ongoing, active part of product security. What are the different pieces of testing? Static analysis, dynamic analysis, and manual analysis are the 3 big ones. So if you were to ever go through a PhD program and on your comps get asked, tell me 3 ways to find bugs in software, not that that question's ever been asked during a comps, the answer is static, dynamic, and manual. And then you can drill into each one of those areas and talk about activities under each one of those. And you'll get that out of today's talk. That'll help set the stage for that insight, right? So keep that in mind. Okay, so the first step, the SDL, sort of the software maturity life cycle. The point of this stage is to increase the IQ of everyone in the organization, right? So increasing security knowledge across the organization, from development to test to QA. It's not just something that's done at test time. It's not just something that vulnerability research do. It's not just something that hackers do. Understanding how do we make this product more secure from the get-go, like not including stuff in the product. Like the product doesn't maybe need to do everything. One of the best things you could do to secure a product is remove a feature. Just leave it out. Don't develop it in the first place, right? If your car doesn't actually need to be, sending location data, or I don't know, whatever, maybe they probably does. But you can imagine there are certain products that do more than they need to. So kind of reducing risk in the first place. Attack surface reduction, that whole mindset and that whole knowledge. And following one of these continuous improvement models like Microsoft's SDL, Synopsys BSIM, or OWASP SAM, those are the three major SDL models out there. And I don't have time to drill down into each one, but if you were to look at each one, they all include certain components like training, requirements, design, implementation, testing, verification, release, which is operational release, like dealing with it as it's fielded, and response. As vulnerabilities are found, how do you deal with that? So that's Microsoft's version of it. Darn, I wish my thing was working better before. Now it's kind of hardly working. Synopsys BSIM. Actually, I went too far, didn't I? There we go. They call it, instead of the Microsoft version, they have sort of four major and then sort of minor domains. So governance, intelligence, SDL touchpoints, and deployment. I like the way that the OWASP version phrases it: governance, construction, verification, and operations, because I think that makes it very clear in today's DevOps world where we're constantly writing code and releasing code and writing code and releasing code, maybe more than once a day even, right? Code is being written and pushed out on a kind of a continuous version. So this construction, verification, and operations is an ongoing active. It's not like we built it 2 years ago and now we're testing it 2 years later. It's like we have to find a way to kind of do that on an ongoing, all-the-time basis. And again, you could spend a long time studying each one of these, and you probably should at some point if you're interested in software security, but we don't have time to really dig into that too far. So again, if you were asked how to find bugs in software, static, dynamic, manual, there's other phrases for those in industry. Industry uses the terms SAST, DAST, IS, and MAST. Those are the four terms that are kind of fairly new to the industry. And this is the latest Gartner Magic Quadrant. I don't know if you guys have ever seen one of these or not, but they kind of release these for every product, for network security, endpoint security. This is specific to AST, Application Security Testing domain, they call it. And there's two products which we've used, certainly before in the work that we do, Veracode and Synopsys, which I like both those, and they're toward the top of the quadrant, so I'm not surprised by that. I always caution the use of these kind of quadrants because honestly, let's be honest, a lot of these kind of charts are sort of bought and paid for kind of marketing things, right? Like companies sort of encourage Gartner to make sure they're on the list sort of situations. But in this case, at least, I actually agree with the quadrant. I think that Veracode and Synopsys are pretty good. And they include, and the reason for that is because they have a suite, they're a commercial suite, and I'm not endorsing them in any way. I'm just saying if you're doing AST on an ongoing basis and you want a commercial solution to help with that, they do include both SAS, DAS, and at least some parts of the others as well. But SAS and DAS are probably the two most important. Interactive IS is kind of newer, and that's basically like as an application is running, you're getting feedback about its operation in some way, sort of discovering either intrusions or vulnerabilities actually as a product is fielded. So that one's slightly different than the others. But we'll look at some of these. I'll show you some screenshots in this of some of these technologies at work. So before we do that, though, before we talk about the 6 steps of a product security test, so we're still getting there. I know it's a lot of background and ramp up just to get to the meat of today's talk, which is how to actually do a product security test. We're still getting to it. I'm still trying to give you all the right requisite background knowledge. Why do mistakes happen in code again? Lots of reasons, right? Could be numerous issues, right? Maybe the developers weren't properly trained. Maybe the deadlines for software release were too tight. They didn't have enough time to do proper testing. Maybe there's no budget for it. Management says that security is really important to them, but when they're asked to actually like send somebody to training, there's no money for it. You know, that kind of stuff, that happens a lot. So there's lots of reasons. There's also lots of other sort of more architectural reasons, like maybe, you know, we still see medical equipment that's on XP, for example. I don't know if you guys have ever noticed, have you ever been to like a hospital and like the nurse's station computer's like this ancient XP machine, and you're like, you know, that actually happened to me when I was going to have LASIK surgery done. They're like, put your head in this highly advanced machine and it's going to take pictures of your eyeballs. And I'm like, that's running Windows XP. Like, that doesn't make me feel good about putting my head into this highly advanced machine. I feel really bad about that right now. Not good. Because it lacks DEP, it lacks ASLR, it lacks code sign, it lacks all the modern things that are in Windows 10. Can we please get this running on Windows 10, you know? And that, by the way, if you're ever asked about these topics in an advanced exploitation class, that's part of why you want some of these, right? Because the older releases of operating systems didn't include these exploit mitigations that newer operating systems do. It could be lots of other reasons. There could be, you know, poorly written algorithms, like you rolled your own crypto, or you're using old crypto, or you're not storing data encrypted, which we've seen that a lot in prior breaches, right? Like when you think back to the Yahoo breach and the LinkedIn breach and all these different mega breach, Equifax and all these, a lot of times, what happens during those breaches? You hear about it a lot, like, wow, there was this mega breach and like 10 million records or billion records or whatever it is were released, and the average person goes, okay, what does that mean to me? Well, it could mean a lot of things to you. One of the things it means in terms of pen testing, and we use this to our advantage as pen testers a lot when we go to breach a company, is we look through that prior breach data for usernames and passwords, because a lot of times they're part of the breach because the passwords weren't stored encrypted. So if we're pen testing XYZ company, we look through those prior exposures and we go, oh, here's some user and passwords for like 500 people that work there. Let's see if any of those passwords still work, and sometimes they do. So we can actually, no fault to these people, their password has been exposed, basically, right? And that's why two-factor authentication is really important, and there's lots of other things associated with that I could talk about. But, you know, storing data, how you do that's really important, and it's not just important to you, it's important to others too, you know? And that's one of the things I think we're seeing across the industry is if you get breached and your data is lost, maybe you don't care. Probably you do, right? Your stock's probably going to go down. And there's lots of reasons why you probably care too, but it's going to affect other people also. Even if you didn't care, it still hurts other people, other companies. It's not good for a lot of reasons. So one thing we see a lot are existing bugs in third-party libraries. So you'll see, like for example, we see it a lot in IoT. If you're going to build an IoT camera, how much of that camera are you going to actually build? You're going to create a new IoT camera today and sell it for like $50, which is crazy that you could sell something that cheap, right? It's brand new, connected, wireless, you know, fancy. You're going to create, you know, like not that much of it in some ways. Maybe you'll buy sort of like prepackaged housing stuff, and you'll use an open source video editing library, and you're like, a lot of it, most of it will be packages and components and third-party libraries that you're going to kind of pull together and make something work. And so when those libraries are out of date and really old, then you sort of inherit all the weaknesses and the vulnerabilities of that. So that's another reason that vulnerabilities can be in software, is because of the things that you inherit. And so those need to be kept up to date, and that can be hard. Lack of clarity, confusing APIs, responsibility gaps. We love to test where systems touch each other. So you've got this part of the company that doesn't play very well with that part of the company, and they made an app together, and there's some integration point where it's all supposed to kind of work magically. And this guy, you know, is in charge of the security up to this point, and this gal up to this point, but they don't really communicate very well. That's where we like to test, right? Because they probably screwed that part up. So think about that when you're creating a system. How well do they interface, and how well do they play together? So there's lots of other things in design issues, complex code, not thinking about the future, that could affect the security of a product. A lot of the other things are the basics, kind of the things that we've known about for 20 years in this field, right? Like having a password, having a good password, having different passwords that aren't always the same in default. Stuff like that, we still see that very frequently in the IoT space where, you know, because of the legacy and the history of that industry, you know, when you think about industrial controls and things like that, it was always an industry where a technician would come with his tool belt, and he would work on the air conditioning unit, and they needed to know the default password because he was just going to plug in with his laptop, and like it was okay kind of because it wasn't really connected to the internet. But now that everything's connected, that same sort of poor security practice that they used in the past, and we see it in other industries too, not just HVAC, but we see it in like the physical, like the home alarm industry, and there's a lot of other industries that kind of have fairly poor practices around passwords and things like that because it wasn't really that important before, but now it is. So getting the basics right. Segmenting networks, strong passwords, monitoring, updating the firmware. Those are all what I would call the basics. For example, does your HVAC system need to be on the same network as your domain users, your normal corporate users, or your privileged corporate users, or your finance? Or probably they should be separate and segmented in some way, right? And that would be really good. That's called least privilege. It's a thing in security we've known about for 20 years, and we still see it being done wrong in many cases. So separation, segmentation, defense in depth, having more than one control around important systems. So not only does it have good passwords and all that, but if it's physically available, like a thermostat in an airport, sometimes you can just go up to them and you can actually plug right into those thermostats and you're on the network at the airport. Oh, that's bad, right? Maybe they should put a little plastic house around that so you can't physically plug into it, because that would be kind of bad. So thinking about the sort of defense in depth, having monitoring, intrusion detection, doing canaries even, maybe put a fake HVAC controller on your network with a default user and password, and as soon as somebody tries to log into it, you know you've got somebody trying to attack your network, because nobody should be logging into it. It's a fake system. That's actually really smart. We don't see a lot of people doing that, but it's a really easy, really smart control to put in place, this sort of honeynet type systems. So, yeah, I don't know if you guys have tried to go to Shodan.io, but still a lot of problems there. I gave a talk last year at various places about how to find cameras on the internet and log into them and stuff like that. You can still do it. If you go to Shodan.io and if you know what to search for, you can. I bet I could do it right now if I was on the net and find an open camera somewhere in the world. It's really easy. So there's still a lot of crazy stuff out there. And just sort of the basics. And so you want to go, not only have a good user and pass, but you want to go beyond that, right? You want to limit by IP and have to VPN in, and kind of all the two-factor authentication is really, really important. If you're not using two-factor auth for like your email and your work and banking, you should be. Let me just say that. If you're using just a user and a pass, you need to be using a user and a pass and a PIN or something that comes to your phone for all your critical accounts. Because a user and a pass anymore just isn't, it's not safe enough. Not in today's threat landscape. Okay, so updating your firmware is really important because software decays over time. So what was safe a year ago is not safe this year necessarily. It needs to be fresh. It needs to be kept fresh, or it will decay over time. And maybe even hiding your intellectual property, right? So obfuscating, if you're writing code in, like, say, a managed language. So if you ever get a question on what's the difference between reverse engineering code in a managed language and a fully compiled language, the answer to that question would be reverse engineering managed code. You run it through something like .peek if it's like C# or Java. There's a number of tools, and then you can basically take managed code right back to source code if it's not obfuscated, because it's not fully compiled. It's in kind of a half compiled format. Where with fully compiled native code, it's fully compiled into assembly code. It's a little bit harder just in general to reverse all the way back to like C code. There are tools. IDA Pro does have an extension that can kind of do that, but it's a little harder just by default. You can still obfuscate that too, though. So obfuscating your binaries to protect your intellectual property is a good idea, because reverse engineering in either case is possible. You might also want to try to hide your code a little bit. Sort of, our industry's been sort of down on security through obscurity, right? Like, well, you're just hiding your firmware. Attackers will find it anyway. They'll be able to dump it off the device. That's true. They will. But it might slow them down. And in today's world, with as fast as things move, code's being developed so quickly and stuff, if you can hide your firmware behind some kind of a paywall or login or something that maybe slows attackers down by even 6 months or a year, that might be enough that the new version's out by then anyway, and it actually is fairly effective. So some amount of security through obscurity is actually, in my opinion, a good thing. I'd do it if I was running a product. I would hide my stuff. I wouldn't give it out to just anybody. I would only give it out to those who need it. And then be, accountable for the things that you make. Be able to respond to a secure act company. If somebody, sends you a report like, hey, I found a vulnerability in this product, don't hate them. Say, hey, thanks, I really appreciate it. Like, we'd love to work with you and make a fix. And there's still too many companies out there not understanding how this whole security research thing works. So, all right, that's all the background I have. I know that was a lot. How much time? Yeah, it took like half the time to go through all the background. So we finally have enough background knowledge to talk about how to conduct a product security test. We know where it fits in, when it fits in, why it fits in, and how all the other things around it. So what are the steps to actually finding bugs in whatever you can imagine, whatever it is, whatever you're interested in, whether it's a mobile application or a web application or a kernel or a Microsoft binary like Office or a car or an HVAC controller, whatever it is, these are the steps in my mind, especially from kind of more of a consulting perspective as far as how you do that. So step one is scoping. And this is where you sit down with the customer and you basically talk to them about, what part of their thing do they want tested, like what's the scope, what's the budget, how much of this do you want done, and how many bugs do you want to find? This is a really interesting thing that a lot of buyers of pen tests, they don't know this. They haven't been briefed on this. They don't get this, and we have to kind of re-explain this over and over again, which is this point. They'll be like, well, we really just want to see what a hacker can do. So, we're going to let you hack our thing. Okay, good. It's good. It's a good thought to start with. But if, for example, let's say it's a web app, and you just give us a URL. Or an IP address. That's fine. We can try to hack that just with that. There's lots of ways we can do that, right? We'll open source intelligence. Maybe we can find creds. Maybe we can brute force creds. Maybe there's some vulnerability that's even pre-authentication that we could find without login credentials and stuff like that. So could we hack it? Yes, probably. Maybe. It depends, right, on how well the app's written, and it depends on a lot of things. But in my opinion, it would be better to have that test. So that's what's called a black box test, right? You're given, as testers, you're giving very little information about the target. It would be smarter, in my case, in my opinion, for the system owner to give you more data than that. It would be smarter for them to share their source code, to share login credentials, not just for a non-privileged user, but also for, a lot of systems have lots of different login levels, right? Like there's student, and there's admin, and there's teacher, and there's principal, or whatever it is, right? There's all these different privilege levels. Based on your role in the organization, you get to see different data in the database and perform different, you can add grades versus just see your grades, or whatever it is, right? It would be smarter to give your security testers not only all the different logins for each level, but credentials and source code, and maybe even some sort of debug hook to the system itself. Why? Because that's cheating, right? Is that cheating? So what are they going to hack if they already have the admin credentials? How do you know what they can do as a hacker? Isn't that, I have to explain this a lot to customers, so I want to explain this to you. It's not cheating. It basically allows us to find vulnerabilities faster, right? So we can run the source code through static analysis tools and find bugs that way. We can run the binaries through dynamic analysis tools and find bugs that way. We can log in as an admin so that when we try the unprivileged users, we can see the logs to see what our attempts at doing this, that, and the other thing are having on the system. So it just basically enables us to do our job better. And so that mindset of that's cheating versus no, that's actually helping them do their job, we fight this all the time. And I haven't yet found a way to effectively explain that. I'm still trying. So if you can help me explain that, please, maybe send me an email or something, because I think there's still a lot of customers that when I try to explain that, they're like, yeah, but we just want to see what a hacker can do. It's like we're back to square one every time. And it's like, okay, well, that's fine. We'll do that. We'll definitely do that. Well, if you want to hire us to do a black box pen test, that's great. We'll do that. It's not a problem. It's just at the end of it, you'll find we'll have 4 bugs for you instead of 20, right? And so you kind of get to pick how many bugs do you want. Maybe you don't want 20 bugs. Maybe you only want 4 bugs. That's fine. Some don't, right? If there's a first pen test, it's too much all at once. That's fine. That's okay. And just so you don't think I'm making all that up, there's actually research behind that. The BSIM document actually talks about that. So they have sort of these levels of maturity, right? So level 2 is where you decide to share more information with the pen testers. Oh, that's interesting, right? So as you kind of go up the maturity, the organizational maturity chart, you figure that out, is what happens. So you can read about that. I won't rant too much more about that, because we don't really care. We're happy. It's actually sometimes more fun to do a total black box test. We're not opposed to doing it that way. It's just you get a different level of result. Okay, so that's step 0. And good luck with that, right? That's the hardest part probably, is explaining all that to a potential buyer. Step one is the actual system investigation. And this is where you have to sort of learn the system. And as pen testers, this is really a very fun, very time crunch, very tricky, high pace, sort of activity where, you've just been given a, 2-week engagement to hack an ATM. Cool, sounds like a lot of fun, but I don't know anything about ATMs. So you have to all of a sudden learn an entire industry's worth of knowledge in a very compressed, and hopefully you have some knowledge of that industry, right? Otherwise, it's probably too much to learn in that short of a time frame. But basically, you get the idea that you have to become an expert or a relative expert in very niche fields in many cases. So if they shared any design notes or sort of engineering information or whatever, great. If they didn't, that's okay. We'll go and find it. We can usually find a lot of that on the internet, PDF, specifications, you name it. Functionality, what's the product do? How does it work? What are the APIs? What does it interact with? Does it interact with a website or a mobile app? Or how does it all work? What's in scope? Maybe not all of that's in scope. Maybe just the device is in scope, but not the APIs or the web or the mobile app. Or they just want a certain thing tested now, and they'll test the other parts later. That's okay. We run into that a lot. So what's in scope? How does it work? And what are the tools that we're going to use to help us do our job? Because what's interesting is that this field is such a fast-paced field that auditing Ruby code last year is different than auditing Ruby code this year. We just found a static analysis tool called Brakeman, for example. I don't know if you guys have ever seen that. It's an open source product. You can find it on GitHub. It's called Brakeman. You can use it to audit Ruby code. But it's pretty new, relatively. And so basically, every time you do a security test, it's a matter of, hey, let me go see what new tools are out there. Let me go see if somebody else has a cool new open source tool, or if there's a commercial tool we can get or afford or whatever. Let me go and check that out, because that could be really useful. Okay, and then obviously it depends on, again, what you have access to. Do you have the binaries? Do you have the code? Is it just attack surface? All of that matters a lot in terms of what tools and techniques and procedures, TTPs, you can actually bring to bear on the engagement. Is social engineering allowed, for example? That changes the whole thing. If it is, maybe you can just fish the admin first creds and log in with those. Or everything depends on what's in scope and what's not. Uh-oh. So keep digging. Find technician passwords, find engineering files, find open source data, find CVEs that are already out for the product. Maybe there's known vulnerabilities that are out there that the product owner doesn't even realize. Look for lost credentials and breach data. Find key staff on LinkedIn. So all of this is sort of OSINT, open source intelligence gathering, right? It's all really important. Learn the domain knowledge. Enterprise, application, auto, ATM, building controller, medical, military, IoT embedded. Each one of these spaces, while the sort of overall approach is the same, how you do it and how you talk to the customer is very different. You can't talk to a hospital administrator the same way you would talk to a military officer in many cases, right? A lot of times the things that they're interested in or concerned about, one wants to hear about how do we keep our patients safe, the other wants to talk about cyber operations, right? They're very different mindsets. And so being sensitive to that's really important. So for example, safety is really important to HVAC, medical, auto, where money and physical is very important to the financial sector. Weaponization of cyber tools is very important to defense. So those are just some of the sort of tips on domain-specific concerns that are interesting to which folks. Okay, so finally we get to this diagram. We started with this diagram at the beginning of the talk just to kind of whet your appetite, and now we talk about it a little bit more. So you've got the investigation, that's what we just did, and now you're going to move into trying to actually find vulnerabilities outside of it. You might actually find vulnerabilities just in the investigation. Just by reading the design docs, it's like, oh, this system doesn't have a password. It says right in the design doc. Okay, cool, found a vulnerability, right? But most systems aren't quite that easy to hack, some are. But so you go into this next steps. So automated tooling on the code or the binary, so static analysis. Runtime tools, dynamic analysis on the attack surface, right? So one's running against either the binary or the code, and run is where you're touching the application as it runs at its points where you try to log in or whatever. And then manual hacking could be kind of a combination of all those, where you're either auditing the code manually or you're intercepting like web traffic with burp and you're changing requests kind of manually based on, oh, I wonder if I change this little thing here. We find those kind of vulnerabilities a lot. For example, you see a long URL and there's a number at the end. Just change that number. And it's like, oh, I'm looking at somebody else's W2 instead of mine. Interesting. That's called an IDOR. That's the name of that vulnerability, indirect object reference, whatever. So there's lots of different kinds of vulnerabilities you have to learn about, but we see all kinds of different, and there's different techniques for trying to sort of ferret out all those different kinds of vulnerabilities. And then probably one of the more important parts is that final step of explaining the impact to the system owner. So that either, maybe they get really excited about a proof of concept exploit. Maybe they get really excited when you show them a picture of their own inbox because you were in their email. That scares them, usually. That works. Whatever it is. And a lot of times it's really cool to do a little bit of that if it was in scope and it was allowed. Obviously, don't do anything unethical outside of the bounds of your test. But if that was allowed as part of the test, those pictures are worth 1,000 words when you show them to senior leadership, administrators, things like that, that maybe when you talk about if you blah, 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 ASLR, blah, 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 like they don't get any of that. But if you show them a picture of their inbox, they're like, woo, that's my inbox. They get really excited about that. They get really scared by that. And that can be helpful to driving the program forward, to getting the budget, to getting the things you need to actually make an impact, to make a difference. Okay, so I talked a little bit about this, but I just want to revisit it again so that you know. Again, the specifics of your system dictate which TTPs, which tools, which techniques, which procedures. So for example, if you're auditing unmanaged code, you're probably looking for maybe buffer overflows or stuff in between that applies to both, like authentication bypass, command injection, weak crypto. Where if you're auditing managed or web code, you're probably looking for OWASP top 10. What's OWASP top 10? Well, it's changed throughout the years. There's a new version in 2017, but it's basically things like injection, whether it's SQLI, SQL injection, or command injection, broken authentication where you can kind of get to a page that you're just not supposed to be able to get to because you haven't logged in yet, stuff like that. We see a lot of those kind of web vulns yet. We see every kind of crazy vulnerability you could imagine when we do pen testing, right? Everything from they accidentally posted creds online publicly to really complicated technical things and everything in between. A lot of the typical like cross-site scripting and CSRF and all the sort of web vulns, those are all OS top 10s. So we see all those. And so, just to give, throughout this, I've got some kind of random screenshots sort of sprinkled throughout the talk, just so that you can actually see some of the tools, so it's not just me talking just strategy and high level. I like to do that for a keynote, but I want to give you some pictures too. This is, for example, using a tool called JetBrains decompiler to take what was a C# executable, so a DLL or an EXE, right back to source code. Because again, even though it's a EXE or a DLL, it's in sort of that half-compiled format. So it's pretty easy in most cases, unless they've intentionally obfuscated it, to take it back to code. Well, now that you've taken it back to code, what do you do with that? Well, it's just a lot easier to audit, right? You could run it through a code analysis tool. You can read the code to see if maybe they just have some, who knows what kind of vulnerabilities, right? Maybe there's hard-coded creds, or they, their keying algorithm is no good, so you can break that, whatever. Where if it were C and C++, maybe you'd need IDAPRO, or Binary Ninja's another one. You might actually have to read the assembly. That's less fun, but you can still audit code that way. Okay, so now we're finally to step 2, static analysis tools. What are some of the static analysis approaches? You've heard the term, but what does it really mean? What are some of the actual tools? And I'll talk about those. First of all, what are some of the pros and cons? The pro is that it can work across the entire code base, right? So if you can run a static analysis tool, like, there's kind of 2 categories. One is more broad against the binary itself, so software composition analysis, SCA. That's where you're looking at the software as a composed food item. Like, here's a hamburger. Well, what's in the hamburger? Well, it's got 20 proteins and 30 carbs and 40 sugars or whatever. That's the composition of the software, right? Okay, and you can break that down and go, well, this third-party library, you're using, whatever, an old version of whatever, libc or something that's part of that software, and there's a known vulnerability in there. So you've got, just by doing SCA, we know that you've got potentially up to 200 vulnerabilities before we even start. And I'll show you a picture of that. That's the easiest one to run because it's pretty easy to identify the versions of products inside of a product. So it's fairly, and it's not real exact. So it can be an interesting discussion with developers. They may say, well, we don't really use that part of that product. Yes, we include this old version of XML edit or whatever, but we don't actually do the XML editing or something. So you're like, okay, well, so you're kind of theoretically vulnerable to it, but in practice, nobody could exploit your product with that vulnerability. so that you can get into weird discussions, but it's like, well, why don't you just update the version of that or ditch it altogether, and then we won't have to have that discussion, right? So that's what I really want to get across to developers. Instead of having the argument about whether it's vulnerable or not, I'd rather just have that finding not show up in the tool because they either upgraded it or ditch it. And the other thing that's interesting about static is you can run a tool like, say, Coverity or Fortify or other open source tools against your whole code base. So it gives you kind of a breadth look at your product. But there will be some, in some cases, quite a few sort of uninteresting or false positive findings associated with that. So that's kind of bad, right? Because if you give your developer, you're like, hey, Mr. Developer, I ran this cool new security tool against your product and it found 1,000 vulnerabilities. Wow. And you give it to the developer and they sit down and they go, they spend 8 hours looking through your findings and they go, not one of those was real. They were all like some kind of false positive thing that didn't, your tool is killing me and you are killing me. Don't ever talk to me again, right? So you can actually irritate your developers a lot by doing that. So you have to be really careful about how you do that. If you're going to sort of start a new security strategy push in your company, you need to kind of know a little bit about that before you put all those in front of whoever owns that system so that you're not giving them rubbish, because you might turn them off and they might not want to work with you again. And remember, we work with people, humans, ultimately, right? Not just computers. So you have to maintain good relationships with the people you work with. So that's really important. Okay, so talk to me about some specific tools in that space. Commercial tools, like I said, Veracode, Synopsys, lots of open source ones. I'll show you some pictures. I got to keep moving because I'm starting to run out of time a little bit. Here's an SCA tool. So let me just show you a picture of an SCA tool. This is one called Protocode by Synopsys, and I actually like it a lot. I like the way this tool displays its results. So this was from a Wi-Fi router firmware binary. You just put it in their tool. It's a cloud service, and then it spits out, oh, look, your product has 573 vulnerabilities, which probably it doesn't have that many, right? Because, again, it probably doesn't use, so the Linux kernel is old, and Coverity says that it has 366 vulnerabilities just based on the fact that it uses an old Linux kernel. You probably, as an attacker, can't actually exploit that wireless router 366 different ways, right? Because not all of those vulnerabilities are exposed remotely. Maybe some would only be exposed to local users or only if you had this type of situation or that type of situation. But it does give you an interesting metric, and metric's really important in security because we struggle with metrics in security. Because one day, your finance person is going to come to you and they're going to say, hey, we're really excited about security just like you are, but explain to me again why you need $1 million budget for your security program, because I'm not feeling that, right? And you're going to have to justify your program to your finance people at some point. And it's going to be really hard to do. You're going to go, well, I went to Dakotacon, and there was this really cool guy named Dr. DeMont, and he gave this really great talk, and that's why we need $1 million budget. And they're going to go, I need a little more than that. I need some, data, some metrics. I need to see some return on this investment, right? I need to see something. And so that's where these kind of metrics can help you. How do they help you? Well, let's say you run this tool every time you have a new release. So you can do it on a CI, a continuous integration basis, and you see that over time, over the last year, every time we've released a version of our product, it's actually gotten worse. And I've seen that in products. It's not getting better over time. It's actually, we have more, now how many are exploitable and blah, blah, blah. But metrics, just pure metrics-wise, it looks like we're not improving. So we need to spend a little more. So you can use some of that as part of your budget justification. Okay. This is a different tool. This is Veracode's version of how they show SCA to you. Different vulnerabilities, like there's a high vulnerability in this Spring Web Java jar file, for example. So they display it in a slightly different way. In general, I actually like Veracode a little better than Synopsys. I'm not supposed to save enter stuff, but I actually like Synopsys' version of their SCA better than Veracode. So what you find is that each product will have one piece of the product that I like this little bit of this thing better than this little bit in this thing. So it's kind of, anyway, not really, I don't know. Am I supposed to talk about other stuff? Maybe I shouldn't. So, like I said, there's also a lot of open source stuff. So, for example, if your project is Ruby, check out Breakman. You'd have to Google to find that. If it's .NET and you have the code, there's some open source .NET plugins that you can install inside of Visual Studio. Now, if they didn't give you the code, guess what? You can't do that, right? And so this is what I was trying to explain at the very beginning of the talk when you talk about scoping with your customer. What they give you determines what you're able to do. Right? Because if they didn't give you the code, you can't do this part, and that's okay. right? So you're not going to find bugs in the static analysis phase because they didn't give you the code or the binaries. Okay, fair enough. So then you move on. What do you do then? Do you panic and all is lost? No, you're probably still going to find vulnerabilities if you know what you're doing. You're just going to have to use dynamic analysis. You're going to have to use manual analysis. You're going to have to use different techniques. So this is a view of the inside of Veracode when it's found vulnerabilities and how it reports them to you and talks about them and stuff. I won't go through this really in detail now. It's too much to go through, but I just wanted to give you some screenshots versus Coverity. This is a synopsis tool. They both have their pros and cons as far as how they work. I'll kind of leave it at that. If you want to know more about the pros and cons, I'm happy to talk to you about it. I think they're both great tools, and so I don't want to give a big on pitch on either one. This is one of those open source tools. When you actually do a code analysis, if you have the code inside of Visual Studio, it'll give you like a little warning saying, hey, I think the hashing algorithm's not very good there. So what you find is when it comes to static analysis, code analysis tool, the free and open source ones aren't nearly as good as the commercial ones that you pay for. Go figure, right? So it is what it is there. But they're still better than nothing. Okay, so suppose they didn't give you any code and you can't do static analysis. What do you do? I know I'm running out of time. Dynamic analysis. Well, how does dynamic analysis work? It's basically where you get to touch, yeah. What's it? Oh, thanks, man. You're going to give me 5 minutes of your talk time? 10 even. That's generous. Okay, well, we'll see if I need it, but I appreciate that. I try not to ever do that to other speakers because I've had speakers do that to me and they start you like 10 minutes late and it's just super annoying. So I appreciate that, though. He's offered to give me a little bit of his talk slot next, but I'll just kind of keep moving and see where it ends up. So in terms of dynamic analysis, one of the pros is that there's less false positives, right? So if I can log into this system and actually twiddle this bit and get some data back from the database, that's a real vulnerability. There's not much chance that that's a false positive. Maybe there is some chance if I'm like, I accidentally am testing their test system and I thought it was production, or like there are some complications that could potentially, change that. But in general, the bugs you find are real. And we see that whether it's fuzzing on native code or we see that whether it's more managed, whether it's web code or mobile apps. If you can actually exercise a vulnerability, it's probably a real vulnerability. So that's good. That's a pro. The con, and this again goes back to what I was saying earlier, is that you have black box visibility instead of white box or gray box. It's gray's in the middle, white's like they gave you code, gray's like they kind of gave you some stuff but not all of it, and black's like they didn't give you any code. So you could also call it like maybe red, blue, and purple, or you could use different colors if that makes you happier, but it's that sense of how much data they give you. So you're only able to touch the attack surface. You're not able to go as deep with your analysis, and that's fine. You can still find lots of good bugs. So this is a tool called Arachne, which is a free and open source web scanner. So if you're like, hey, I want to scan this website for vulnerabilities, but I can't afford XYZ commercial tool, that's fine. There are some open source tools. Most of them are, but this one's not bad. We've used Arachne before, and it's found vulnerabilities for us. In fact, what we find, and this is true of all tools, is that using a plethora of tools is better than just one, right? So try that commercial tool if you have access to it, but then try this too anyway, right? And what you'll find is that, the commercial tool may find 5 vulnerabilities, and this only finds 1, but it found one that the commercial tool didn't find. How's that possible? It's just the way our field works, right? Because ultimately, testing is sort of what we call NP hard or incomplete. Like you really can't provably test something to be totally secure. So it's not surprising to us that different TTPs find different vulnerabilities. So, okay, that's Arachne, and this is a little bit of what their interface looks like. It's not a very good, my pictures really aren't showing up all that clear, but you get the idea that it'll display some results to you. This could be true in fuzzing too. So if you're dealing with native code, the testing process is very different. Right? So you're going to be using, for dynamic instrumentation, you're going to be using a technique called fuzzing. And one of the most modern feedback fuzzers out there is called AFL. And I don't really have time to give a whole long lecture on fuzzing. Although I did bring one copy of the second edition of our fuzzing book that just came out. I'm going to give it away to a student in my class. So we'll have a little bit more discussion about fuzzing in the class if you take my training this weekend. But basically, long story short, it's kind of an interesting way to exercise inputs. So again, it's attack surface oriented, looking for crashes to find vulnerabilities in native, fully compiled code. So that's about all the time I have to talk about fuzzing for now. And it's really interesting, and this is what their interface looks like if you actually run AFL, the American Fuzzy Lop. It's named after a rabbit. It's kind of funny. It gives you some data about, sort of how deep it's able to instrument the binary that it's continually sending new and changed inputs to based on the code coverage feedback that it receives, and continues to submit new inputs to it. So really interesting stuff. So we've talked about all the different steps so far of the 6, right? From scoping to investigation to static to dynamic. Now what about manual hacking? What does that mean? How's that different than the other steps? Well, they're all kind of related. They all inform each other. You do all of these cyclically. It's not like you just do, hey, I just did this one and now I'm done, and now I'm going to do this other, and now I'm going to do. A lot of times you do one and you go, I have an idea. Let me go try this manually. Let me go run the static analysis again now that I know this thing, right? And so it's this loop that you're constantly cycling as you travel back and forth to find vulnerabilities. Okay, so manual hacking, talk about what that could be like. It could be code review if you have the code. It could be reverse engineering if you only have the binaries. It could be, based on anything you found so far. It could be more of, let me craft this particular message. Let me craft this particular tool. Let me manually create a tool that helps me do some automated analysis. Sometimes we've had to do that if we've come across like custom protocols that we didn't have a fuzzer for. We actually quick would write one in Python using Scapy, if you guys have ever heard of that. That's one you can create random packets and stuff. So you can kind of mix the idea of sort of, I have this manual hacking idea that I'm going to put into a tool to launch a bunch of tests, kind of blending these ideas. They don't need to be sort of completely separate and disparate. They all work together. And one of the most common that you'll run into when it comes to web hacking is something called Burp. You can download Burp Community for free. It's really useful. If you do any kind of pen testing at all, you probably already used this before. It's super useful for, basically it lets you man in the middle your communications between your browser and the website. So you send the session and you kind of pause it and you're like, okay, here's the cookie, here's the username, here's this, here's that, here's this. Oh, what if I change this? Now let the request go, and I'll see, I get a different response than what I got before. So it allows you to kind of do this sort of, it does have some automated techniques into it. So Burp's a really interesting tool in that it's kind of the web hacking tool in a box, so to speak. It's got dynamic abilities to sort of spray passwords and do like automated testing, but it also allows you to do that very manual, investigative testing. Excuse me. It could be more of this. This is just plain old code review, right? I'm going to look at the code and look for vulnerabilities manually. That works great, particularly if you have a fairly limited scope, if the code's not too huge, or if you kind of have some idea where you want to start looking. If they gave you 1,000,000 lines of code and they're like, hey, manually audit, this 1,000,000 lines of C or C++, you're just going to die trying, right? Because it's, reading C and C++ and C is not that much better than reading assembly. It's pretty hard to read a lot of it, especially if it's really complex and across all these different classes and files and structures. And it's non-trivial, to be sure. And again, that's why what? Well, that's why there's still vulnerabilities everywhere in the world, because all of these things we're talking about help, but none of them really get you all the way. They're all just sort of arrows in your quiver that you're going to kind of shoot at this target, trying to shake out as many things as you can. Might be IDA Pro, reverse engineering. Could be a lot of different things. So those are all sort of the activities that are involved in manual hacking. And then once you've done that, and hopefully you found some vulnerabilities. If you're doing a pen test and you never find vulnerabilities on any of the pen tests you do, maybe it's not your calling, right? Because we find vulnerabilities all the time in every pen test we do. So you should have some finding probably, maybe not in every test, maybe something super secure or whatever, but in general, you should have some reasonable findings. So this is your chance in this final step to sort of put this, well, it's not the final, reporting is the 6th and final step. But step 5, your chance to kind of package this in a way that shows impact, rather than just going, cross-site history, blah, 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 DEP, ASLR, blah, blah. If you just kind of ramble technical terms in front of the business stakeholders, they won't understand what you're talking about, right? You need to kind of get this in front of them in a way that makes sense. So why do you spend time on this? Again, it's to help you help the CEO or whoever's actually controls the budget get it. So it could be something like this, like if you found a command injection vulnerability, it could be just sort of a simple hack where you're supposed to be able to enter an IP address, and all of a sudden you put in, backtick or semicolon ping IP address, and you're getting ping results back when you're supposed to be, or it could be, you put in, I don't know, whatever, you put in this long command injection string and you get a shell on a system, and from there you were able to use responder and become DA and dump the whole thing and then dump all their hashes, and it's like, here's your password. How did you get my password? Well, and you can talk about this long sequence of events that took place because of an initial, vulnerability vector that led to this, that led to this, that led to this, to led to you showing him a picture of his inbox, right? So that can be very effective. Or something like this, the open cameras view. This is from an open camera that we had actually captured off the internet. And I don't know, maybe we shouldn't have, but anyway, we did. And it's a picture of like, here's open cameras on the internet. This is an actual jewelry store. This was an actual person running a transaction that we captured. So should we have done that? I don't know. Well, it proves the point, right? It raises eyebrows. People go, oh crap, that's a real problem. Maybe somebody should address that problem, right? It helps people understand the problem. And that's one of the interesting things in our field is it's super important to be very ethical in all things we do, hacking, but sometimes we have to push that just a little bit, right? Because if you don't push it a little bit, people don't get it. They're like, yeah, I know there's vulnerabilities that need mitigation, and it's like they kind of get it, but you kind of have to help them get it just a little, within ethical bounds, please. This is another one that's very effective. If you find a SQL injection vulnerability, if you can dump all of the teachers' pay or some out of the system, or all of the students' social security numbers, and you show that to them, like, hey, we were able to get to the system, and here's 100,000 SSNs from all your students or something, and they go, that's really bad. What do we do? And then this is your chance to help them figure out what do we do. So in the reporting, you get to put together hopefully a concise, meaningful report that has all your findings, all your remediations, so findings that are ordered, remediations that make sense, remediations that are hopefully within their budget or their means to be able to achieve, so that you can actually help make the world a little safer. That's why we're here, right? We all want to make everything a little bit safer. So you sit down with a customer, either remotely or in person, and you talk about all these different things. Like, this is what a SQL injection vulnerability is, and this is how you prevent them. You use these kind of parameterized queries, and this is how your developers maybe could not just fix this bug, but maybe they could fix all of those types of bugs across all their products by using this type of function when they code early on, or whatever it is, right? So hopefully, and this is why I said security's kind of hard, right? Why is security hard? Well, security's hard because it's not like you have to just be a developer of Java or whatever, right? You have to actually know enough about all of that to be able to give wisdom to the technical people who make the products in Java, right? So you kind of have to be an expert of expert domains almost to be really effective in cyber. And I think that's one of the real challenges of our field. I think that's why it's so hard to find people in our field that are really good at what they do and really know what they do, because who has that background to be able to speak to a CEO, to be able to speak to a developer, to be able to speak to a network architect, to be able to speak to an endpoint engineer, right? It's a tall order, but it's the calling that we have in this field, and I'm really excited about it. I love it. And I don't ever present it to them as bad news, like, hey, you guys are just terrible. Oh my God. I always present it to them as, here's some opportunities for improvement, right? This is how we get to the next level. And so that's kind of my approach to putting those findings forward. So I almost finished on time. I only took 2 minutes of your time. Sorry. So security's hard. Your products are at risk. So is your network. So are your users. So is their data. And it's not just me making that up, right? We see it every day in the news when yet another company gets breached. So how do we do better? Well, all the things that I just talked about. So if you have questions, if you have concerns, feedback, please hit me up on email or whatever it is. I guess I don't really have time for questions. I don't really want to steal any more of his time, but thank you for coming.
right, expecting lots of questions. Questions from everybody. Huh? Tired. I think I finished at like 4. Got up at like 7. Yeah. This is my laptop. So my laptop at like 4, I'm finishing up working, and the fucking hinge on the left side breaks. So like the LCD's hanging right now, like one wire. I'm like, please make it through CCDC. I'm gonna have to go to like some shit store and buy a laptop today just to do a competition. So, no, I have this ThinkPad protection, but who's gonna come to freaking Madison in like 8 hours to fix the display? It'll probably take like 3 days to get here. So, we'll see. All right, I guess we'll get started. Mine's not that long. It's like 30 minutes. Check, check, check. Quiet. Should we get started? Yeah? No? Hang out for a little bit? All right, mine's not too long, so I typically give talks on pen testing and techniques and tools and philosophy sometimes and things like that. What I thought might be relevant more this year, since I've been coming here for a number of years and presenting, is a lot of times there's students in here that haven't graduated yet. There's also participants that are in CCDC this weekend that may come here. And so as I started thinking about where I was at that stage in my life a long time ago, and kind of the path that I've taken to get to where I am in my career, I wanted to try and put some pros and cons and kind of some career advice into some things that I've seen along the way to get to where I'm at and my peers are at, but as well as some of the struggles I see either in the industry or as we're trying to hire, and we're hiring a much different generation now because obviously, you can't always hire 20-year veterans. Some of the pitfalls I've seen along the way and kind of some of the gaps, as well as preparing some of you guys that maybe haven't graduated or are just now getting ready to graduate into this industry, and maybe some tips that will help you kind of steer you along the way. So just for my own reference, how many are still in school or about to graduate and go off into the workforce? Awesome. So the talk isn't terribly long, which is why I told Jared he could run longer if he wanted to. I really want to leave it open at the end to not only have questions from you guys, but also some of the others that may be here, vendors or speakers that may be going through some of the same struggles that we go through a lot of times when we're trying to hire into a younger generation and younger workforce, some of the things we've seen along the way that become frustrating or become challenges. So definitely want to keep it open, for questions at the end. So as we're going, if there's something you think about that you want to talk about, we're going to have time at the end for sure. So a little about me. I was able to co-found Lars Consulting with a good friend of mine about 10 years ago now. Prior to that, I kind of had a mixture of positions along the way, starting out doing consulting about 20 years ago, and started in more the telecom space and moved up to IT security and InfoSec industry about 15 years ago. So there's a number of different types of services that we've done within our company, as well as what I've done along the way, but really a primary focus in penetration testing, social engineering, and what we consider red team testing, which is really blended threat testing of physical, social, electronic, and anything we can use to combine all those into driving impact in the company. So what was my motivation for this talk? There's mostly just the why are we here and what has happened along the way. I think more of the drivers behind that as I get older and I feel like I'm one of the old dogs in the industry now. It becomes a bit jaded. So as we start dealing with the younger generation, and we start dealing with maybe the way that they are moving into the industry versus how we kind of had to fight to get into the industry, there's a lot more opportunities now, but it's also a much different industry. When people my age were, and just so you guys think I'm not 60, I'm in my 40s, so I feel like I'm definitely an age gap different than some of you guys that are graduating and going into this space now. But when we were fighting to get into this space, the information that's available now wasn't readily available. It was really driving BBSs and getting into private forums and trying to share as much as possible online, but the availability of those places was much smaller than they are today. So you've got this information abundance now to go out and watch a video and become an expert right away, right? And so when we were trying to get into different technologies or different spaces or learn new techniques, there was a lot more of finding the information, which took a long time before we were even able to go learn about that piece of technology or what we were trying to become experts at. So keep that in mind when you're beginning to progress into a different direction, whether it may be pen testing or consulting or forensics or DevOps or coding or whatever it may be. The information is much more readily available now, and so it's much easier to fall prey to some of the things that we'll talk about in the talk, which is becoming a subject matter expert right away. And so it's definitely been a big difference that I've seen when we're speaking to younger generations now about job opportunities or training them or trying to educate them in certain ways so they become better in their position. The availability of information for them and for us as a whole is much more readily available than where it was 20 years ago. And much of that is just because the internet is much different now, right? So, one thing that I like to kind of remind myself of is, the information and the I guess the life lessons, if you will, that we kind of went through to get to this point. I didn't really have those available when we were starting out. So it was kind of trial by fire and a lot of times learning by mistakes. And so I feel like the 80s and 90s when we were getting into this space was obviously a great time because looking back now and seeing the evolution of where it started and how fast it's progressed to where it is now, and then seeing how fast things change year over year versus waiting 5 or 10 years to see innovation and technology changes. It's daily at this point. So certainly respect the time that I grew up and got into the space in the 80s and 90s, but the times are different now and the space is different and the industry is different. So I think as I look at the industry as a whole, one of the jokes we often make when we're looking at hiring new talent, and we're always looking for new talent, is the mindset now that when we look and say, well, it took me 3 years of being a firewall administrator and really understanding protocols and understanding things at a packet layer and understanding technologies that are involved in that space. You guys have a much wider array of technology and environments now, whereas smaller environments or older environments may have only had 1 or 2 pieces of technology. Now, just in the security space alone, if you look at, like Jared was saying, the Gartner Magic Quadrants and things like that, the abundance of technology and the information you have available to yourself is much more broad than, say, where it was 20, 30 years ago. So that's kind of what sourced some of these topics in the conversation. So as I started going through my career and going through different positions, whether it was IT related or security related, I was lucky enough about 10 years ago to really fall into a position and start a company that was more of a hobby for me. And so you always hear the analogy of if you're not doing what you love, then it's not what you really love to do. It's not your career. It's just a job. And I was lucky enough to take my passion of InfoSec and pen testing and red team testing and all those things and actually create a company and get paid to do what I love to do. So as you're starting to begin looking for positions in this industry, really think about, is this something that's going to advance you where you want to go? What are you going to get out of the position? Is it something that you really love to do? One thing that I hate seeing is someone taking a position just to have the name on the resume or just to have a year of experience, and then they can, further improve their salary and things like that. Like, if you're hard up for cash, you need a job, that's one thing. But if you have an opportunity to really go and pursue what you're passionate about, it's not always about money. And along the way, I took a number of positions that may have been a pay cut just to do what I wanted to do versus making, $10,000, $20,000, $30,000 more somewhere else and being, hating my job. So it's much more, looking back now, I didn't think about it at the time, but it's much more gratifying now to wake up and actually want to go to work and want to do my job, or don't mind spending 15, 16, 18-hour days working sometimes because it's actually what I love to do. So when we were growing up, there was all these things that we were kind of being exposed to in the media, and anyone that's either looked in the Wayback Machine and looked at old YouTube videos or seen old commercials and kind of laughed at them, like the VH1 back in the 80s or whatever. We had this huge amount of information being thrown at us about, just say no to drugs, say no to, scary strangers in the park that are offering you candy, and, all these different things, and kind of the after-school specials that were trying to teach us what was bad. But there was really nothing that taught us these things in the industry. It was all around drugs or, diseases in the world or, strangers and things like that. But there was really no focus on what I should say no to and what I should not do in the industry. It was all about my personal side of life. And so, all of a sudden you're in this position where it's like, all right, I have all these negative connotations of the world and I don't know where to go and what to, stay away from. But, everyone was kind of confused in the InfoSec space and IT industry of, really what do I do and what do I not do? Because it was so easy to flock to a certain direction and follow someone else, or jump on the coattails and just do it because someone else is doing it. So it's the whole kind of peer pressure thing, right? And so there was really no direction on what I should do and what I should focus on in my career. It was kind of, choose your own adventure style. So I felt like creating some of these tips in the industry for today is beneficial because no one ever really gave these tips to me when I was coming up, and I'm sure a lot of you guys that have been in the space for a bit of time now didn't have the same either. So the first one really is the bandwagon piece, and I see this a lot in our space because it's very easy for someone to jump on a message or a hashtag troll or something that's trending or whatever it may be to build their own posture, build their own name, build their own brand because they want more Twitter followers, or they want to have a name in this little space they're in, and so it's very easy to become a voice because someone else is already speaking about it. So you have this whole bandwagon mentality in our industry where it's easy to flock in that direction. Unfortunately, what a lot of people didn't realize years ago, and they're still paying the price for it, is our industry really kind of maintains a rap sheet, if you will, because these first impressions, whether it's your first time speaking on stage, it's your first time presenting, it's your first time releasing something on your private GitHub, all these things kind of became your first impression and your first introduction to the industry. And unfortunately, those things stick, and that's really what people remember is, oh, I remember the time, so-and-so was at a conference speaking and, afterwards got trashed at the bar and, showed their tail, and all of a sudden, that's what people remember about that person. And so if you've been in this industry for a bit of time and you've followed some people, you've probably seen some of those and you're like, man, I can't believe they did that. Like, that's what you stick with. And so the whole idea of these first impressions last, it not only applies in that personal side of your life, but in InfoSec, especially in the days of the internet now, whatever you do is permanent. Whether you take something down or delete it or whatever, someone likely has a log of it, someone likely already took a screenshot, and someone's probably putting it in their pocket waiting to out you on it later on. And that's just, unfortunately, the world we live in now with, all of the Me Too types things of, oh yeah, that happened too, I'm going to jump on that. So be careful what bandwagons you jump into, because a lot of those, just by associating yourself with them, these movements and things like that, will definitely put a brand on you that's very difficult to overcome in your career. So, keep those things in mind as you're flocking into these crowds and kind of, the whole peer pressure mentality, right? If everyone else is doing it, it's okay for me to do it. And that isn't always the case in our industry. So, I think my biggest tip here is really pick your friends and pick your peers and pick your coworkers selectively, because guilty by association and associating yourself with a brand or a movement could be damaging to your career for a number of years, and then you're spending time just trying to repair that. You guys know this one well coming out of college. Love that picture. So our industry has really developed this kind of mentality of, if someone else already wrote it, I can easily go grab this thing, make some tweaks to it, and kind of call it my own, and then jump to my blog and talk about it, and show the same thing that it's probably out there 100 other ways. Jared kind of mentioned Responder earlier. It's one of the tools that's used in our industry, and if you went and searched Responder right now, you'd find 100 different blog entries of all telling you the same thing of, this is how I use Responder to grab a hash and then compromise a system, and now I'm domain admin, and ooh, I'm stunt hacking. And so it's all, most of those aren't necessarily driven to provide information to you so that you become better in your career. It's really self-centered and selfishly motivated of, I want to get my name out there so that people come to my blog, or people know my Twitter handle now, and all of a sudden I'm standing on the shoulder of someone else just to get my voice heard. And so this happens a lot in our industry, and it's something that you have to be really careful about. We always kind of make the saying that shout-outs go a long way, and they really do. You'll get much more respect in the industry and much more followers if you take the approach of crediting someone because they've done great research, and maybe you want to evolve that a little bit. But give credit where credit is due. And a lot of times we don't see that. We see more of the, I'm going to take someone's code off of GitHub, maybe thread it or optimize it a bit, and now I've got a whole new tool. In reality, you just had it threaded to someone else's tool. So, give credit where credit is due, and pay homage to the people that actually kind of paved the road for you ahead of time and built some of these things, and you'll definitely get a lot more respect in the end, especially if you've been able to give attribution where it's due. Standardization, and what I don't mean here is standardization is great in certain spaces. In InfoSec, becoming a standard and becoming very static in what you do is a big no-no. You have to be very dynamic. You have to think dynamic in these environments, especially in the pen testing space. If you come into an environment and you have a preconceived notion that I'm going to fire this tool, this methodology, and do this same thing every time, you're likely going to miss things. You're also going to be at a position where you're trying to achieve a standard that is repeatable and you're following the same methodology, but at the end of the day, when you get to running out of time on your engagement, you likely missed a number of things because you didn't go into the environment with an open mind going, all right, let me look at everything I can assess. Let me evaluate exactly how this company operates versus coming into it going, well, day one I usually run these tools. Day two I usually do this. Day three I'm this. And by day four I'm out of the company and I'm going home. Jared talked about this one, which is really a big one for me, is don't be afraid to push the envelope. You have to break the mold. You have to be willing to still be ethical, but still push the boundaries. And that's something that we try and drive in all of our engagements is don't worry so much about the finding, worry about the impact. Because at the end of the day, that's what the client really cares about, is what is the impact to the business? Can you impact the brand? Can you impact the bottom line? Is it something you've identified that may be important to a competitor? And all these things really are going to drive value at the end of the day when you're a consultant, is how can you step into an environment and begin to question it day one and go, what exactly is occurring here? And whether you tell me something or I find it on my own, I don't believe it until I validate it. So the whole trust but verify mentality. And really, I think the big one for anyone to remember here is standards are great, especially in the risk space. So if you're looking at PCI or HIPAA or ISO or COBIT or any of these frameworks, if you're going to go into the auditing world, frameworks and regulations and standards are really a starting point. They define what a business should do from the beginning, and then they should progress from there. So if you look at things from a compliance standpoint, we always make the analogy that compliance doesn't equal security, and it's really a proper way to define compliance. Compliance has always been a starting point for a business. It should never be the end-all goal. And so when I say no to standardization, it's really about say no to standardizing yourself and your own methodology, right? Think beyond that, push the envelope as far as you can without going too far out of the bounds of being ethical, but begin to drive impact more versus worry about how many findings you have for your report. This one I always kind of get flack from with people that are heavily focused on automation. In my mind, in pen testing space especially, automation really becomes an efficiency for background noise. So when we step into an engagement, yes, we will use tools and automation to become efficient for certain pieces of an engagement, but by no means are they supposed to be, walk in, push a button, and wait 2 days to get your findings, and then now you've got 500 findings for the report, and you feel like you've done some value for the customer. As Jared said before, you end up with 500 findings. Chances are 80% of them are probably false positives because you're relying on automation too much. And what we see a lot of times in this space is people have become very efficient at using automated tools, whether it's scanners or automated exploit frameworks or any of these things that may make you more efficient. But it also breeds laziness because you rely on the tools, you rely on the output, and you don't really have the understanding of what the tools are doing. So there's no way for you to validate what's coming out of the tool as being a proper finding. I worked for a number of consultancies over the years before I started Laura's, and when I was working at some of those sweatshops, if you will, it was all about how many findings can get into the report. What can we find with scanners? What can we find with automation? How fast can we get to the next phase of the engagement? Because it was all about finishing a project, getting paid, moving on to the next one. And that's really what was driving consultancies and audits and compliance and those things in the beginning. Luckily, that's changing a bit in the industry, and it's really progressing more towards going beyond what compliance drives. But my issue with automation, and it's probably a common issue in a lot of companies, is when we're looking at hiring candidates and we're also leveraging automation within the environment, it does make people become more lazy because they have a mentality that well, someone else did the work for me and automated some of these tasks that I used to do by hand, and so I can just hit the magic easy red button and let automation roll and kind of sit back and wait for the gold to fall out of the sky. And it doesn't always work that way. So the old saying of a fool with a tool is still a fool applies here, right? If you don't understand what the tools are doing, if you don't understand how to validate if they're actually working properly, then you're blind to hitting the button and waiting for it to finish. And so you can't really trust the value of what they're offering. So really become intimately familiar with how these tools are working if you're going to use them. For us, kind of our methodology is use the automated tools, but they become background noise only. And so as you're doing your manual testing, as you're doing validation, as you're doing manual exploitation, or you're working on other pieces, you can come back and see what some of those tools are doing, but really push those to the background and just have them run, because what I try to avoid when we're scoping engagements is I don't like charging clients for, say, running vulnerability scans. To me, vulnerability scans are push a button and it's now background for the next 2 days. If it finds something for me, great, but I'm still going to use my same procedures and my same approach to an environment. And the scanners are just background noise. So unfortunately in our space, a lot of consultancies and a lot of audit shops take the time of, well, if the laptop's running, I'm obviously on the clock. And so we put in 18-hour days because the scanner was running all night. And it's not fair to your clients, it's not fair to the industry, and it's not fair to the ones that are out there grinding and doing manual testing and actually focusing on trying to identify flaws in an environment that tools aren't necessarily finding. So trust but verify everything and really understand how these things are working so that you're not relying only on the tools. So this one's kind of cool because I feel like the experimentation, and not so much experimentation there, but experimentation in trying to do this experimental research, right? Looking at something and going, I don't believe it's working that way. I'm going to question it all the way down to the end where I'm proved wrong. That's really what drives innovation in our space, and that's really what has evolved a lot of tools and a lot of procedures and approaches, is someone questioning it going, this isn't how it's supposed to work, or I don't believe it works this way. I'm going to put it in a lab, I'm going to beat the heck out of it until I figure out if I have a different result. And so you get into these, if you look at experimental research, you'll find things that are driven around these cause and effects relationships. And so if I can develop a cause in a lab, I can see different effects of that cause. And that's, you can apply that to a lot of different numbers. Jared's talked before, we were talking about applying that to, fuzzing and things like that. And so you're really creating all these test cases, and you guys have learned this, through all your different classes you've taken in school, is when you develop these test cases, you develop them so that you're expecting different results each time. And that's really where innovation is driven from. So, whether you're doing vulnerability research, whether you're doing, exploitation, whatever it may be that you're doing, as you create these test cases and you're doing this experimental research, That's really where you're going to identify new either flaws in the environment, new efficiency in tools you're using. All these different things kind of surface up as you're doing this research and this experimentation. So don't be afraid to step outside and ask why and then test it a different way. But really, I think one of the big ones here is, we see a lot of times that someone's very eager to release a tool or release a blog post or release a video on YouTube of some stunt hacking, and it worked very well in the lab they built at home, but doesn't really apply to the real world. So you take a tool, you put it in an environment other than the one they built it in or a VM they had running on their system at the time, and it's broken. And it's really because people aren't creating the proper test cases and proper environment to test these things. They got it working one time, proved it worked on their system, and they go, I'm a genius now, I'm going to release this to the world. And in reality, it doesn't really apply to the field very much. So, keep that in mind as you're doing this research. Is the lab does not equal the real world. We say it all the time that you can test things 100 times in the lab, but you bring it in the field once and it's going to fail. So, be cognizant of that and be able to take what you've done and apply it to a new environment to make sure that your test case was actually valid. I've given talks for an hour at times on consulting in general and why I think consulting is broken these days, but I kind of wanted to bubble up a couple of these so that if there's anyone that's expecting to go into a consulting role, kind of keep some of these things in mind. One of the issues I see in consulting, and it's really a big problem across the board, is when consultants move into an environment, day one, the client has this preconceived idea of what they need, and the consultant kind of has the chip on his shoulder of, I've done this before, I already know it. And so you immediately have this mental block on both sides of the conversation of, I know what I need, you know what you think you need to give me, and just execute on it. And you don't have these conversations of, well, let's identify the why. And really that's the big one for us is when we start talking to a customer either day one when they call us blindly about an engagement, or we've done work with them year over year and they want to do a new service or repeat business, the first thing we always ask is why. Why are we having the conversation? Why are we talking about pen testing? Is it something that you heard at the bar from a peer that was cool? Is it something that's driven by a compliance that you should meet yearly? Is it something that is driven by a breach you had? Understanding the whys will help you shape the engagement and shape the scope. Jared actually mentioned that a little bit in his of proper scoping and the art of scoping, and that's something that is lost these days in our space. Is no one really understands how, not no one, a lot of people don't understand how to properly scope an environment because they come into this with this predefined methodology and scope already of, well, that's what the scope was last year, just repeat it. Or compliance says only this environment should be in scope, but you don't really question it. So as you're beginning to move into different environments and have conversations about scoping an application or scoping a pen test, or maybe you might be the auditor, all these things kind of bubble up to identifying a proper scope and a proper test environment so you can get the best value for the client. The other issue is a lot of the services that have been in this industry for a while are really becoming commoditized. So penetration testing is moving kind of to the edge of the bubble now, where automation is kind of driving a lot of those things, and unfortunately it's really given a much more negative connotation to pen testing, if you will, because the idea of pen testing being dead is somewhat debatable right now. Of if you're only testing for vulnerabilities, you're only testing for how many vulnerabilities you can exploit, how much value is a client really getting out of it? And so that's why you're starting to see things evolve into doing simulations and doing red team and collaboration and all these different exercises that bring more value to conversations, because it's not the once a year, do a pen test, here's your report and walk away. Now you're actually beginning to collaborate more with your clients. But at the end of the day, you're really consulting. Because if you walk into an environment and the client says, I need you to do this, and you execute that and you leave, you're not really consulting, you're engineering. And so that one is often misinterpreted in our space. Is if I'm coming in and I'm doing a task and I finish my task and I leave, you've not consulted. You've not been the subject matter expert. You've not brought additional value to the table. You really haven't offered any kind of solution. You've only engineered what the client gave you. And so for us, when we talk about consulting, it's really about sitting down and bringing new ideas to the table. We always make the analogy of, if you're coming in and giving an extra hand to someone, you're not really consulting. If you're coming in and you're providing an extra brain and an extra voice in the conversations, that's consulting. Now you're sitting down and you're actually having conversations about where can we take this, or what can we bring additional to the conversation, not take this prescribed solution that someone gives you and you execute it and you leave. To me, that's engineering. So there's a big difference between security engineering and security consulting. And so that's always been a big one for us and kind of a big battle we've seen. But I think the big one here that we always kind of joke around about internally is, a lot of times we come into these environments and we're really playing therapist. There's isolated business units, there's isolated teams, and no one really talks. You've got physical security over here that thinks they're only in charge of certain pieces of an environment. Then you've got network operations that thinks they're only in charge of a certain piece of the environment. And so everyone's kind of on their little island, and no one's really talking. And then we come in as a consultant, and we identify flaws in several different areas. And now during the debrief, we have those different teams involved. And in the beginning, there may be some finger pointing. There's like, oh, well, this group was supposed to be responsible for this. I'm not taking on that responsibility. And they kind of throw their arms up and say it's someone else's problem. But in reality, a lot of times consultants play this therapist role of almost like a marriage counselor, where you're getting the two sides to talk properly. Hopefully, at the end of the day, they're actually on the same team, and then you've done your job well. But unfortunately, a lot of times your position as a consultant is really being the mediator between these different teams. So don't be offended if you come in and you've got everyone kind of screaming and pointing fingers. It's really because they don't know how to talk. This one's kind of a big pet peeve among a lot of us in our space, and it's really this whole broad term of using the word red team. When the term red team was used by us and by others 15 years ago, it was really designed to be a next level type of service where it was full scope, no holds barred, anything goes. Similar to some of the things we'll be doing tomorrow at CCDC, but really it's anything physical, social, or electronic. And so when we talk about red team in the proper technology or the proper terminology, it really derives from the military and how they would institute testing facilities that are under their control but may not know that a test is occurring. And now they're using guns and they're trying to break in and possibly kidnap people and things like that. But when that terminology and that procedures got moved into the InfoSec space, it was really designed to be a full scope test. And so when you're thinking about red teaming, you're thinking about multiple people on a project. You're thinking about different activities that are happening at the same time. You're modeling different adversaries based on the kind of attacks you're doing. There may be one team that's designed to do electronic-based attacks. There may be another team on the ground that's designed to do physical attacks. And where those things converge and where they blend is really where red team testing is supposed to occur. It's this collaboration between these different teams, these different organizations, and how those can be driven to a chained attack or a blended threat that show impact to a business. And so you've got this misuse of the word red team that occurs a lot, where now anything that's offensive, whether it's application testing or pen testing or DevOps testing or wireless testing or all these different things, everything kind of rolls under this term red team because they brand it as it's an offensive security approach. And in reality, it's not red teaming because it's probably one or two people that are on a project. They're not really collaborating. They're not sharing information. They're both doing their own individual tasks. But there's really no sharing of how can I leverage a finding in this application or this space or this environment to chain that and get access another way. And so, unfortunately, the penetration testing that we see a lot of times, they call it red team testing, but the way we consider penetration testing is it's a component of red team testing. So if we're doing what we consider a red team test, there's penetration testing that occurs throughout that project. But there's also other areas that we're focusing on too. We're doing physical testing. We're doing application layer testing. We're doing social engineering. We're doing phishing. All these things fall underneath the red team umbrella. So for us, we don't consider pen testing a piece of red team. We don't consider pen testing an actual red team activity. It's really a component of a red team service. Does that make sense? This one, I put this one in here because it bubbles up a lot of different ways. We're in this space now where it's very easy for someone to assign themselves a job title. assign themselves, a label of what they do in the industry. And one of my favorite ones is this whole idea of I'm a research expert. Unfortunately, what that usually means is they just research something on Google. A lot of times it happens because they're in between jobs and they're looking for a new position, and so in their downtime, they consider themselves a research expert. But in reality, they're just looking up information that's already available, and now they brand themselves this research guru. One that I would strongly advise to not pursue and try to label yourself as, because it's becoming a much more negative connotation, is the idea of evangelizing something. You see a lot of people now that have their job titles on LinkedIn and places like that as being a security evangelist. And unfortunately, what that usually means is they had a very big following as bloggers. They had this idea of, whatever I'm doing, I'm going to blog and tell the whole world. And so now they have a number of followers. And usually companies will look at that as, this is a huge marketing, a capability. And if we pick this person up and we give them an evangelist title, now we can put out a PR news blast that we have this person on the team, and now they're an evangelist. And so it's unfortunately among your peers, it begins to give you a negative brand. And so a lot of times we see drawback with someone trying to perpetuate themselves as being an evangelist in a particular space, because at the end of the day, it's really just a marketing ploy, right? I'm an expert in this space, but I'm also an active blogger, so now I'm going to evangelize these things. So personal recommendation, I wouldn't try to go that route. I would try to stay focused in an area that you're in and really become an expert at it without being an evangelist. The hiring process a lot of times when we're looking for new talent is quite surprising because there's this mentality that if I've been doing something for a year, or I worked in a place where I was auditing environments for a year, and you really get this 1 or 2 year mentality. If I've done this for a minute, I feel like an expert, I now should be a senior. And to us, senior means a much different thing. Senior means you're able to perform any service we offer on our line card, or you're able to actually sit down and have conversations with your client and consult properly. All these things are a senior label in our mind. So it's quite surprising sometimes when we're talking to candidates about being hired, and they've got 1 or 2 years of experience and they're asking for $200,000 salaries. And thinking back to the amount of time that we had to grind and put in, trying to move up the ladder and advance our careers, and now you've got this mentality of having the handout because you feel like you've earned it, when in reality it wasn't given to you. Job titles are earned, but job titles are assigned, and it's really a recognition of something. So when we have conversations sometimes with new talent we're trying to acquire, and they've got this mentality of, well, I've got 1 or 2 years experience, I'm a senior, doesn't equal you being a senior just because you have tenure, right? You have time. You really have to earn that title and understand what that means in that environment you're working in, right? If you're in the consulting space, it may not mean you've been consulting for 2 years. It means that you can sit down and speak fluently with a customer about all the services you do and actually be an expert in many of those. But it doesn't always mean just because you've done it for a period of time, you've now become this senior level or principal level. And then the last one is one that is actually a real title that I've seen in a number of places, this whole cyber ninja. There are teams that I've seen, companies I've seen that try and build a team out and assign these ninja titles. And it works great when you're a Twitter handle and you're trying to get followers. It doesn't work so well when you're trying to speak to a customer and get them to sign a several $100,000 contract. And having cyber ninja on your job title isn't necessarily something that translates well with executives. It may be cool with your peers at a conference, but not so much with executives. This one is more prevalent than you would think. And there's been a number of cases where we've been able to identify something that is scary, but everyone is so eager to build their brand and get followers and all these things, right? And you've got this instant blogger mentality of, if I identify something cool, let me put it out to the world real quick. And maybe I'll get a few more followers, and maybe I'll get a couple of high fives and kudos, and someone will see me at the conference and be like, oh man, that was a cool blog post you put out. But what's really happening a lot of times that we see is you've got these consultants that are going in and they're on a customer environment and they find something really cool and they develop a tool really fast, or they tweak someone else's tool, and then they go home that night and they blog about it. And unfortunately, that's a risk sometimes, because what we've seen through several cases is, prior to that, they like to blog or they like to post on social networks where they are. And maybe they're even taking pictures with team members. And so it's very easy to see that this person or this team was at a certain client that week, and maybe even geolocation of where that client is. And then 2 days later, there's a blog post about something that was found cool. And it's very easy to attribute that finding to that customer in that environment. So you get into this mentality of, well, now you're doxing your clients, right? Now you're dropping data on a client because you were there 2 days ago. Now you've got this amazing blog post on a new tool you wrote, and now you're able to compromise the lab. And in reality, you're just using your customer's environment as your lab, and for your own, self-promotion, you're blogging about these things, and it's very easy to attribute that to your customer environment. So, I think as companies start becoming more keen of how these things occur, because everyone likes to, show their feathers and get some followers, be careful about what you're putting out and the time period you're using to put that out, because a lot of times it'll be very easy to attribute that back to where you were at and what client you were possibly at. So instead of saying no to all these things, what can we really say yes to, right? We can push the envelope. We can, try and break the mold. And, whether you're doing anything offense or defense related, think about how you can improve what you're doing. How can you bring more value to the table? How can you offer more to your client? If you're not offering anything additional, I don't think you're really doing value for your customer, because every time we engage with a customer, we should always be trying to bring something new to the conversation, whether it's a new service, whether it's improving on what we're doing, whether it's more efficiency in what they're doing, whether it's using data more properly than what they're doing. Always think about how you can push the envelope and break the mold a bit more. The whole resist the audit mentality, if you're an auditor, it's one thing. But if you're assessing an environment, following a rigor of just auditing an environment for a set of controls, you're not offering a lot of value to the customer, right? You're baselining them against a preset defined standards, and maybe they're achieving compliance with that, but as I said before, and you guys have probably already heard, is compliance doesn't equal security. Compliance isn't an end all, it's really a start. And so, resist this, I'm going to audit you against these controls because this is my standard set of controls I always evaluate against. This is my minimum testing guide. These are my things I always search for. And once I make it through my list, I'm done. And really move past that. That should be a starting point for you, not a finish line. And then really, be a pioneer. Try and innovate as much as you can. And not so much innovate by taking from others and calling it your own, but really figure out what can you bring new. And it doesn't have to be, I'm going to write this awesome piece of software. I'm sure a lot of you guys have talents in a number of spaces based on the classes you've taken here and what you've learned. Is there's always something additional you can bring to the conversation or bring to the table, and it doesn't have to be something grandiose and huge to the environment. It can be something very small. A lot of times we find the most value and efficiency in what we offer is just small little tweaks to the environment, or small little tidbits of recommendations, and all of a sudden you tell it to a client and they're blown away. They never thought about it. So a lot of times it's very simple, basic things. It doesn't have to be some amazing tool that's going to take you 6 months to write. And then really stepping outside your comfort zone is a big one for us. Don't get caught up in that same standardized methodology, that same standard approach to how you have conversations, and how you conduct an assessment, and how you report. Really figure out how you can be different this time. How can you step outside of that same monotonous, repeatable task you always do, and how can you bring this innovation? And then the last one for me is there's no experts. Everyone that's been in the space for a period of time now knows that. It's impossible to know everything, and if you're calling yourself an expert at something, you likely aren't an expert at anything. So when we look at candidates and we look at people that we really respect and people we want to have as part of our team, it's the ones that don't call themselves experts, the ones that are humble, the ones that know that there's so much more to learn and so much more to offer and so much more to gain from their peers, because they understand that it's impossible to be very proficient at one thing, because it's always evolving, especially in today's industry. Things are changing so fast that it's impossible for anyone to keep up. So, even someone that's very specialized in one particular service or one particular product, it's impossible for them to be experts at that because it's changing so often. So, that's it. It was short and sweet. I really wanted to have conversations at the end. I don't know how much time. I've got, what time is it? 10 minutes, not bad. Cool. So questions? I wanted to kind of use this as a time for anyone else to kind of share stories they've had of trying to hire a newer generation, or hire people that are just getting into the space, and maybe issues they've seen along the way. But really, if you guys had questions for me of what we look for, or if you've got questions about directions you want to go in your career or things like that, I wanted to kind of leave it open at the end for questions if you had any. Anyone there? Like a public image? I used to say LinkedIn because that was always the only professional place for people to kind of see what you do and who you are. Unfortunately, LinkedIn's kind of become more poisoned with marketing and paid ads, just like any other social network is now. I think for me, what I probably would consider the most important is really the networking side of it, right? Becoming known for what you're doing, not who you know, not name dropping and things like that. And that's really a big issue I see a lot of times, is someone tries to associate themselves with someone else to have an image versus kind of standing on their own 2 feet. So for me, I've always tried to keep in mind of being humble at anything that I'm doing. I mean, yeah, I think that sometimes I can probably be a little overconfident, because you just get that way by nature, right? We all kind of have that, I've been doing this so long, I know it, and then you have to remind yourselves, like, I don't know it as well as I thought I did. So it's kind of a learning lesson along the way. But I think for me, probably being humble and attributing everything I can to someone else is really what gives me a better feeling about myself of being professional. As far as imaging and followers and things like that, I think that's a difficult one. If you're caught up in your public persona online, you're probably doing it a different way. I've kind of, over the years, I kind of always took the approach of people would know me or know who I was based on what I was doing, not so much what I was saying. And so I kind of let it speak for myself. For a number of years, I really wasn't speaking at conferences or anything. I was just kind of keeping my head down, doing my job. So I think the humbleness and letting it kind of organically develop on its own versus you trying to self-promote yourself is the better way in my mind. Here. OSCP? It's good. So when we look at hiring candidates, we've never been caught up as much in degrees. And I say that only because, to me, I remember when I was going to school and me getting a degree, and it was very easy to pass the test because I could read and regurgitate answers, right? Just like you're going to school and learn and passing tests. When I got to a point of hiring, I valued the discipline of someone finishing college more of they know how to meet deadlines, they know how to work under pressure, and they likely can write. And that's always been a big issue in our space, especially consulting, is I would hire some of the best hackers that work awesome out of basements, and they're really, really good at doing what they're doing. But when it came time to reporting or it came time to speaking to a client, they would fall on their face because they were, they had the introverted, I'm very good at pushing keys, but I'm awful at regurgitating what I just did. So I think the discipline of a formal education is relevant for us more from like a technical writing perspective. They know how to actually put their thoughts on paper in an organized manner versus getting on the phone and fumbling over words because they can't speak to someone. So from an educational discipline, I guess, that is of value to me because I know they can probably work well and look professional on paper. From a certification standpoint, it depends on the role that you're moving into. Like right now, if we're looking at hiring pen testers, if they have an OSCP or OSCE, it shows me that they at least understand the tools and the concepts. How well they can apply it to the field is always kind of the variable there. And really that's when we start looking at job experience. Okay, they've just obtained the certification 6 months ago, likely to know how to fire up Kali and use tools in there and maybe do some reversing or whatever. And so they understand the concepts. So it's a great start. We definitely don't have a requirement when we look at people to go, they've got to be CISSP certified and they've got to have their OSCP, and those are all nice to haves. But I've seen so many times where someone has a full signature line, line wrapped with 100 certs, and they're just not very good. So I think it gives an idea of someone being motivated and having the discipline, especially if they have a degree also, but it doesn't give that immediate checkbox of, all right, this guy's ready to become a senior or whatever, right? But those are definitely great certs to have as fundamentals for the tools. And the GACs are another. SANs are pretty good in certain ones. The GAC certifications are good. We also value those pretty highly. But again, it shows that they understand concepts and tools and kind of the methodology of how to approach things, not necessarily, this guy's an expert at this, right? Any others? Is that one back there? What's that? VI. I don't even use Vim. Any more? It's hard to see. Yell if I'm missing you. Got one? Yeah. Yep. Yep. Yep, absolutely. I totally agree. And I think the other piece of that too is being able to speak technical versus non-technical based on who your audience is. You can't go in and sit down with C-levels and expect to tell them how you moved from this to this to this to DA. They're not going to understand that. But if you speak to them about impact and driving, brand defamation or affecting, their numbers and bottom line and things, they're going to understand it at that level. So understand who your audience is and how you position that, for sure. Is there one more? Yep. Yeah. Yeah. It does. Helps you break the ice, right? Helps you break the ice. And one thing we always try and say when we're building relationships is that common ground, right? If you can relate to something with someone, it's much easier to have those conversations and, oh, you're into riding motorcycles too, or whatever, right? And so now you've got this common ground to connect on, and then you can have more conversations because people a lot of times are closed up until you have something in common, and now you're high-fiving and going, all right, well, let's talk about business now. So I think I'm about out of time. Anybody else? Good? I'll be around if you guys have questions. Thank you.
Okay, cool, awesome. Okay, about to get started. Let's see. Awesome, guys. I'm happy to be here. My name's Carlos Perez. I am the team lead for research at TrustedSec. I'm also known as dark operator. So if you guys have been using Metasploit tools and you look through those, more than likely you've been using some of my modules in post-exploitation. Or if you've done anything with Interpreter, you're going to find a piece of code from me over there. Same with some Kali tools. My Twitter handle is Carlos_Perez. No, I'm not dark operator in Twitter. That's a Colombian guy that goes by that same handle. And that's not me, just in case. As I mentioned, I'm the red team research lead. My job at TrustedSec is actually working with the red team, helping them develop new tools, new techniques, and kind of helping them as they're going out there to customers, make sure that we tailor our tools to mimic specifically the threat actors that customers are actually engaging out there. I'm also a Microsoft MVP. I'm an MVP for Enterprise Security and PowerShell. In addition to that, I'm the author of multiple open source tools, and I'm also a co-host in the Security Weekly podcast. So you will see the salty side of me in the podcast. I'm the guy that sometimes kind of gets frustrated with the status quo, or is it PC, not PC, or stuff like that. I'll be the salty guy that will more than likely will say a swear word and kind of bring back or try to bring back the discussion in line. Or sometimes I'll be the one that just throws in the wrench and derails the conversation. But it tends to be very fun. Do listen to it. Sadly, with all of my travels lately, I haven't been able to do much. So the purpose of the talk itself is that I know that Sysmon has been overdue. I think almost every conference has a Sysmon talk. Almost every conference, a Sysmon talk is about hunting. Like, hey, this is how you configure Sysmon for hunting. This is how you use Sysmon for finding specific events that will lead you to your attacker or to the red team, or if you run CCD competition, that you'll be able to find the other guys. But I wanted to kind of give it a twist, and give it a twist of the hunting side and also the red side. I'm kind of like a purple kind of guy, even though I work with a red team. I like that interaction between blue and red. So I'm going to cover Sysmon kind of like with a twist. I'm going to try to cover how you as a red team, when you go into a box, you identify Sysmon, and you abuse the heck out of it, and even disable Sysmon if you need to disable it. And at the same time, how blue you should be working with your red team to improve your rules in Sysmon. So I'm not going to go very deep into Sysmon. I'm just going to go enough for you guys to understand what it does, and at the same time kind of cover some of the adversarial mindset and behavior that you should take into consideration when working with Sysmon. So Sysmon was originally developed by Mark Rusinovich and a couple of other guys inside of Microsoft. Most of them are actually inside of the Azure team. In fact, it was originally developed for them for use internally. At the moment, there are two versions that I know of Sysmon. There's the version that Mark makes public, and there's the internal version that actually captures a bunch of other stuff. I was lucky enough that by accident I got a copy of the internal version a couple of years ago, and I went like, oh, wow. And it captures a way ton more stuff, but at the same time, sorry, I'm a bit under the weather. But at the same time, if you try to use it inside of an enterprise environment with users, you may get into legal problems due to the amount of data it captures on the behavior of the users. Its main purpose is not to be a SIM. It's not to be an EDR. It's not for you to write signatures of attack. It is for you to actually extend your event logging specifically around attacker behavior. I see a lot of people going like, no, APT, blah, 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 came out with technique X, Y, and Z. Here's a signature for their tool. Hey, so-and-so red team or so-and-so company released this tool. Let's write specific rule sets for that tool. It's not for that. You're not using it as an AV. The purpose of Sysmon, the original purpose of it, and how it is intended to use is to focus on behavior. So you got to go from the tactical to the strategic in the way that you're actually building your tools, in the way that you use that. I'll go a bit into that. So in Sysmon, we have, it actually comes in one single binary, sysmon.exe. That single binary actually contains a 64-bit and 32-bit version in one single binary. You're going to see another one that's sysmon64.exe. That one's for nano server. In fact, I can count in my left hand that is missing fingers the amount of nano servers I actually seen out there. But it is a great version of Windows because it runs at around 100 megs of memory. It's great as a web server, super light. In my laptop, I actually was able to bring up to, I think, 68 instances of it, web servers running Node.js and serving web pages. It's kind of awesome. Sadly, Microsoft kind of gave up on it, but it was a nice try for them. The installer itself is both what you use to control the service. We'll see a bit more about that, and at the same time, it is what you use to install that single binary. All of the events always go into Microsoft Windows Sysmon operation event log. So let me go into my VM here. Has anybody here never seen Sysmon logs? Okay, we have a couple. So let me go over here. So typically the way you would find, once you install it, you normally would just go, let me see if I can go. I don't have Summit installed here. I have it in the top VM. There we go. So normally when you go into the event lock, you will go into applications and services. Inside of application services, Microsoft Windows, and inside of Windows, you would scroll all the way to the end, and you'll find Sysmon, and you'll be able to see each one of the events here for Sysmon. So let me just grab one of these guys here. Process creation. Sorry. It says that it cannot find the description. That means the manifest is borked in this VM. Typically, what I tell people, if you work in a blue team, you'll be doing kind of like the same thing I'm doing right now. You don't want the sanitized version that Microsoft gives you, like this is the smallest pieces of information that you want to see. You always go straight into details, and inside of details, XML view, and you go into XML view because that's where all of the juicy stuff is. It's not only what Microsoft wants you to see, but also the stuff that they sometimes think that you should not be seeing. And in this case, I'm going to be having a process that was created. I get a process GUID, a process ID. I get the image, which is the process that actually was launched here. So it's the runtime broker. I get file version information, description, product, company. I get the full command line. I get the current directory, user, login ID. I get a bunch of nice information that I can then use in my threat hunting, or also if I'm a SOC, to write rules against known behavior. So it's very, very useful kind of tool. Everything is inside of the event log. That way we can use Windows Event Forwarding if we want to and move all of those logs to a centralized place. If you're not doing it, don't talk to me. You should be doing it. I see it as a cardinal sin nowadays if people don't move their logs into a centralized position. These are all the events that I can catch. I can catch process creation. I can catch when an image is loaded. I can catch when a driver is loaded. I can even capture information about WMI. I can get information about pipe names. So Sysmon has been evolving throughout the years. So initially, Sysmon was process creation, process termination, capturing network traffic. Then we attackers started getting better at our tooling, and we started adding new stuff to bypass that. So we started injecting into memory. So he added create remote threat. So all of a sudden, we create a remote threat where we're injecting into another process. So now they added a way to detect that. Now we had to adapt, and we now do process hollowing. We do other techniques to be able to kind of mitigate these controls. We started, in some environments, Microsoft actually added ACLs to the LSA, so if you dump everything from, let's say, an Active Directory domain controller, you'll be able to catch me. And you're like, damn, if I run Mimikatz on the box, you'll be able to catch me because of that ACL. In addition, it's monitoring for people opening the LSAS process and injecting into it. In fact, some AV products will actually blue screen the box on purpose when you try to go into LSAS. So what we did is we went with raw access. We went straight to the disk and we copied the ntds.det file, the database out of AD. We brought it in, we cracked it, and then a couple of versions later, Microsoft Image came out with a new way of detecting that. So it's a cat and mouse game. And in this industry, what I'm seeing is that the mouse is getting better. So red is the cat, blue is the mouse. Now, let's say a good example, a tool that I've been discussing with my friends. Sharpshooter comes out, is talking about .NET JS. In less than 24 hours, Windows Defender has a rule for it. And it's catching all of its use. There's a new JavaScript encoding function. Jessica Payne from Microsoft sees this. Somebody tweeted it. She goes straight into her team. She says, oh, look at this new JavaScript encoding function. They added it to their machine learning tool that generates some of their signatures. They tested that. And in 5 minutes, they had a rule that they're pushing out. So the mouse is getting better. And as cats, we need to constantly be improving our tool set. So Sysmon is a great example of that. Before you installed Sysmon, believe it or not, a lot of people actually thought it was magic. I installed Sysmon and it's going to catch everything. They forget that they actually had to go in and configure stuff on it. So now, to make it simpler, it enables by default a configuration for logging process creation, process termination, driver load, file creation, time change. So when I modify the timestamps of files, and goes with SHA-1 for all of the hashes of the images or everything that gets loaded. So every time I install this, it's going to copy into the Windows folder itself. It's going to register the manifest, and it's going to create a service. So the way it actually works is that you have a mini filter driver. That every time you boot your machine, that mini filter driver is going to start catching all of the events. And it's catching all of the events, catching all of them. And then once it catches all of them and the service starts, it goes, hey, service, here's all of the events I have. The service will grab all of those events, and it will then start going through its filters, through its configuration, and start saying, okay, I don't want this, I don't want this, I don't want this, this is what I want, this is what I want, this is what I want, and starts writing those over into the event log. So the way it actually works is with the sysmon.exe, I can configure the sysmon service. I can add my configuration, add what I need, this is what you're going to look for, and then the driver is the one that is in charge of capturing all of that stuff. In fact, that is a mini filter driver that attaches to your drive, to your C drive, to each one of the volumes, because Sysmon, it catches some of the data, but it then goes into the drive itself to hash that process, to get the information about the file itself, to present that to you. So that's why it's actually a mini filter driver that works at the kernel level. Sysmon.exe and Sysmon service is user mode, Sysmon driver is kernel mode. That comes very important when it comes to wondering why blue screen so many boxes. It can be configured in two manners manually. I can either create my entire rule set via the command line. I can also use an XML file, configuration file. This is your configuration, use this. A tip, if you do sysmon.exe /h or -h for help, and you see the help, those are not all of the switches. If you dump the schema, and there's a switch for schema that you can dump, there's extra switches hidden, and this is a tip. I'm not going to go through those because actually, when I was writing a Sysmon workshop, actually ended up being like almost 4 days. So there's a lot of stuff, and wish I could go through all of it. Where's the VM? bring up the font. But if and we have kind of like a small set here of configuration parameters that we can actually use. But if I go here and do sysmon minus s, if I put 2 more, on the first side, you're going to see under configuration, I have a bunch of other switches that actually are not shown in the help that I can actually use when I want to configure sysmon via the command line. So that's kind of like a freebie there for you guys to look at and explore and use. You can actually just go by the switches that already exist, and you can figure out what is the schema for that XML. Now, in an enterprise environment, typically the way that we would configure this is that we would use sysmon.exe calling an XML file. That XML file typically will be in a file share. God's sake, don't put it in sysvol. I see that a lot. Well, now I'm a red teamer, so yes, please do put it in sysvol. And yes, do if you want. Be my guest. Copy it over to the box into System32 or into Windows. Leave it there, and then run the exe against it. It makes my life so much easier just to go in and read that file and know everything you're looking for, instead of me trying to figure out the binary format of the configuration in the registry. So there are 2 ways. The other one is just use the registry binary value and just copy that into the boxes. The configuration file itself is very simple. You have a schema version. So every time Mark adds a new feature, that schema version goes up. The schema version is not reciprocal with the version of sysmon. So if we're sysmon 7, it's not schema version 7. Schema version 4. Do keep that in mind. You have specified your hashing algorithm if you're going to check if the signatures are revoked or not. And then you have your event filters. Now, for each event filter, I'm going to have a category. Inside of that category, I'm going to say, hey, this is include or exclude. Or I can actually have both, include and exclude. One thing also to take into consideration is that it is case sensitive. Not only is it XML that makes me want to puke, but it also is case sensitive. So you have to be very, very, very careful when you do this stuff. I've actually seen it in environments that somebody goes like, let me do a quick edit and push it out. And the quick edit is that it somewhere failed because it was case sensitive, and they pushed out a blank registry value to all of the boxes, practically disabling sysmon. Just in case, do keep that in mind. It is case sensitive. It's very finicky. Then for each one of those categories, I can actually create filters. So my filter would be the filter of the event that I want to look at. You'll find those in the schema. You'll find that in the XML view. The condition type is not, and then the value I'm comparing those. You can actually combine them together, the excludes and the include. The way it will work is that we'll do all the includes first. The output of those includes will go into the excludes, and we'll remove that data and clean it up. And then whatever's left is what goes into your event log. Here are some of the values that we have there. We have is the same, is not, it just equals not, contains. It means that it's kind of like a wildcard search without the wildcards. It means that this string, this specific value, is somewhere in this field. And you can also do exclude, which is the opposite of contains, begins with and ends with. It uses this slash as a delimiter. It is not documented. Thank you, Mark. I actually had to figure this one out by loading freaking sysmon in IDA and looking why my rules were failing. Until I figured that one out. I have less than, more than, that's for numeric values, and then I have image. The image is the name of the exe. If you give it a full path, it will actually just strip the other part, and you'll just use, again, the slash as a delimiter. Again, not documented. you're going to find that trend with us. I like Mark, I like Microsoft. I'm an MVP, but I have to give them crap for when they do their bad stuff, just in case. So typically, when I call my configuration, I go sysmon.exe minus C for configuration. This is my configuration file. Once that file is processed, it's actually written into HK local machine, system, current control set 001, service, sysmon driver parameters, and it's going to be in a binary format. Actually, Matt Graver has a very nice PowerShell script that will parse that for you. I have one in Ruby that does it partially in Meterpreter. I'm not sharing that one because you guys are going to write rules against it. It's a bit noisy. And it works, and we're able to parse that and kind of figure out what's going on there. You have this hashing algorithm. One thing to keep in mind, any modification that you do to that registry key, it's taken immediately by the service itself. Any change to the registry, it is almost instantaneous, the change in the behavior of sysmon. When I use sysmon.exe to modify my configuration, and that's a big caveat, when I use sysmon.exe, it's going to generate an event 16. And the event 16 is going to actually have all the information. Hey, you loaded this configuration file. This is child 1 of the file. It was done. It's actually going to be doing it in UTC time, so you don't have to mess with timetables or time zones to be able to figure stuff out. Now, I can actually tamper with that configuration. If I go straight to registry, there's no event 16. You'd be surprised how many blue teams actually do not know that. Many blue teams actually think that if I modify the configuration itself and sysmon sees a change, that it will by itself generate an event 16. That won't happen. Event 16 is created by sysmon.exe. That's why I'm saying, blue team, you better bring in your red team to work with you when you're defining these rules and provide that devil's advocata to your process. Red team the process. Red team your rules. Work with them. Work with your hunt team. What a bad guy is actually going to be using. So do keep that in mind. You can actually make sysmon watch itself, but that's the last message you're going to see from sysmon. And the problem is that it's not only going to be the last message, but since it runs as you have to be admin to make that modification, more than likely I'm going to clear that log. And you're going to lose everything. That's why you use something like Windows Event Collector to ship all of your logs somewhere centrally. I know everybody likes WinLogBeat. I know Elk is the new sexy, is fine, and all that stuff. But I rather prefer use Windows featured tool, Windows Event Log Forwarding, grab all of those, move them as quickly as possible out of that box somewhere centrally. And then on that central box, I'll have WinLogBeat or any of the other beats from Elk and move those over to Elasticsearch and Kibana to do my stuff. That's a very simple rule. Target object, which is the registry key. Condition contains sysmon drv. So very easy to have it watch itself. Here you can see regedit.exe is actually modifying the registry key. And you can see that I did something very simple. I just simply modified the hashing algorithm, and that applied immediately. Now, if you want to write your own rules, and here I'm patting myself a bit in the back, I wrote a module called POSH-Sysmon that you can actually use to create your own rules. It is for PowerShell version 4 and 5. Supports the latest 2 versions of Sysmon. I try to keep up to date. There's a running joke between my friends and I, is that at the same time that I push POSH-Sysmon, Mark sees it and he pushes a new version with a new schema, just to fuck with me. We have that running joke, and the thing is that it has happened 7 times. I'm going like, fuck. So I'm beginning to think it is actually true. Because sadly, Sysmon also has what I call shadow updates. Sometimes Mark will fix a bug, update it, and the version doesn't go up. So do check that WebDAV drive. It has only happened twice in the entire history of Sysmon, but it was enough to make me paranoid. So I always check the date on when was the last time it was updated inside of that WebDAV drive. And I don't go by the Sysmon version when I'm doing my testing, just in case. It has a bunch of functions for you to use. One of them is the one from Mike Graver, Sysmon binary configuration. Actually, you can grab the value, that binary format, using PowerShell itself from all of your boxes, run it through this, and you'll get the configuration XML. And then the other ones are just for managing the configuration file itself, or for pulling the events from the event log and parsing those to build tools, or build rules, actually. It's very simple. There we go. So here's an example. I do new sysmon configuration path base config hashing algorithm SHA-1, and then I tell it process create. So it will include all of the process create information. Then I go set sysmon rule. I says, hey, path, this is my XML file. Registry event include. That means that whatever matches in the filters, I'm going to include. And then I do a new sysmon registry filter. I give it the file, on match include, so it matches that rule. Condition contains, value sysmon driver, and the event field is target object, and it creates the one for sysmon watching itself. I don't have to worry about uppercase, lowercase, what's the format. And it will, by default, it will do it for the latest version of schema version. You can actually tell it to go one version back if you want. You have that option. And the advantage of this is that you can do everything tab complete. You can write all of this stuff probably in a CSV file. And then you can go import from CSV and then pipe it into the other commandlets and have all of your rules automatically built for you. So you can have one single repo that you can go from. I wrote this a couple of years ago. For me, it's super useful in research. As a red teamer, I like knowing everything that my tools do because defenders are getting better. I have had the honor and the privilege of training Marine Corps, CPT units, and other people inside of DoD. And they're top-notch. They have very nice tools. They know their shit. They know what they're looking for. I've gone against customers. The vein of my existence is Elk. Elk has made threat hunting so freaking easy that organizations are leveraging it very well. There's many times before they had Splunk. Oh, I have to deal with Splunk. And then you got to go back to your manager. Hey, we're bringing out all of this logs, so I need more money to bring in over more logs. Now they don't have that problem with Elk. With Elk, I just bring it in. The only thing I need is somebody willing to learn, somebody willing to try new stuff and just code whatever I need. And it's very easy just to bring all of those dashboards and stuff. So Elk has been a changer in the game as a red teamer. What I like is just knowing everything. Every whisper, everything that my tools do, I want to know what they're doing. It is called the low card exchange principle. How many here have worked in forensics? One, two, only like a couple. In forensics, we have what is called the low card exchange principle. He's a French dude that actually created what we call now modern forensics. What he said is that any interaction between two objects, there's always going to be something left in that object. There's always going to be a transfer or something. If I grab a gun, there's already some part of my skin, my sweat, my fingerprints on that. I fired the gun, there's going to be powder on my hand. Probably there's going to be oil on my hands. Same thing when I teach the military. Sometimes I'll have trackers, people that have gone through tracker school. So I'll use the term spore. Like when they're tracking an enemy across the ground, they're looking for spore, they're looking for footprints, broken branches, snot on leaves, believe it or not. One of them was telling me a story how they tracked an insurgent, and it was very easy. The guy was actually coughing all the time and just throwing snot at the side of the trail, so they were able to track the guy just by his snot. And that's the spore that they actually use. Every action we take as red teamers in a network is going to leave a trail. It's going to go through a router. That router is going to deal with those packets. The server, the firewall, there's going to be logs everywhere. And as a red teamer, the better I know my tools, the better I understand how networks work, the easier for me is to blend in with the noise or make sure that my spore gets lost with the spore of other actors for you not to see me. And that's a very hard exercise to do, and that's why I actually built this module, because it allows me to be able to track my own actions. You can actually do obfuscation when you install it. I respect the notion, the idea, but it made me laugh in the implementation, and I'm going to explain why. So I can actually just rename sysmon.exe to whatever exe name I want. I can call it HP printer control.exe. That's going to be now your service executable. I then do the -d switch. Driver, you're not going to be sysmon.drv. Your name is going to be prntcrtl. I do -i, accept EULA, because I always have to accept the EULA for Microsoft stuff, and it installs. Now, the driver has another name, so I cannot find that driver, that .sys file on the target box. I'm not able to find it anymore. And if I list the service now is called HP printer control.exe. So not able to find that. So it obfuscates itself. So now it's difficult for me to find. Well, sysinternals also provides me another tool called procmon, which is very simple. So what I did is I launched procmon, installed the new sysmon, and I saw everything that didn't change between each version of sysmon. Now I know how to fingerprint it. So I admire what they're doing, but at the same time, there are ways of actually detecting this. Oh, and by the way, once you rename it and you try to use sysmon.exe to control it, it won't work. Because sysmon.exe, when it runs, again, something that is not documented that I had to find via IDA, thanks, Mark, is that, after banging my head for half an hour, is that sysmon itself will look at its name, and whatever is its name of the executable is what it's going to match the service name to. So I actually have to use hpcontrol.exe to be able to modify my configuration. Why do I mention it? I know environments that go like, oh, that's so awesome, that's sexy. Let me use it, and for some reason, they think that their GPO is applying the configurations, and they're not. They're not adding anything. Just because of that undocumented feature on it. Now, if I'm, let's burn a bit of tradecraft. I know that some of my coworkers are going to hate me for this. I can actually control that driver. It's very easy if I'm an admin. I can make you blind. And no, I'm not talking about showing pictures of me without a t-shirt. I can use the tool fltmc.exe that will actually allow me to control drivers, mini filter drivers. I can list them. Each driver is going to have an altitude. The altitude for sysmon is 385201. It's always going to be the same altitude. The altitude number refers that when your machine boots up, every driver has an altitude number that says this is your order that you're going to load. Every AV vendor has its own altitude number. The main reason for the altitude number is that if two altitude numbers are the same, your box is going to blue screen. So it's made to not cause that conflict. That's why you have to register your altitude number with Microsoft so everybody knows. So here you can see that printer control has the altitude number of sysmon, so I know that that's sysmon. And if I go into the registry, here's the printer control driver entry, and you can see that the altitude number is there in the registry. You can modify it. But to keep in mind, you can actually blue screen your box if anybody else has the same altitude number. So do keep that in your testing. Now, sysmon will also, when installed, it creates a file where it stores its event logs, and that name remains the same. So typically what I'll do is, since if you look at the tool set nowadays, you have Empire, you have Cobalt Strike, you have Metasploit. Those are kind of like the top 3 ones. One single common denominator in terms of all of those on doing stuff on memory is that all of them can list files. Only Meterpreter can read registry from memory. And Empire, sadly, now everything gets logged. As soon as you try to read the registry, it gets logged. So the only common denominator is I can list files from memory and not trigger anything funny in the event log or anywhere else. So typically I'll write modules for both 3 tools to detect sysmon in the target box, and I do it this way. I check for the EVTX file in that folder. Once I see it, sysmon's there, now I can start planning my TTPs of what actually I'm going to do. Next, I'm going to search for XML files in the system root if you're using XML files. If I'm admin and still want to stay under the radar, I'll actually go inside of your event logs I'll start going through your event logs and using those against you. I'll start looking at process creation events and command lines to see what you're actually calling. I'm going to find out if you're calling that from sysvol, and then we'll go to sysvol and read it. How easy it is to unload and make sysmon blind. fltmc.exe unload, print, and then I give it the driver name, and that's all. The service is still up. The driver is down, so the service is not getting any data. Sysmon's now blind. And the service is not smart enough to bring it back up. And it's kind of funny because a lot of AV vendors, this works also. The only one that has given me trouble or fights me to be able to unload that driver and have to do kind of like a timing attack and stuff on it and pause process and then be able to kill it and then respawn the process and kill it is Carbon Black. Carbon Black is the only one that monitors for this so far that I've seen that monitors for you unloading that mini filter driver. They go like, boom, and pulls it back up. And then if I try to disable the service, the driver will see it and the driver will bring up the service back. So they're protecting each other. That's kind of neat. And again, it will catch itself being unloaded. Its last event. If you have Windows 7 forwarding, Windows 7 forwarding will forward that to you, and that's the last log you're going to see from sysmon. Until I reload the driver again, and now you're going like, what did they did in half an hour, or 2 hours, or 5 minutes, or 10 seconds, if I automated everything. If you have Mimikatz, I was talking about this with Benjamin Depley, and he added this to Mimikat for me, which is you can use MISC, MSFLT, and it will list all of your drivers with the altitude numbers. You can actually go and read that source code, and you have half of the battle of disabling sysmon in memory. Now, when you're crafting good configs, how am I doing with time? Okay, cool. So when you're crafting good configs, do make sure that you have an adversarial mindset. Think that people are going to attack your rule set. People are going to attack every rule that you're building there. They're going to abuse it. And you have to think, how are they going to abuse it? That's why we always preach about purple. That's why we always say, keep your freaking ego at check and work with each other. We're in the same team. Sadly, many organizations do not get that. And they set the KPIs where, hey, if red wins, blue loses. If blue wins, red loses. And what you're creating is an adversarial relationship at work. You want that adversarial relationship to be a simulated adversarial relationship, not a real one between your blue and red team. So do bring that mindset over. Start with a known, sensible configuration. Taylor Swift has a good one. It doesn't watch us for people modifying sysmon, but it has a very good base of settings there. Some of them we can abuse. I can show you a couple that can be abused if you want. Start with a small set of systems. Collect, analyze. Sysmon has been known to blue screen boxes when people upgrade willy-nilly and trusting that it's always going to work. So do test it. This is a side project of Mark. It means that the CTO of Azure, after he deals with all of the Azure BS, whatever time he has left between his kids going to bed and spending time with his wife, is that what he puts into it. So there's not a lot of QA going into it. It's a side project. Microsoft won't give you support for it. It is awesome, but if you blue screen 500 boxes all of a sudden in your network or more, and you call Microsoft support, they're not going to give you support. They're just going to send an email to Mark, and then when Mark has time, he'll fix it. So do test and validate both the configuration with the executable itself. So always remember, edit, deploy, assess. Bring in your red team in the part of assess, or your hunt team. In fact, hunt, if you're a hunt team, you're supposed to have a large chunk of your time, 20, 30%. 10% if you're overworked, but you have to have research time. Going through all of the threat intel, everything that you're getting through Twitter, all OTX feeds and all that stuff, and building new rules for your SOC. Have your SOC deploy those in test mode and then bring the data and fine-tune those and start going through that constant process. The work of Blue and SOC is immediate detection. The work of Hunt is finding new behaviors that they can then feed into the SOC for them to find stuff. We work together. Don't create one single file for every system. Fine-tune it per system. There's Sysmon can make your system slower, depending on the rule set. So don't create a one master rule and send it to everybody. You may be creating impact in performance, which then means an impact in business, which it means that you're losing political capital inside of your organization. I know that sucks when we talk about internal politics and business, but at the end of the day, we're part of the business. We are a facilitator. Our job is to protect the freaking business. So guys, any of you who are students here, I know business classes suck. I know talking with people suck. I know project management suck. But if I can give you a word of advice career-wise, spend time learning that shit. Also, I'm building political capital. You're going to be dealing with SOBs that you want to kill. But you need them to be able to get your job done. See it as a social engineering exercise. Meter their actions. Social engineer them. See them as a social engineering exercise. And you bring in boxes and slowing them down and bringing them down, and also bringing them down completely won't help you there. So do be careful. Some good tips from Mark himself. Process create, log all, file creation time, exclude known processes. I like this. That gives me a target of where should I be. Network connections, log all known browser activity. That means that I'm going COM objects against application.IE Explorer and then using that for my exfiltration. See, I'm bringing the red perspective into the rules. Process terminated, enable only when investigation. That's awesome. Now you don't know how long was that running in your system. Now I'm giving you the willy-nilly. You don't know, this executed, but when did it end it? Did it work? Or how much data did he exfil? You won't know because process termination is just too much for you to handle. You're drinking from the fire hose. So do keep that in mind. Driver loaded, log all known Windows and non-Microsoft. This one's nasty. This one will catch quite a bit of APT actors out there. Image load, do look for PowerShell, system.automation.ni.dll. Look for that one. That's very good. WSHOCM.OCX, Windows scripting host. Anything that uses Windows scripting host, you'll be able to catch it. So they say not to use it, only for investigations. As a red teamer, I would tell my blue team, yeah, do use it. But be very, very, very targeted with it. Create remote threat. Exclude known processes. Awesome. Now I know where to move and then from where to inject into other places. Raw access read. Exclude known processes. Now I know where to go to then dump your ntds.dit. And they're good recommendations, but at the same time, I'm not doing this to be an asshole and just say they're bad. No, they're good recommendations. I'm just bringing you the other side, the side that, that many people don't like to hear. It's like when you hear somebody and they're going like, oh, dude, I want to lose weight. And you go like, dude, simple. Exercise and diet. That's everything you need. Calories in, calories out. And you make it sound so pretty. But in reality, that means a lot of work, a lot of pain. You have the DOMs. You have to have discipline to wake up every morning, do your PT, wake up at 4:30, go hit the gym, do what you need to do, come back, have breakfast, and do whatever you need to do. So I'm bringing you the other side, the side that people don't tell you. Like, hey, cool, great rules, they work. But don't think that they're the all be all and will cover all. So that's why I want to bring that red perspective to those. Process access includes sensitive targets. It's a bitch, that one. That one hurts when people do use it. That means I cannot get where I want to get inside of memory. It cripples me in memory. I hate that. But that one's a very good one, sensitive targets. File create, that's a good one for auto-start entry points. All of the registry ones for the auto-start stuff, for persistence, that one's awesome. Works very well. File create, stream hash. For MO2W names, I don't know what MOTW is. Sorry, that's a recommendation from Mark. You have pipe create, pipe connect. It says to enable in investigations. Actually, I've seen a lot of environments actually done a very good job of profiling all of the name pipes that are normally used in a system and create rules. Actually, I know that some of them actually make that list public and they put it in GitHub and say, hey, look for this name pipes. And that is actually awesome. Actually had another slide here. Oh, it's a bit further down. Sorry about that. So tips for red. Have the capability to load and unload the mini filter in memory. Your best friend, MSDN. The examples are there for you, for free in C++. You just need to code it. Make sure that you're actually, you copy the configuration, you parse it, that's kind of like given. Do post-execution automation profiling. This is something that I talk with red teams and they go like, I never do that. And then I see others, they go, I do it all the time. For example, if you're going to be launching attacks, not all payloads have to be code execution payloads. Have profiling payloads, recon payloads. Like you're talking with sales and you're talking, oh here, I have this spreadsheet. You're bringing that report with the target. You're talking with the salesperson. You're giving them a Word file. The Word file is benign. It has all of the data that, some very basic VBA code that is going to give you back the data back to you on how they're configured. It's not going to trigger behavioral analysis on the AV, on the EDR. It's only going to give you back enough information to you know what controls are there. Now that sales guy, after a bit of rapport back and forth of recruiting, you're able to get quite a bit of information of what controls they have, and in addition to know if stuff's getting picked up by their sandbox or not in your sandbox detection techniques. And now you have enough info that you can actually send your payload. So in your profiling, make sure that you identify if sysmon is on the target. Check for accept EULA. This is the vein of Microsoft Legal. It always creates a registry key, so that key is an indicator that is present. Microsoft does it for every sysmon tool. Sorry, for every sysinternal tools. So if you're running auto runs automatically on the boxes, it's going to have a registry key there. You run sysmon, it's going to be there. Doesn't matter how much obfuscation, how much shit you do, Microsoft Legal requires this, so it's going to be there. And you're going to be able to find it and see if the host actually has sysmon, yes or no. Now this is the one that a couple of blue teamers were sharing, like, hey, we have all of this. We're able to find Windows credential editor. We're able to find Metasploit. We're able to find Cobalt Strike as it uses the name pipes. We're able to find all of this other stuff because we have a list of known name pipes, and we're able to find them trying to use name pipes to move laterally across our network. In fact, it's kind of funny. There's a technique that certain state actors use. They call it the hand of God. And the way and the reason that it's called the hand of God is that all of their payloads talk with each other, and then those talk back to a central server that is the only one that's persistent. Every other machine in the network, everything's in memory, and they get reinfected by memory. And they have even redundant connections between each other. And only that single box that has persistence on disk is the only one talking to the outside world. And they call it the hand of God because it works like that. Everything's connecting back, and then this guy connects outward. And one of the techniques that they use is actually using name pipes. So you're able to find those through that. But most of our tools are open source, aren't they? So if I'm a red teamer, the only thing I got to do is I got to grab my code, find the name pipe that says Metasploit, and change it to one of these, or the pipe that says pwdump. Actually, the name pipe's called pwdump. That's so stupid. you can actually just rename it, and it will work. So tips for red, make sure you have a testing environment, you have it automated. So as you're building your payloads and you're building everything, you're feeding it to AV, EDR, and you're also collecting SIM and rules. And that way you will know what are going to be your functional TTPs for that target. So once you identify, hey, they use Symantec endpoint protection. We know they're using FireEye boxes. Then you know, okay, let me bring that into my lab, test all of this stuff. Now I know the TTPs of my actions that I'm going to be able to execute on the target. This is why recon is so freaking important. I was talking with some of my coworkers about an engagement, and what I did is I called the recruiter. I'm like, hey, I want to work for your security team. Here's my resume. And we started going through the interview process. So, hey, what tools do you guys use? Oh, we use this, this, and this, and this, and this. Awesome, cool. Do you guys speak in conferences? Yes. What conference? Oh, we had so-and-so talk at this one, so-and-so talk at this one. I go into those conferences, I go like, oh, this is how we use elk in our environment to hunt. Oh, awesome. These are the rules that we use, and this is our entire process. Cool! I'm like, awesome, now I know how to operate on their radar. Or at the very least, I know, like, shit, they know their stuff. So I gotta be careful. I gotta test my stuff. So recon becomes super important as you're working on this, and that will give you your resultant TTPs when you're working. Tips for blue, not shipping logs nowadays in this modern age. Even when Microsoft gives you that for free, Linux gives you that for free, every freaking device gives you that for free. That's an RGE in my book. That's a resume generating event. If you get breached and you're not shipping your logs out of your host into a central location. For me, that's an RGE. Do leverage process GUID and log on GUID. Believe it or not, PITs do get reused, and they get reused very, very, very quickly in a Windows environment. I thought it was a myth until I was working on some tools for a hunt team, and all of a sudden I had a bunch of PITs actually repeated in my environment. Also remember that modern versions of Windows, you have 2 logon IDs every time that a user logs in. And I like this because it trips up blue teams. Blue teams are kind of a bit hampered on Windows 10 when they're hunting because they never spent the time to actually check the release notes from Microsoft to find out that Microsoft decided to update the version number for process creation events and for logon IDs. Now every time I log in, there's 2 events, 4624, and each one has their own unique logon ID. One, it is for when I execute anything that is UAC enabled. The other one is when I execute everything as a regular user. And if you're a hunter and you don't know that, that will cost you problems. In the case of Sysmon, what they do is they build one GUID and associate it to one single logon session. So you're able to track that. Same thing, they create a GUID for the process, so you're able to track that also. So do keep that in mind. As I mentioned, work with red and your hunt teams. Check your ego. Same goes for red. If your boss lacks leadership and their KPIs are to put you against each other at the end of the game, if your organization gets hacked, it is your salary, it's your job that you lose. You need to work together, like it or not. You got to work around the system. So do work around the system. Keep your ego in check. Work with them. Hey, these are our rules. This is what we're working. Do you have any recommendations, any bypasses? And if Red provides those, at the very least, write a nice email to their boss or to your boss's boss saying, the work that the Red team did for us was great. Work around the system. Have them show you blind spot. Eliminate those. Mitigate them, or at the very least, be aware and document them. You saw me providing examples of places where, hey, there's this configuration, cool, but I can bypass it or I can abuse it. Many times you just gotta take your medicine. That's the only thing you gotta do, because you're not going to be able to process all of those logs. You have to filter those out. But at the very least, know about those and have your hunt team look for those manually. Even if you don't trigger automatically, have your hunt team look for those. If you want an example of this, let's go into security TA's example here. One of my favorite WMI PRVSC. Okay. Does anybody know when WMI PRVSC.exe, you see it with the dash embedding flag? No? Okay. You'll see that when I use WMI to move laterally inside of your network. When I use WMI Win32_process class, instantiate that to create a process in another box or on my box, its parent is going to be WMI PRV.sc.exe. But it's going to have that dash embedding flag. So every time I move laterally across your network, or let's say you're using Windows ASR rules, attack surface reduction rules. Attack surface reduction tools won't let, in Windows Defender, any process have the Word or Excel process as its parent. It's going to block it. Hey, Word, you cannot create a sub-process. I'm going to block you. So what you do is use WMI. You instantiate a Win32_process and you say, hey, WMI, start this process for me. And somewhere in the system, you're going to see WMI PRV.se.exe, launch it itself with a dash embedding, and then that process over there for you to bypass those Windows Defender attack surface reduction rules. But the problem is that you're removing that because also the system uses it for other stuff. So I'm able to kind of operate under the radar and move laterally now in your network if you have that rule enabled. It is a good rule. It generates a lot of noise. But at the same time, as a red teamer, it lets me know how I can operate in the environment. Blue, now you got to work with other mitigations. Probably create a permitted event subscription that looks for the instance creation of the Win32_process class, or the execution or the calling of a method of create under Win32_process, and you build your own tooling with WMI itself. But you have to be aware, and the only way you're going to be aware if this red team works with you and gives you that data for you to work out of. So I'm out of time, and I don't know if I'll have time for questions. But are there any questions? Okay, if there aren't any questions, I thank you all for your time, and I hope you enjoyed the talk.
Yeah.
Guess we'll get started in about 30 seconds. All right, everybody. Hello. Thank you. I am Bob Kelka. I'm the Global Vice President of Cybersecurity for IBM. It is a thrill to be here at Dakotacon. I was invited by the team when the cyber team competed at the National Collegiate Penetration Testing Competition Finals at Rochester Institute of Technology last fall. And I am the executive sponsor at IBM that is supporting that. So what I'm going to take you through over the next 50 or 55 minutes is what's going on with cognitive and AI and how it's changing cyber. And this isn't a philosophical pitch for the most part. It's really focused on what's happening now. It's not future fantasy stuff. It's actually happening. And this whole topic has a tendency to freak some people out and get other people incredibly excited. So I'm going to take you through both points of view on that. I'm actually close to 29 years with IBM. I've been doing cyber at IBM since 1994. So I've literally been doing cyber for 24 years. I was one of the first couple of people in the 1990s that looked at what IBM was doing for security and realized that outside of the mainframe we were horrible. And so I got rid of everything that we were doing and started acquiring companies. And we acquired our first company in September 1999 of a web single sign-on company because everybody was putting up portal servers, and now we all call it web access management. And last February, we made our 28th cybersecurity acquisition. So we've gone from being really a no-op outside of the mainframe on cyber to we now are over a $2 billion business in IBM. We, Cisco, and Symantec are the three largest cyber providers in the world, and we have over 8,000 people doing cyber. For myself, in the years of working on this, I'm one of the guys that's with clients, chief security officers, chief information security officers, CIOs, board CEOs every day. I just recently hit 9.4 million air miles with American Airlines. So if you do the math, I've been off of the ground for about 785 days of my life. So my wife, thankfully still my wife, probably why she's still my wife, would tell you that's pretty good. But I've had incredible experiences over the years working on cyber, and everything from being with boards of directors in Moscow. I spoke last year to the board of directors for Sberbank, the largest bank in Russia, and the two speakers to the board were myself and Eugene Kaspersky. And that was really cool, right? Because Eugene, he's kind of persona non grata here in the U.S. right now. But clearly, you know, one of the forefathers of security. In fact, at the risk of overstaying my welcome, I'll tell you something really funny, is that after Eugene and I spoke to the board, afterwards, I was talking to Eugene for a while. Hey, how'd you guys break out so big? He says, one phone call. I called Best Buy in Minneapolis and said, I'll beat any other vendor by $1 a unit. And Best Buy said, okay. And then all of a sudden, Kaspersky Labs antivirus was all over the place. After he left, one of the Russians walks up to me and says, hey, do you know the truth? Yeah. Do you know the truth about Eugene? And I said, what do you mean? It sounded like Access Hollywood or something. You know, I'm like, well, do I want to know about Eugene? And the guy says, did you know he's not the smart one? I said, what do you mean? It's Eugene Kaspersky. He goes, no. He says his ex-wife invented the technology. He's just the marketing guy. So there you go. You learn things all over the world in cybersecurity, in this case, sitting in a boardroom in Moscow. But anyways, what I'm going to show you is the reason the AI, which, by the way, most people say AI is artificial intelligence. At IBM, we actually almost as a rule call it augmented intelligence, and it's not just for a like vendor-specific reason. The reason is when a lot of people hear artificial intelligence, they instantly come to this vision of people out of work with the machines and the robots running everything. We've been doing cognitive and AI for a long time, right? Watson beat Jeopardy all those years ago. We have changed the nature of cancer diagnosis with Watson, with what we're doing there. And we have hundreds of different things within industries that we are remaking by applying cognitive learning to it. What we have learned is it doesn't displace any jobs. What it does is allow people to actually get their job done. And if you can think of an area that has too much data and the need for too much insight happening right now, I'd be hard-pressed to find one other than cyber. So we started looking at, about 3.5 years ago, how could we take, in our case, of course, Watson, which is the center of our AI investment, and start applying it to cybersecurity. And I'm going to show you a couple of examples of it today. Because we've actually identified over 24 different specific things within cyber that cognitive engines like Watson, not limited to Watson, but clearly we have a head start on it, it can do to fundamentally change things, all right? So that's what I'm going to take you through. What I'm going to start with is the backdrop for where this becomes so relevant is you have to look at where we are right now with how people are running their security programs. We've got almost 18,000 clients, and we have very tight relationships with our clients. And when you sit with folks like that every day and see what they're doing, you start to notice things. In fact, I've actually got a bachelor's degree in computer science, but I have an MBA in small group psychology. And the reason I got a degree in small group psychology is that if you haven't figured it out yet, the problems in cyber are about 98% people, if you think of people, process, technology. There's a lot of great stuff out there. The people, especially outside of the security bubble, kind of don't often want to work with the security bubble. And we've got stuff all over the world that we've got tools everywhere. I've got one client that's paying maintenance on 288 security tools from 65 vendors. Right? When Target was breached, it was 85 tools from 45 vendors. The problem isn't there aren't enough tools. The problem is that people aren't using them well. So I actually literally changed my MBA focus to group psychology when I started to get into cyber because I realized that's the bigger problem here. And we'll probably feed a little bit of that into this conversation as well. But let me, at the risk, because anytime you do this, the AV people always get really nervous. And I'm going to try to switch over to my iPad and draw a little bit to give you kind of a sense of what we're actually seeing out there today. You guys can let me know if you get the signal here. You'll know quick enough. It'll be worth it, I assure you. Let's see, let me plug it back in. Just, there we go. All right, let's try it again. You'll know pretty quick if there's a squiggly line on it. Oh, there it is. Hey, brilliant. Good job, guys. All right, so when you look at how most people are running their cyber shops right now, a vanilla ice cream version of it looks like this. Most people have 4 phases to their cyber program. Of course, it's bidirectional comms between each of the phases, providing a closed loop so you learn as you go, all that standard stuff. What everybody starts with is security analytics. And security analytics is, how do I find the needles in the haystack, right? We know there's a bunch of needles out there. The problem that most people have today is they've got hay in the needle stack, right? In other words, there's so much poor analytics coming out of the untuned tools that most people have today that the needles are not the exception, they're the rule. So what everybody starts with is logs, right? Collecting, normalizing, correlating, reporting, and monitoring logs, and that's SIM, right? Security Information Event Management. Everybody's got a SIM. Roughly 96% of them are poorly tuned. And by the way, it's not because people are bad people at all. It's just, you know the fact. I mean, it's 209,000 unfilled cyber jobs right now, right? If you're in cyber in school here, you're smart because you're going to get a job. Nobody can do all the stuff they have to get done. They just can't do it. And so what happens is every organization, when you talk to the CISOs, they've got checklists of things they have to get done. And one of the checklists is, well, they had a bad audit finding because they didn't have a SIM. They didn't have a log correlation. So they go buy a SIM, put it in, realize it takes 6 to 9 months to actually properly tune it, and they have all these other check boxes, so they go, I'll get back to it, and they never get back to it. So everybody's got a SIM today, but most of them are poorly tuned. The other problem with the security analytics that most people have today is that logs is old stuff. It's things happened before. It may have been 20 milliseconds ago, or it may have been 3 weeks ago, but it's old. That stuff doesn't help you with things like, hey, typically contractors download 3 confidential documents a week, and right now I have a contractor downloading 300 confidential documents. When do you catch that with logs? Maybe never if you do it later. So what most people are doing is they're graduating beyond logs into real-time flow analytics. Right? So you look at network traffic patterns and combine it with the logs, and that's become the best practice. By the way, we're still only in middle school. Logs are like the elementary school of security analytics. Flows are middle school. High school, where a lot of people are starting to move now, is things like user behavior analytics, and there's lots of layers beyond that, but for sake of this discussion, that's enough. But that's the first thing everybody does, is put in some security analytics, try to find the needles in the haystack, and hopefully there aren't no more needles than haystack. Then you get to where it starts to get interesting for cognitive. Because then, once you identify the needles, you have to figure out if they're actually sharp enough to do something about. So what a lot of people would call that is threat hunting. This one's amazing. By far, the most common practice for threat hunting today is this really sophisticated, hyper cool technique called manual Google search. In other words, the level 1 SOC analysts, they get these needles cranking out of their analytics tool, and what they do is they find, we've talked to hundreds of them, they find 5 to 13 sources like blogs and stuff that they trust, and they say, hey, we got this thing that we saw a configuration change to a device and some strange network behavior right afterwards. Anybody else seen that? And that becomes the threat hunting technique that the vast majority of organizations use today. What makes that particularly problematic, of course, is that it's kind of slow. But there's even a more foundational problem here. Of all the threat research out there, roughly only 20% of it is indexed and searchable. So the best practice that people use today is manually searching through 20% of the data. Makes no sense, but guess what? That's what they're doing. Our researchers also tell me that there's an average of 7,426 new pages of threat intelligence getting generated every day. And the average human reads 150 words a minute. Do the math, right? It's kind of an impossible problem, and we're doing a real poor job at it. Now, once you kind of see this as a reality, then one day when the CISO and the team is sitting around with the business, they say, I got a great idea. Let's be proactive. So let's get into threat intelligence. So then what people do is they start buying threat intelligence feeds. Hey, like who else is getting hacked? What's going on out there? You know, our X-Force Exchange, we don't charge. Most vendors charge. We don't charge because we think it's silly to charge for this. But people are buying $50,000, $100,000 for these threat intelligence feeds. I did a survey myself last year. I asked a handful of CISOs, what are you doing with those threat intelligence feeds? And they said, looking at them. I said, that wasn't my question. What are you doing with them? They said, looking at them. They're not getting much of any utility. Hey, it's nice to know there's a bank in Moscow getting hacked right now, but what does that mean for me? All right, so we got a problem there, and then finally we get to arguably the dirtiest little secret in cybersecurity today. In cybersecurity, one of the concepts that we use at IBM is the concept of left and right of boom. Boom is a cyber event. Boom is and basically, left of boom is what do you do to prepare for and discover boom, and then right of boom is what do you do once you have the problem. So this final piece, and the dirtiest little secret in cyber today, is called incident response. I've been doing this a long, long time, and professionally, my most naive moment of the last 3 years was that 3 years ago, I assumed 95% of organizations had a well-defined, up-to-date incident response plan. With what incidents, what cyber incidents, what booms am I worried about? And then, who's going to do what if those events happen, right? The run books is what people call it. I assume 95% of organizations have those. We've discovered it's less than 2%. Now, by the way, think about it. If you have a boom event, and you do not have a well-defined, up-to-date incident response plan, then what do you do to respond? I like to write it, I used to be a math minor at least, as a null set. You make it up as you go. And making up a cyber response when the heat of the battle is going on is really a horrible idea, but that's what most people are doing today. So I know that sounds a little cynical, but when you're in the field, you'll see. This is the typical thing you're going to run into, is that you have poorly tuned log correlation, manual search to find stuff, feeds that give you pretty dashboards but not much more, and then people making up their incident response plans as they go. Well, what can you do about it? Well, here's where cognitive starts to get super interesting. Okay, because first of all, if you have maturity in your security analytics and you migrate towards automation, so not only defining the run books, but actually automating the execution of the incident response run books, that helps immensely, and that is the best practice right now, around the world right now, is making sure you get more mature in your analytics at the top left, and then that you go to define and automate the run books on the bottom left, but we're still stuck. The problem is right here on the search piece of it. And that's the first use case that we discovered where cognitive can fundamentally change cyber. We started teaching Watson 3 years ago. It's actually 3.5 now. 3.5 years ago to ingest and digest threat intelligence. Now, IBM has taught Watson a lot of different vertical knowledge bases on top of its engine, with the cancer diagnosis being the most famous one right now. But there's literally hundreds of them. So we started feeding threat intelligence, vetted of course, into Watson about 3.5 years ago and started teaching it the language of cybersecurity. One of the things that we learned when we did that is there is some terms that we use in cybersecurity that have really radically different meanings in the real world. Like, for example, one of my favorites is we had to teach Watson in the early days that hash is not an illegal drug or a food when applied against cybersecurity. Think about it. I mean, that should give you a taste. When you're programming a cognitive engine, it's literally from scratch. It's like an ignorant little child knows nothing. You have to teach it from scratch. You know, we put some stuff in and it kicks out a recipe. We're going, dude, that's not what we meant. You know? So we had to teach Watson the entire language of cybersecurity. And frankly, for the first year, we're going, oh my gosh, this is going to work. This is crazy. After about a year, started showing results. After about 1.5 years, the light bulbs started going on in Watson around this stuff. And we're now at the point that we're feeding over 1 million sources of threat intelligence every single day. And by the way, it's growing every day. Huge, huge effort into Watson to ingest and digest the information and then build what it calls knowledge maps. So instead of manually searching through 20% of the data, you just ask Watson. It's already pulled it in, and it's pulling it on a recurring basis. Now, by the way, it sounds impressive to say we're pulling 1 million sources in, but we're in grade school on that. There's way more than 1 million sources out there. And so, but we're very, very careful with vetting constantly the inputs, and that's why we're only at about 1 million right now. But I want to tell you, so what this means, right, is that putting AI into the middle of this thing is where it gets really super interesting. So I'm going to go back to here and kind of show you a couple of data points and a couple of points of maybe insight that you might not realize. Oh, that's pretty interesting. Oh, well done. All right, so, you know, once again, the backdrop here is there's too much data. So this is a study we did, and this makes the point. 93% of Security Operations Center SOC managers aren't able to triage all the potential threats. 42% say they ignore a significant number of security alerts. Some of you are probably aware of this, but when you say target breach, besides, oh gosh, someone else bringing up the target breach, reaction number 1. Reaction number 2 is, yeah, it's the HVAC vendor. Well, there's a much more basic problem that happened at Target that has nothing to do with the HVAC vendor. It's the fact that Target had a SOC in Minneapolis, and they had a SOC in India. And when the malware through the HVAC vendor came in, their Indian SOC saw it. They got flagged. They knew it was there. So why did they still have the breach? Because what happened is, over the previous year, their untuned security analytics tools were kicking out so many false positives that as the Indian team would send stuff to the Minneapolis team, they started ignoring them because they knew that most of them, if not all, were false positives. So they found the breach in India. The moment it entered their systems to the HVAC vendor, they sent it to Minneapolis and they ignored it. Until a couple weeks later when they were notified by an outside body, guess what? Your stuff's all over the place out here. See what I mean? So ignoring a significant number of security alerts is just bad, but it's the state of where we are. And then 31% of organizations claim they ignore 50% or more of the alerts. That's not cyber, right? I'll give you another little story just to make the point. There's certain things that we should take responsibility for as cybersecurity professionals. The fact that that's the reality right now, we shouldn't accept it, right? One of the best presentation openings I've ever seen in my career. About 3 years ago, I keynoted a conference in Tel Aviv, Cyber Week in Tel Aviv, Israel. And it was me, Gil, the president of Checkpoint, and Netanyahu, right? Benjamin Netanyahu, the prime minister of Israel. And so Netanyahu gets up. He's the first speaker, of course. He gets up there, and imagine this room. This is a beautiful room, by the way. Imagine this room with 3,000 people in it. At Tel Aviv University. And yet Netanyahu goes up to the podium and doesn't even say hi or anything. And he's half hour late, too, right? But he's the prime minister. He can do anything he wants. He gets up to the podium, and he goes like this. How many of you know Hebrew? And about half of the room. It was an international conference, even though it was in Israel. So about half of the hands in the room go up. He goes, okay, about half of you. I need to tell a brief story in Hebrew. And so I hope the rest of you aren't offended, but it'll be short. And he goes on and tells a story in Hebrew. I timed it. It was 2 minutes. You know, when you're hearing something talk for 2 minutes in a language you don't know, it gets a little long, stuff like that. So he finishes 2 minutes later. Remember, this is his introduction. 2 minutes later, he ends, and you have that pregnant pause, right? Okay, he's done. And all of a sudden, the entire room breaks out in raucous applause. I didn't, by the way. I had no idea what he said, and I'm wondering why everybody else is clapping, right? And he goes like this. I'm confused. Half of you told me that you didn't know Hebrew, and yet you were clapping for a story that I just told in Hebrew. You're supposed to be cybersecurity professionals. You're supposed to question everything. I'm very disappointed. That was his opening, right, for this massive conference. By the way, incredible if you think about it, really active. But the point is we have to question everything, and we have to question dumb things like that. But it's because we're overwhelmed with all this stuff. Now, guess what we found? Most people say, oh, well, the real problem here is that it's the speed gap. It's the fact that if we have all this intelligence, then it will take us too long to find the right information to come to a conclusion of what the real problem is while we're doing our threat hunting. But what we found is there's two other things. There's also an intelligence gap. What I mean by that is not that the people doing it aren't smart. That has nothing to do with it. What it means is as we looked at these, as we observed these level 1 security analysts going Googling and finding a document that explains a situation like they're seeing that came out of their analytics tool, what we found is as soon as they come to something that convinces them it's a match, they stop reading the document. And the problem is they go fix the immediate problem, but if they kept reading the document, the 3 paragraphs after it, they would have found the problem was more widespread than they realized. But they don't ever see it, because as soon as they see the match, they're overwhelmed, they got too much to do, they go, it's a match, let's go fix that tactical problem. So that's an intelligence gap. They're not learning enough as they're doing it manually. And then the other one is the accuracy gap. As soon as they read a sentence in the blog entry or a PDF file or something that leads them to believe it's not a match, they stop reading. not realizing that 4 paragraphs later there was something. However, if this is the situation, here it is. They never get there. So the problem that cognitive is addressing in threat hunting is not only speed. By the way, we did this beta test year before last to 42 clients of this Watson cybersecurity stuff. And one of our large financial services clients literally told us, I'm not making this up, they said our threat investigations now go 60 times faster. They used to take days to weeks, they take minutes now. It's not only speed, that is one of the benefits, but the other thing is that Watson is reading the whole document and building a knowledge map based on the whole document. So you also get a benefit around intelligence and accuracy as well. All right, so that becomes very, very interesting. So what we're basically talking about is you take the traditional data that we're pulling into the SIMs and hopefully into the flow analytics, and we're taking all this unstructured stuff. Right? We're going out, we're finding, we're vetting, we're ingesting and digesting, right? Different things between ingestion and digestion. All of this different data. Now I'm sharing this much with you just so you can see, because this is real. This is not some kind of, oh, what's going to happen in 5 years from now. This is happening actually as we speak. So it's pulling in this kind of data and doing this stuff. So what I want to do, and so in essence, the bottom line is you're taking traditional human beings and security analytics and you're adding unstructured analysis and natural language. This is really important. You can talk to a cognitive engine, right? In fact, one of our researchers, researchers are generally pretty geeky and pridefully. And one of our researchers had an 11-year-old fellow geek son, and he was working on this at home one day in his basement office. And his son said, Dad, how come I can't talk to this? And being a geek, he said, great idea. We've got voice recognition. So we actually have an interface on top of our Watson cyber stuff. You can just talk to it and it talks back to you. It's called Project Haven. And it's pretty cool. So it's adding natural language, machine learning, unstructured analysis. So what I'm going to do is I'm going to show it to you. I'm going to show you a demo of what the art of the possible is with this. Because it's actually pretty cool. I think I'm going to show it to you. You never know with this live stuff sometimes. Okay, that means I must have to move it over to there. Give me a sec. Hello. There we go. All right, so I'm going to show you a live demonstration of what this looks like, just so you can get it kind of, it becomes more pragmatic, right, when you can see it. At least for me it does. I'm a visual person. So what you're looking at here is a SIM. It happens to be our QRadar one. It really doesn't matter for the sake of this discussion. But what's happened is our SIM console has been taking in logs and stuff from all over the place, and it has come to the conclusion that there's a pretty high potential that we've got potential WannaCry, right? A WannaCry attack within our systems. And so what we do is, the way we do this is we have a free app that interfaces between QRadar and Watson. And as soon as you download this free app, you'll notice at the top, for those of you near the front anyways, that there's a Watson tab that shows up within QRadar. And so what I'm going to do is take you to that Watson tab. And what it does is say, I've got a bunch of things that you can look at. Let's look at that one. And what it does is gives you a whole bunch of information about what the actual alert is. And then what it does is it says, well, hey, do you want to send it to Watson? Because if you'd like, this says Watson has not investigated this incident, right? You can automate it, but just for sake of this, I just set it up where it's manual. So in this case, I'm going to ask Watson to go look at this thing. Let's set up some limitations, 1001, 1002, 1003, 1004. It's about 4 seconds. Watson searched its knowledge map of over 1 million different threat intelligence sources, repeatedly pulled in, building out the knowledge map of the linkage between the data, and it gives you this literally English language thing. I'm not going to read the whole thing, right? But Watson analysis of 53 observables found 73 new indicators, 43 data points, 33 related suspicious activity. It kind of reads it out for you of what it found, okay? But here's where the magic takes place. Because remember, the A-B test here. The A test is you go manually searching the web on blogs and asking questions, saying, has anyone else seen this kind of thing? In this case, we took the indicators and just sent them directly into Watson. And Watson, in 4 seconds, said, well, hey, I've come up with a whole bunch of stuff here, and I think you're going to be interested in this. And then you click on it, and there you go. In 4 seconds, it was able to determine that you've got 4 different strains of malware that have come through 12 IP address, 17 URLs, and you got 17 infected files. And it did it in 4 seconds. The A-B test is just brain dead obvious there, right? And this was a really simple case. It can do some incredibly complex things. And so so you can see where you could get to a 60-time threat investigation improvement here, because you just ask the thing and it tells you what it sees. But this is where all of us that are techies get excited, because it also builds a live map of everything that it found. And you can click on any point within what it analyzed to see exactly what's going on, right? So this is just one of dozens of examples, as I said, of applying cognitive against cybersecurity. But the reason we started here is that this is the lowest of the low-hanging fruit. Everybody's struggling with their threat hunting. The accuracy is low. The tuning of the tools that are even feeding into the process are generally not that good. And so the ability to help across the board there by having the information being ready to be asked is just so no-brainer obvious. It's not funny. Now let me give you a couple of other examples of how cognitive is changing as we speak cyber. Here's a second example for you. The cats and dogs of the cybersecurity world are app developers in the security team. All right? Security teams and app developers generally don't want to hang out with each other. There's just kind of a natural cats and dogs thing. The app developers want to write cool code and go off and do their thing, and security wants to do risk management. And so, of course, that kind of gets in the way of the developers doing the stuff they want to do oftentimes. So the developers are like, yeah, I know you're important, but I'm important even more, and so get out of my sight. Or something to that effect. Sometimes they're nicer. But one of the problems is that as people are now widely adopting static source code scanning, dynamic scanning of the apps and stuff, those are the two risk management controls that have become widespread now as the cats and dogs have been forced to work together. One of the problems that you find, if anyone's in here has done static source code analysis, is that you scan the code and you get 478 different findings. And the developers go, see why I don't want to hang out with you? Oh my God, it's going to take me too long just to read what the 478 are, let alone fix the problem. Well, what we did is we started turning Watson on to this about 2 years ago. And we started saying, when you find this kind of source code problem, I'm not looking for @SQL, right, in an input field, to state the obvious one, or one of the most baseline ones. And what we did is we started learning that a lot of the source code scanners will find something that they look at the tip of the spear, they don't look at the shaft of the spear. And that if you look at the shaft, you learn that there's way more tip types than shaft types. So we came out with last year something, which I can't stand the name, I think it's dumb, but intelligent finding analytics. What that is takes source code scan output, and in using what Watson's learned about the different types of shafts, that instead of 478 alerts, shows you the 20 shaft types that you have to fix, right? That's a second example for you of cognitive applied against cybersecurity. And I'll give you one more, because this one is brand new, and this one blows my mind every time I even think about it. So we've started to integrate our cognitive engine, which is Watson, of course, with our mobile device management software. We've acquired 28 companies to build this thing, and one of them was FiberLink Mass 360, which is one of the more popular MDM tools. Well, we started to integrate Watson with that. Why have we done that? 2 reasons. First is the obvious one, the vanilla ice cream thing. is that, everybody's got at least one mobile device now. And when you look at the mobile devices, one of the most baseline basics of cyber thing is device configuration. So we've been teaching Watson for a couple of years to analyze mobile device configurations. And Watson has built this kind of expert knowledge of what's a really good configuration for a mobile device, what's an okay one, and what's an not so okay, and what's horrible. And so what we can do now is that whoever's using our Mass 360 stuff can use Watson to basically evaluate the quality of the configurations across the different user populations. That's just vanilla ice cream, right? That's not that exciting. It's just a very simple use of cognitive for this stuff. But here's the one that blows me away. We're starting to take completely unrelated or seemingly unrelated pools of Watson knowledge and tying it to the mobile device management stuff. And one of the most intriguing examples to me is that a lot of people don't realize that IBM acquired the Weather Channel 2 years ago. We acquired the Weather Company. So the Weather Channel, right on whatever cable you have, is not owned by IBM. But all the data that they use to report on is owned by IBM. Right? So we acquired the Weather Channel because we've bet the farm at IBM on cognitive and cloud. Right? We're 3 or 4 years now into our transformation that cognitive and cloud is what we're all about. And so when you start thinking cognitively, one of the most relevant points of what's happening is weather. So we wanted those Weather Channel feeds, we bought them, and we've been feeding those weather feeds into Watson now for well over a year every day. And believe me, we'll be doing some cool things with that, but let me just limit it to our discussion here on cyber. So let me give you a potential application. Let's say for executives that have access to your most sensitive data, you have a very restrictive MDM policy. But let's say that the weather channel, the weather company data feeds for Sioux Falls indicate that there's a 99% chance of ice storms tomorrow, which means that everybody's probably going to be working from home. So, given that cognitive reality, do you slightly relax the device configuration on those executive phones because you know they're going to be working from home and still need to get their job done, and then 24 hours later automatically put it back to the more restrictive policy? Now, whether you agree with that decision or not is not the important point here. The point is, just think what the possibilities of cognitive are when we start taking data that seemingly has very little to nothing to do with cybersecurity and actually have it start at least making recommendations to us, if not overtly automating, what do we do around the areas of cybersecurity? See what I mean? The upside here is massive. And we're all in like preschool right now on this topic. I mean, we have a head start, right? I mean, one of the benefits that we have in cybersecurity at IBM is that the IBM machine, is doing so much investment in the core Watson engine. All we have to do is build in the cyber smarts on top of it. I've shared 3 of those cases with you. We've got literally about 24 more that we're actively working on. Because when it comes back to it, remember where we started. Nobody's got enough people to get the job done, as indicated by the fact that, all the open jobs, and everybody says 2 million within the next 3 years open jobs in cybersecurity. So nobody can get done everything they have to do, and yet they're doing stuff but not doing it well, like I drew it. They're checking boxes. What we're supposed to be doing in cybersecurity is risk management. That ultimately is why we exist. We are providing, right? Since beginning of time, crime follows the money. All the money's online now, so all the crime is online. I mean, all with a lowercase a, right? I'm being a little facetious. But you have all this stuff, and you've got to protect it, but you don't have enough people, and you've got too many distracting priorities, so even when you do it, you're kind of doing it partially. That's not risk management, right? I like to say, when I meet with CISOs, which we are a big conference in Vegas this week. I just got in from Vegas and met with about 15 clients a day all week. And what I like to say to the CISOs is cybersecurity is about risk management. It's lowering the risk of an outage, right, to the ongoing concern. That's why we exist. However, most people aren't doing risk management, they're doing career management. What do we mean by that? When you check the box to say, I've got a SIM now, so the auditor's not going to give me a red mark, but you don't tune it so it's not actually doing risk management, you're not doing risk management, you're doing career management. The problem is when you have a breach, you're going to get fired anyways, so it's short-term career management, right? But it sounds kind of harsh, but that's what the reality is. Our jobs are to do risk management, and to do risk management, we got to be able to handle the inputs that are coming into us. And with 7,426 new pages of threat intelligence being generated daily, and only 20% of it being indexed and searchable, we can't do this as human beings without machine learning. And that's what we've realized, and that's why we're doing this stuff. So, I guess it went into sleep. So let me finish up with you, and then I'll see if you have any questions by just giving you, whoa, dude. Sounds like some gothic metal or something. Wow. I live in Austin, Texas. I grew up in New York, but I have lived for about 22 years in Austin, Texas, and I'm a musician. I got 4 bands in Austin and stuff. And I've actually played in a band that sounded something like that before. So. I will tell you, if there's any fellow hard rock fans, talk about cyber taking you some interesting places. I was speaking at an event 6 years ago in Stockholm, Sweden. And I get to the event, and it says, I wasn't the keynote speaker, I was just doing a thing on cyber. And it said, keynote speaker, Bruce Dickinson. And I'm going, the only Bruce Dickinson I know is the lead singer of Iron Maiden. And why would he be at a conference in Stockholm for technologists? Well, it was Bruce Dickinson, the lead singer of Iron Maiden. So I got to spend an hour with Bruce Dickinson, who, I grew up playing metal and stuff. And I'm going, oh my God, I'm sitting here talking cyber. And now, it was IBM, an IBM event. Why did we hire Bruce Dickinson? Because everybody in the Nordic is a metalhead. Right? If you lived with all that darkness all the time, right, you'd get it. And secondly, he's got a lot of businesses. He bought an airport in Wales, and he believes, I'm giving you firsthand, he told me this directly, he believes that the next thing in international air transport are Zeppelin balloons. So I got to watch like 30 minutes of his test flights of his balloons, right, which was really interesting. But anyways, cyber will take you some fascinating places. And it's fun. And it's cool, and it's kind of timely and all that. But anyways, I digress. All right, so the final thing I'm going to show you, and then I'll see if you have any questions, is just to kind of summarize what I've shared with you. The bottom line is there's no way we can handle all the data. Machine learning gives us a chance to do that. Now, there's lots of issues. You got to be careful. Everybody knows about the Microsoft AI bot that became a pervert in 24 hours and all that stuff. So you have to be really careful about the inputs and all that stuff. But what we've learned, right, because we've been doing this across almost every industry now for years, is what we've learned is when you do it right, it's incredible. And we've learned very much how to do it right. So in this case, what we're talking about is taking the stuff that is generally done, and everybody knows, such as security events in the green, and what we're doing in this case is taking threat database, security textbooks even, and pulling them in, right? And then it learns it. There's good old hash, and then goes and tests. And I showed you the net result of that thing, right? So that's what this stuff is all about. I'm going to share these slides with everybody because a lot of people are interested. What do you actually put in there? And there's the details of what we put in there. But the big thing, most important thing is we as cyber professionals should take it personally, as Netanyahu pointed out in Tel Aviv 3 years ago. We should take it personally that we are doing risk management, not just that we're doing some cool technology and, whoa, look at this dashboard and all this stuff, but our jobs are risk management, not cool technology. So we should take it very personally that we get to be able to supply risk management to our employers. And you cannot supply comprehensive risk management if you can't handle all the data coming or if you ignore 50% of the alerts coming and stuff, right? All that stats you saw. So that's why we believe machine learning is inevitable. We have to do that, okay? So I try to give you perspective on what's happening now. I'm happy to answer any questions that you have about, where it's going next, or issues, or things you're worried about, or things you're excited about, whatever. Are there any questions? Yes, sir. Yeah, exactly. So the question, if you didn't hear it, is in the area of static code analysis, and I mentioned the intelligent finding analytics thing that we do. How do you teach it to ignore some syntactical things? The cool thing about a machine learning engine is that when you interpret something as a problem, and then you realize that either the impact of that problem is irrelevant or it's not really a problem to begin with, there's a fine line between those two, then Watson learns that. And it says, okay, I now have seen that 3,542 times, and I know that you've taught me that that's irrelevant except in the following cases. Right? The cool thing about a cognitive engine is just it's teaching the same way you learn, except it doesn't forget. Right? So you may know, because of the research you're doing on this, that particular syntactical thing really isn't a problem. But someone who doesn't have your experience wouldn't know that. They'd spend however much time they'd spend on it and stuff. Or someone who's experienced and overwhelmed, and they're not only responsible for static analysis, but dynamic analysis and instant response too, because they only don't have enough people in the shop, and so they don't have time to think about it. They may even forget that they realized at one point. See what I mean? And with the AI engine, it doesn't forget. It's just dispassionately, as you learn, as it learns, and it learns the exception cases and the exceptions on top of the exceptions, it doesn't forget them. So anyways, if you want to talk more about it, see me, I'll give you my card, and I can get you with our guys that are doing that. So you can talk to them directly if you'd like. Yes, sir. Oh, what a great question. That's an insightful question. The question, if you didn't hear it, is does Watson help in actually tuning like the sim in the first place? No. Will it eventually? Yes. But here's what we've learned. That thing I showed you, the code that I just showed you and the analysis that Watson did, the number one gating factor between people that get value out of what I just showed you and people that don't is how tuned their sim environment is. Because, look, it's either good in, good out, or garbage in, garbage out. We had 42 beta test clients, and I would assert to you probably 20 of them got a ton of value and about 22 got no value, other than a learning experience, I guess. And the reason was that is if you don't have your security analytics tooling tuned to look for the specific risks and threats you're most worried about, then you're just sending gibberish in, and Watson goes, well, I'm going to process the gibberish, and you're going to start having connections all over the place that make no sense, because it's not really a problem. See what I mean? So yeah, we would love it to help with that, because that's kind of the prereq to get value out of that today, but it's not doing it yet. It's a great question. What else? Anything around cyber? Anything around Eugene? All right, it's an honor to be here. Thanks so much for your time. I look forward to see you again, and good luck to all the teams competing this weekend in CCDC. It's awesome stuff. We are always hiring, and so that's why we sponsor a lot of these things. So we've got over 8,000 security professionals now, which is about 7,988 than we had when I started on this thing. And we'd love to get to know and work with all of you. Thanks. Hey, let's go, man. Look at that, given time. They both have.
want me just to go? All right, I can just go. All right, let's go ahead and get this thing started. All right, I've got a video I want to show you guys. It has absolutely nothing to do with anything, but I'm going to try really hard to tie it in to computer security. And I wanted to share with you all what it's like to actually pen test an organization that is properly defended. I've been working on this for quite a while. I can't get it yet, but whenever I do, I'm going to record it. So I'm going to screw this up, but it's going to be funny, all right? So I wanted to give you guys a representation of what it was like, or what it's like to pen test a properly defended network. All right, so that little guy right there is like me, all right? All right, so I just got access to the network. I just did spear phishing, so I'm sending in my spear phish. The user clicked the link. Great, they clicked the link. This is, oh, crap, they have AV. Bypassing AV is not a problem. I got it. Bypassing AV. Ha! Oh, crap. Application whitelisting. All right, so now I'm going to bypass application whitelisting. Okay, I've got bypassed application crap! Host-based firewalls. Now I've got bypassed with the host-based firewalls, bypassing antivirus. Oh, crap! They got user behavioral analytics. All right, so now they bypassed by user behavioral analytics. I bypassed firewalls, bypassed antivirus. Oh, dang it. They're using honeyports. All right, so now I bypassed all of those different things, bypassed honeyports. Sucker! Oh, crap. They actually got me with something I can't remember at the moment. All right, now, what am I going to do? All right, now I've bypassed all those security technologies. I've identified the honeyports. I'm in! This document looks crap. Is that document a trap? It's a trap. Okay, so I found this document on a share. It looks somewhat legit. Oh, crap, not again. Okay, so I finally got access to the share. I see this document. I know it's a trap. I'm not going to hit it. I'm instead going to go to a different document. Okay, so let's try that. Okay, maybe. Oh, crap, I know it's a trap. All right, I'm going to try a different document. It's a honey document. It got me again. God, this sucks. All right, so I'm going to bypass those documents. I'm now in. Oh, crap, they're using responder detection on the network. Now I've gotten past all the security documents. I'm going to avoid those documents. I got in. Yes! Oh, shit. So at any rate, I'm running out of things to say at this point. But whenever you're testing in a properly defended network, this is what it's like. Everywhere you go, you run into a new defense, a new approach, something in the network that you were not expecting to be on that network. And today's presentation, I want to talk about hunting and actually finding advanced adversaries and how you can actually go about doing that. So one of the questions I would like to ask everybody, have any of you sat through a presentation about machine learning or artificial intelligence and at the end of the presentation still knew nothing about machine learning or artificial intelligence? They basically go through the whole thing. It's like, this crap is awesome. You need more of this in your network security. And it's like, what is it? Never mind that. And until things actually start improving, this is how organizations detect that they were compromised in the first place. And I want you guys to focus at the 1% in there. The 1%ers. Sorry, bad joke. I thought it would kill at a college, but whatever. All right, so thank you. Network intrusion detection systems 1, log review 1, fraud detection 1, host-based IDS, that would be like the AV 1, incident response 1, IT audit 1, and an external monitoring services are basically responsible for less than 1% of the detects in computer security. And it's been like this since 2014, and it's not getting better. It's very hard for me to sit through presentations from a lot of different security vendors, and they talk about all the awesome things that they're doing. And when we're testing their networks or networks with their technology is not making a difference in detecting the attacks that we're launching against them. And this doesn't mean that we're awesome and we're the best security firm ever. You look at the techniques that we implement at Black Hills Information Security, and they're many of the same techniques that you would see at TrustedSec. You would see it in Guardians. You would see it at Rendition InfoSec, and so on. These things are not hard to do. How many of you in this room right now want to be a pen tester when you get done with school? Raise your hands up, okay? Couple of things on that. One, I think it's awesome. I oftentimes tell people, come to the dark side, we have cookies, and you'll like it. It is awesome to be paid to break into places, but I want you guys to start looking at some of the people in this industry that have been doing it a really long time. Look at Dave Kennedy. He started Binary Defense. I've been doing pen testing for 20 years, and we started up Active Countermeasures is a defensive company. Chris Gates, who's at Uber now, is working on their defensive side of the house. Pen testing is great. It is awesome, but it is not the end-all, be-all of computer security. because the defenders need help. Right now, and I hate to tell you this, if you apply for a pen testing job at any pen testing firm, there are going to be resumes hundreds deep of people dying to get into this industry to do network penetration testing. So one of the things I would like to put forth, while I think pen testing is incredibly noble, and it's where I've gotten my start in computer security, and I think it's fantastic, give the blue team a second look. And that's really what we're going to be talking about here today as we progress through this presentation. Because bypassing the defenses that organizations have today is not difficult. It isn't hard, folks. Every single year we do sacred cash cow tipping. One year a presentation got done early and I went through a whole bunch of slides on bypassing antivirus engines. And a lot of the techniques that we used back in 2015, 16, 17 are the exact same techniques that we used in 2016, 17, 18. The techniques are not changing. We're not seeing a lot of the defenses that are in play get better at detecting these. And a little bit later, I'll share a link with you. It gives you a bunch of slides on how to bypass all the different major antivirus vendors that are out there today. And when you're looking at defense, I can see why trying to become a defender in computer security looks like it sucks. Feel free, shout out. What are some things in defensive security that suck? Logs. Users? User buy-in. Thank you. What else? It's always your fault. She's right, you know. Huh? No one listens. I would expect you to say compliance. He's like, oh, God. And he goes, it goes back to no one listens, right? There are lots and lots of reasons why being a defender sucks. And there's one main reason, just aside, why being a pen tester sucks. Anybody here do pen testing? What's the part of your life that sucks the most? Reporting. Yeah. About what percentage of your life is spent reporting? The majority of it, right? Like you gate access, it's like for every vulnerability you find, it's like that's another 2 hours of documentation. So no matter where you go, there's going to be suck. But one of the main reasons why being a defender is so incredibly hard is so many vendors are trying to sell you on the idea that they have an automated tool that'll automate hunting. They're going to automate defense. They're going to automate response. Those people are snake oil salesmen. They should be tarred and feathered and ran out of town. We can literally pull that off. We're in Madison, South Dakota, folks. We have tar, we have feathers. I know, and I'm from South Dakota, and I know for a lot of you, when you say, yeah, you know, you live in South Dakota, people are like, why? And it's like, well, it beats North Dakota. But that joke killed. All right, that's the one that killed. Not the 1%ers, but that one. So we need to get beyond the idea of trying to find automated defensive capabilities to automatically do our job for you. And for all of you that are in this field and you're moving out and you're trying to figure out what your career is going to be moving forward, every single time a vendor is talking about automation, they're talking about, you know, taking the end-to-end life cycle or a single pane of glass. Ultimately, what they're selling to executives is the idea. You guys, could you stand up real quick? You guys look kind of geeky. These guys are kind of geeky. You, sir, what's your shirt say? Drink Mountain Dew. Yep, so you're clearly going into IT. And the rest of you guys just look geeky. I'm not making any assumptions about whether or not you dated in high school or anything like that, but you can sit back down. But whenever people in executive positions, hey, dude, good to see you, good to see you. When executive permissions, stand up, dude, stand up. When people in executive positions see people like us with shifty high shirts and Security Weekly on them, they immediately think, how can we replace this guy as quickly as possible, right? You guys too, right? You guys all look like IT. You guys are wearing the uniform. The uniform's jeans and a black t-shirt. That's what we wear, right? So executives want to get rid of us. And anytime a vendor is talking about automation, single pane of glass, they're not thinking, how can they make your jobs easier? They're thinking, how can we get rid of these people who make us feel very, very uncomfortable, okay? So we need to recognize that and understand, once again, it's garbage. So why did I get into the realm of trying to do defensive stuff? This sounds really jaded and somewhat self-serving, but I've been doing offensive operations for 20 years. I've done it in the Department of Defense. I've done it on the nation-state level. I've broken into banks, I've broken into nonprofit organizations, and this sounds jaded, but the 30th or 40th time that you've taken over a bank, you don't feel excited like, woohoo! Yes! That's bank number 45! No, you're like, oh God, this crap again. What happened? They clicked on a link. What was your spearfish? It said, don't click this link. And they clicked the link twice. Well, who the hell clicked it? The security team. I'm trying so hard to fail. So when we look at the tools and the techniques that are at our disposal, we have to develop better tools and techniques. Because it's almost like an abusive relationship. And I don't want to make light of abusive relationships because that crap's not funny. But do you know anybody that's been in an abusive relationship? They get beat up by their significant other, literally, physically beat up. And they stay with that person? And if you sit and you talk to them, you're like, why in the hell are you still with him? And by the way, this is coming from some experience in me growing up in my family and some of the people that are extended families and things like that. And it ultimately comes back to hearing a cousin or a best friend say, well, this time he said he's going to stop, and I think he means it. That's the way security vendors are. They're like, yeah, we know that our AV didn't work this time, but this time we added NG at the end. You know what that means? You know what that means? Next gen. That's at the end. Do you know what's on the front end? AI. That's right. Not only do we give you the NG, but we give you the AI in the blockchain. In the blockchain. This is an abusive relationship. So some of the different backdoors that we have, and I'm going to show you some of these backdoors, is we have HTTP beaconing, okay? HTTP beaconing looks like this. This is clear text HTTP in a view state parameter, okay? Make that go away. There we go. So the backdoor is base64 encoded inside of this __ view state parameter in clear text HTTP. That's the beacon. It beacons in this particular example of the tool once every 30 seconds. View state is a parameter used in web servers to identify session information, who you are communicating with that website. And in that session information, it's supposed to be random, because that's a good quality of it being secure. And it's also variable in length. Anytime you see a vendor that's like, yeah, we can totally detect a backdoor that's in a random field that's variable in length, they're full of crap, okay? You can't do that. You'd be decoding and processing constantly, and you'd see the product fall flat on its face. So that's an HTTP beacon, and I'll show you how we detect it here in just a little bit. The other types of backdoors, social media backdoors. One of the tools in the link that I'm going to give you is a tool called GCAT. It does all of its command and control in well-formed Gmail communication. The backdoor literally emails itself the commands, executes the commands, and then emails itself back the results, all over HTTPS, all going to Gmail. Another tool that we've written called Sneaky Creepers does that over Tumblr, Salesforce, Google Sheets, and crap, there was one more, I can't remember. But it communicates over these various websites that all of the organizations that we know continue to use every single day. How do we even begin to start detecting something like that? We have DNS, DNS Cat 2. We have Quick as a protocol. There we go, fixed that. Quick is a protocol where it's multi-honed UDP. This can be used for streaming across multiple different sites using multiple ports simultaneously. And then SCTP is a lot like Quick, except it's using TCP over multiple different hosts across the entire internet. When we're using these tools and we're using these tricks, it is very easy to bypass the existing security technologies. And it got really hard for us whenever we'd go on site with a customer, break into their network, exfiltrate a whole bunch of data, and they're like, holy crap, we did everything right. How do we detect that backdoor that you just used? And we're like, crap. Because there was nothing out there that actually would allow them to detect these types of backdoors. And we got really sick and tired of telling people, have you thought of disconnecting from the internet? That's a good solution for defending against this particular backdoor. So that man's waving at you. He's trying to get your attention casually. So there you go. That's better. That's better. A connection has been made. All right. So So what we're going to do is we're going to talk about how we can detect these types of connections. And they're probably hanging out by the door. They're now thinking, all right, this presentation looks okay. Except that guy, he left right there. And they're like, this presentation looks all right. So now they're going to sit down, and then I'm going to say we can use artificial intelligence to do that. At which point they're going to be like, okay, I shouldn't have sat down. I should have went right back out and had some chips or something. But I'm going to talk about artificial intelligence, but as part of doing artificial intelligence in my presentation, I'm going to present it in such a way that all of you will understand at least one way that you can use machine learning to identify beacons on a network. Does that sound fair? So please don't leave yet. All right, because I'm not going to talk about it in terms of magical special sauce or all of these awesome things that I do not define. I'm actually going to define it for you. And the algorithm that we're using is actually called k-means clustering. Okay? And that's two different variations of k-means clustering. And personally, I think that they're self-explanatory. You know what's awesome, though, is we're at DSU. DS freaking U, right? Computer Security Epicenter of South Dakota. How many of you look at that and you're mathy and you're like, no, I can totally figure this out. Just give me 5 minutes. Come talk to me, okay? We're looking to hire people. Come say hi, all right? Because I don't know what the hell this means, all right? I'm going to talk through it, but they trained me. I'm like a trained monkey or a tickle me Elmo where I just pull the string and I tell the same thing again and again and again. All right, so this is k-means clustering, and this is the heart of a product that we've created called RITA, Real Intelligence Threat Analytics. And it kind of, to set the stage on how this actually works, how do we, wait, just a minute, hold on. How do we know that that chair is a chair? As a human being. Trust me, you don't want to get too close to it. It's got stains that honestly I can't identify. It's from the music department and it's being used on a stage. You don't ever want to put a black light on that thing. So how do we know that this chair is in fact a chair as a human being? Shape, pattern recognition. What types of patterns? Patterns like it? Well, no. A chair is a series of attributes of chairness. So what is the chairness? 4 legs, that's awesome, good. What else? It's got a backrest. Do all chairs need to have a backrest? Not necessarily. Do most chairs have a backrest? It is a little bit short. I'm sure there's a joke in there somewhere. I just don't know. I'm tired. I got up at like 4 a.m. to drive out here. So there are attributes of this chair that make up its chairness. Now, Plato believed, in all honesty, that the ideal chair existed somewhere, and that all of us were merely looking at shadows of the ideal or the perfect chair that represented all attributes of chairness, and they were all variations of that theme. Now, believe it or not, he was actually a computer scientist, because when computer scientists are trying to do machine learning and they're trying to do pattern recognition, they have to answer that exact same question that Plato wrestled with thousands of years ago. So we can apply the idea of chairness. I'm going to move this out here because it's just weird. I'm going to need some Purell a little bit later, but we'll deal with that as we see fit. We got different attributes of chairness. We also have different attributes of identifying a beacon. And I'm going to go through some of those attributes. Now, just so you know, this is just one component of artificial intelligence. There inevitably is going to be someone in the room that's an artificial intelligence aficionado, and they're like, well, that's not actually true artificial intelligence. That's actually more machine learning and pattern recognition. Those people are not your friends, and you should never play Dungeons and Dragons with them, because they're the ones that insist on reading all of the rules before they do anything. Don't hang out with them. Don't taunt them either. Just go away. So we're going to talk about identifying beacons. Now, I'm going to give you 3 different ways to kind of identify beacons. We can look at beacons and we can identify consistencies. We can identify consistencies in interval, all right? Let me explain what an interval is. An interval is like a heartbeat. It's a consistent pattern of communications. It doesn't really matter what that interval is, as long as the interval itself is actually consistent. So if it's once every 2 seconds, great, that's a perfect interval. If it's once every 5 seconds, great, that's a perfect interval. If it's 2.3 seconds, great, that's a perfect interval. We're basically dealing with the consistency of an interval. And the closer we get to the center, the closer we get to a 1 value. So if we have a bunch of connections from an endpoint on the inside of your network, RFC 1918 internal non-routable IP address, and one communicating out on the internet, we can look at all of those connections and we develop a cluster. You see, the idea of chairness is, like you said, most chairs have a back, but not all have backs. This one looks a little bit short. So even though you may have a consistency of an interval, the intervals will not be perfect. Because as much as we want computer systems to be perfect and say every 2 seconds beacon, that's going to be, some are going to be 1.99 seconds. Some will be 2.1 seconds. So you're going to see this variation on the interval. It's going to be a little bit of jitter. But what it's going to do is it's going to create a cluster. So k-means clustering identifies these clustered connections that are very close to a consistent interval. This allows for variation. This allows for a chair to be slightly shorter. This allows for a chair to not have a back. This allows for a chair to be made out of freaking swords. So, sorry, I just got caught up on Game of Thrones. Holy crap, I'm behind. Haven't even started Breaking Bad yet, but I'm behind, right? So we can find these clustered patterns of consistent intervals. Next, we can look at consistent patterns of data size. Because we have backdoors like Trevor C2, PowerShell Empire with jitter, Cobalt Strike, that can randomize their interval. And I'm going to talk about the randomization of interval here in just a little bit. But the data size for a lot of these tools is consistent. So let me go with an example of a consistent interval and a consistent data size. All right? How many of you guys have small children? You ever have a conversation with your child like this? Mom, 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 mom. Or dad, 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 dad. Has that conversation ever happened to you? All right, very good. That is a consistent interval and consistent data size. MOM, 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 DAD, DAD, DAD. Now, some kids, they start to get a little bit smarter about things. Have you ever been on an airplane or out to eat, and you can tell that this kid excels at being annoying? Where they start going, Mom, 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 Mom. That situation, the interval is dispersed and random, but the data size is consistent. That's why it's important for us to identify multiple aspects of chairness, to be flexible in our definition of a chair, and multiple aspects of a beacon to be able to identify beacons in our environment. Then we also have the dispersion. The dispersion is awesome, because let's say that I've set up a tool like Trevor C2 or Cobalt Strike, and I say I want every single interval to be 5 seconds, plus or minus 2 seconds jitter. That means it's going to be 5 seconds, but it's going to be randomized, plus or minus 2. So it may be 3 seconds, it may be 7 seconds. It may be randomized anywhere in between. Now, anytime a human being creates anything that's random, what do we actually have to call it? Pseudo-random. Very, very, very good. Because even though it is random, there's consistency. So with dispersion, whenever we're trying to identify a beacon, we can identify a center point like 5 seconds, and 50% of the connections will be below 5 seconds, and 50% of the connections will be above 5 seconds. That doesn't happen with a user that's normally clicking the internet. Does that make sense to everybody? Okay, very cool. Does that help explain artificial intelligence as far as machine learning a little bit for how computers can identify patterns? Awesome. This is what it looks like. So we identify these different categories. So let's talk about some setups and some free tools that you guys can use right now to help identify these beacons on your network. One of the things you can do is you can analyze all the traffic that's coming and going out of your network. Specifically, we want to insert ourselves on a tap or a span port on your edge of your network. So there you have the firewall. You have a compromised computer system on the right, one of many computer systems. And then we have the bad guy system out there. We want to be able to grab traffic pre-network address translation. That means we want to be able to see the IP addresses of the systems that are communicating outbound to the internet. We also want to use Bro. Anybody here using Bro? Bro is awesome. It is amazing, and it's clearly written for geeks. Have you ever tried to show bro and like zgrep statements or bro cut to management? And they're like, oh God, he's doing this again. He went to the dark place. You mean the command prompt? Yes, the dark place. But there's ways that we can make that easier. So we can use bro to identify patterns and log those patterns. And then we can use Rita to do analysis on that data and let us know of the interesting communication pairs that would fall into the artificial intelligence machine learning area. We love using Bro because it's fast. Bro is supported by a number of universities. A lot of money gets put into Bro. Bro is at the heart of a tremendous number of computer security products that are out there. Large user base, lots of support, has very strong consistency. Whenever we're checking for those connections, those mom connections, we need to make sure that the date timestamps are pretty close to accurate. This is important because if you're using a SIM to grab that information off of a collector, it gets very wishy-washy. When do you actually define when a connection occurred? Do you define that connection occurred at the beginning of the connection? Do you define when that connection occurred at the end of the connection? Do you just average the two and just somewhere in the middle go for it? Do you define whenever that connection occurred, whenever it was logged to the SIM? And all of these really horrible things happen on a very regular basis. And what's worse is even within vendors, they can't get it straight. So we used to do a lot of analysis on like Logarithm and Palo Altos. And one of the devices we looked at, it would log a connection at the beginning of that connection for half the day. And then around noonish, it switched and started logging it at the end of the connection. Why? No frickin' clue. It just decided, I'm just going to change things up, throw you a curveball. And it was almost impossible to do good, solid data analytics on those connections. Also, we're trying to get away from signature-based detection. There are far too many ways to obfuscate the connections that are being made out of an environment. We need to be able to start looking at that pattern and those frequency analysis as well. So Rita is free. It is also the source of all of the data that I'm going to cover, except for some third-party websites that you can use. We created Rita as a response to a lot of the organizations we were testing. They honestly could not detect the types of command and control that we had created. So we created Rita as an open source project that anyone in this room can use and contribute to, that we can share with the community. Just a few weeks ago, I finally got note, I hadn't talked about this publicly, but we finally have the patent for the types of frequency analysis that we're doing in Rita, for using frequency analysis for malware detection. The reason why I got a patent on it is so that I could keep it in Rita and I didn't have to worry about any evil large corporation getting a patent on it and shutting down absolutely everyone else from doing this type of research. So Rita is free. You guys can set it up and run it. In fact, there's a lot of you, I'm sure, that are just getting started. It's written in Go. We use a Mongo backend. You've got all kinds of cool things built into it. You're like, I don't know what any of those things are. That's fine. If you just ran Rita, installed it, set it up, configured it, and ran it, even at home, and you gave us feedback on the features that you wanted, or if it blew up when you tried to install it on version X of an operating system, that is actually supporting the community. And we want as many people as possible using these tools to support this project. And yes, complaining and saying it's broken or it needed to do X, Y, and Z are just the things that we want to get from the community as a whole. Just be nice. Don't jump on our forums and be like, hey, you know this free thing that you gave us? It's crap because it didn't install on my Dell Optiplex 110 from 1998. It completely failed. It's a complete crap product. It's free, folks, as in speech and in as beer, all right? It's out there. You can use it. Please contribute it. And also, that's just not for this project. It's any open source project. If you ever find yourself going on the mailing list of an open source project and getting mad at the developer, you're an ass. It's time to pause, reflect, step away from the keyboard, and go bang your head on a wall for a while until you come to your senses and realize the people that are doing these projects for free are actually really nice people who are doing these projects for free while you're probably playing Quake or something, all right? So, as there's kids in the room that are like, Quake, what the hell's Quake? Why the hell didn't he just say Titanfall or something else? Call of Duty, anything other than Quake. So it's free. Please go out and give it a shot. So I already showed you guys what VS Agent looks like with the beaconing connections. And this is very hard for a lot of security appliances to detect. We had one awesome firewall vendor. I shared this in one of my classes. and the firewall vendor got to looking at it, and I told you it's a base64 encoded parameter, and the vendor was like, oh, we got this. Yeah, you see how it always starts with EYJJB21? We're going to write a signature for that string. I'm like, it's base64 encoded. All we have to do is add encryption and a key, and you're not going to be able to detect it. Oh, crap. So it's really hard for vendors to detect this because the pattern itself of the actual signature is always changing. It is always variable in what it does. Well, that's VS Agent. The next one is DNSCat. Now, DNSCat does all of its command and control in well-formed DNS queries. But let's talk about what DNS is, because some people may not be familiar with what DNS is. So I'm going to go with an old example. Have any of you guys ever seen a phone book in your house, like your mom or your grandma keeps around and insists on keeping it? Any of you argue with your mother or your grandmother, like, why the hell do you keep a phone book? We have Google. And they go, well, what if we lose the internet? We have our phones. What if we lose the internet and the phones? Then we stock up on water and ammunition, and we ride out the zombie apocalypse. You know, at any rate, a phone book is an analogy. With the phone book, if you wanted to look up a business, like I went and I ate at a Chinese restaurant, what's it called downtown here? China Moon. I felt like it was a time machine. I went in, and I was like, this is a Chinese restaurant just like every other Chinese restaurant. That's not the time machine part. But like Marty McFly, I ate my lunch, and I went up to pay, and I was transported to 1987. They don't accept credit cards. I was a little bit shocked by this. And they looked at me like I was an idiot. They're like, we don't accept credit cards. Why? And they made me walk across the street and get cash, which is just dirty. I mean, that's just, you guys are starving college students. Go. Anybody have Purell? You do? Of course you do. Appreciate that. I can't get the crap off my hands fast enough, and they're like, yes, we're going to Taco Bell after this. Oh, thank you. Thanks, man. Thanks. It's awesome. All right. So cash, it's dirty, is what I'm saying. And by the way, if there's cocaine on that money, it's not mine. Dude, if I'm snorting cocaine through a $10 bill, I've hit rock bottom. Okay. All right. So with DNS, you use a phone book to look up a name like China Moon. And then the phone book gives you the phone number for China Moon. With DNS, it's very much like that. You try to go to a website like google.com. Your computer has no freaking idea what www.google.com is. None whatsoever. So what it has to do is use DNS to resolve that name to an actual IP address or a number. Now here's where this gets interesting. If you're on your home network or you're here at school, and you make a request for google.com, it's probably not going all the way to the Google phone book to find that number. The local DNS server caches that answer, so anybody else that asks that same question will be able to get that answer very, very quickly. It's a time to live value in a DNS record. Does that make sense to everybody? So if you're using DNS as a command and control, the subdomain, like www.mail.google.com, maps.google.com, that subdomain needs to be randomized every single time. So here, you can see that we have randomized subdomains for every single request going to cat.nanobotninjas.com, right? So this allows all of the traffic to go through, all the way through to a DNS server that supports recursion, and it makes that full connection all the way over to the domain nanobotninjas.com. Now, does anybody know, based on this DNS log in Bro, what is the DNS server that is giving the responses? Google. You know that because the IP address is 8.8.8.8, all right? 8.8.8.8. Now, here's something that I'm going to talk about a little bit later with GCAT2. Most security appliances ignore everything that goes to Google. Why would they ignore everything that goes to Google? It's Google, right? What else do we got to say? It's like Facebook. They're a good, oh, crap. No, wait. It's like no. It's like Uber. No, crap. Okay, it's like Tesla. Tesla wouldn't kill it. Oh, dang it. All right, anyway. So Google is ignored for two reasons. One, because it's Google. And two, whenever you're talking about a security appliance, it's all about throughput and performance. And if you ignore everything that goes to Google's DNS servers, everything that goes to Google itself, everything that goes to Gmail, you can do a lot more throughput because that cuts down a tremendous amount of traffic. Does that make sense to everybody? Super cool. Let's keep moving on. So we can actually detect these types of beacons, and I'll show you how here in just a couple seconds. Also some housekeeping. Please, whatever organization you work at, do me a solid favor, block ads. You can do this through OpenDNS, you can do this through Umbrella, you can do this through Pi-hole, you can do this through almost any firewall appliance that you have. You can go into categories, especially for your egress proxying, the proxying for web traffic that's leaving your environment, and you can go in and select ads. Block them. Please do that. The reason why is ads look a lot like malware because ads are a lot like malware. So please filter ads out of your environment, okay? Just get rid of them. Your life is going to be so much better if you do so. We actually were working with a customer a while back, and we convinced them to remove ads. And they got it done, and their security team was happy. They looked well adjusted. Everything was fine. And they're like, that was good. Killing ads is one of the best things we did because most of your infections come into your environment through what? Ads. It's not porn. I know some people are surprised by that. But it's actually through advertisement. So their infections went down. It was easy to do threat hunting, marketing. Tried to go to a website and view the ad for their own company. The ad didn't load. They went all the way up to the tippy top to the CEO, and they're like, you know what the security team did? And I'm picking on you guys because I gave you money. That's a weird relationship. Just roll with it. So they went up to the CEO, and they're like, you know what the security team did? They blocked our advertisements on the internet. So they go to the security team. How come you're blocking our ads? Well, we're not just blocking our ads. We're blocking all ads. Is there any way that we could allow our ads? No, that's not how it works. Well, you've got to fix this. Well, the only way we could do that is by turning ads back on. You must do that right now. It's like, oh, God. They literally turned on every single ad on the internet simply because they couldn't allow only their ads into their company because they wanted to show corporate spirit and corporate pride. So don't work for those companies, guys. Just don't. Those are the bad ones to go to. All right, I want to show you a couple of different beacons that we detected that I thought were fun. This was kind of, I have this typo everywhere. That's what happens whenever I do slides while I'm drunk. So, all right. So, I wasn't drunk. We were talking about, never mind. All right, so, so whenever we're looking at a couple of different malware specimens, I talked about Quick Protocol and SCTP. Now, the way this works is you stand up, if you're Netflix, you stand up multiple different servers online, and instead of streaming movies from one server to your computer system, it's going to stream that movie to your computer system simultaneously across multiple different endpoints on different parts of the internet. This allows you to use more ports. It allows you to more effectively use the bandwidth on your system and utilize the ports more effectively. And this is also something that's required whenever you start streaming movies in 4K and they're monstrously large. A simple TCP socket may not be enough for that, so you can load balance it and round robin it as well. So we saw this backdoor that was installed on a bunch of phones, and we had a number of IP addresses that were making the consistent pattern connections to 3 different IP addresses that we saw within the time frame that we sampled back to China. They had the exact same frequency, they had the exact same dispersion, and they rotated from IP address to IP address, making these connections to these systems. Now, it was interesting, it was only about 50 packets per system as it round robin whenever it was working. So we thought they were mobile devices. We thought they were iPhones and all kinds of different devices because it was on their wireless network that they allowed guests to use. When we started researching, we found out that what was actually making the round robin connections back to China was actually their video system for physical security. Their system was basically sending telemetry and data back, a lot of data, back to the mothership back in China where this particular device was manufactured. Because they had a very low count of number of packets, because it was randomized as far as the dispersion, but the dispersion was still uniform. It was randomized within a certain frequency interval. We were still able to detect it using RITA. So a very, very, very cool set of backdoors that we were able to pull out of a customer's network. The next one, okay. This made no sense at all. This is one of those few times where I started getting really, really uncomfortable. We had a customer that had thousands of systems that every single day, every single 5 minutes, every system would make a connection back to an IP address, something like 9.8.17.18, which that IP space is owned by the Department of Defense, by like these guys over here. Sorry, you guys kind of stand out. Not as much as these guys. These guys are now targets because they got cash. They're straight rolling in it. But it was going back to DoD, right? Constantly going back to Department of Defense. Every single IP address, every 5 minutes. So I look at this and I'm like, tool's broken, something's wrong. Sure enough, we looked at the packets. All of their systems, thousands of systems, were making connections to the Department of Defense in very consistent intervals over and over and over again. So we went to the customer and we're like, okay, so this is weird, but you have systems that are communicating back to the Department of Defense constantly, every single day, every 5 minutes. And the customer was a little bit paranoid. They freaked out. They're like, oh, this proves that the NSA hacked us. Now, I have a little bit of experience with that in my classified years. We never did that, right? I mean, we never attacked anybody, and we're like, hey, you know what? How about we have this just call back to the Department of Defense, right? I mean, seriously, if you guys are doing cyber offensive operations, isn't that like page 1? Don't have malware call back to DoD. That's what they call bad, right? You just don't do that, right? They're like, no, it's the NSA, and they're calling back to DoD. And I'm like, once again, no, they're not doing that. So we got to looking into it a little bit deeper, and then the theory on the customer side morphed from, instead of it being DoD that hacked them, well, clearly, the shadow brokers had compromised a backdoor that was written by the NSA or the vault breach from the CIA, and they were using a backdoor that was calling back to the DoD. And I'm like, they don't do that. That's just, no, they just don't do that. And it's funny when people are like, well, how do you know? And it's like, well, I don't care if my clearance is revoked. All right, so let's go. But it's not how things work, folks. So we started researching, and sure enough, it was one of the core executables that this organization used. We took this executable. We took a packet capture to one of the developers of this application. And the quote from the developer was like, wait, 9.8.17.18? You know what? That's really weird. That's the same version as our product right now. The update feature was broken. It was supposed to go to an IP address and say, here's my version, is there an update? And they swapped. So it was going to an IP address. It was going to the DoD and saying, here's the IP address of our update server. Is there an update for me? Over and over and over again. So all of a sudden, the entire conversation shifted from, we're taking down the DoD to, oh God, do you think they're going to come after us? And I'm like, 2 things. 1, you'll never know it. And 2, it won't make any difference at all if you do. It's like, once again, you don't want to say that to a customer. They kind of freak out. It's like, no, it's cool. They're going to kill you. It's going to be a surprise. Or not, whatever. So the lesson on this is sometimes beaconing data is not evil. This is why trying to train artificial intelligence to do your job is a really bad thing. There are vendors that show up that like to say things like, we're going to train artificial intelligence to do all of the security analytics, and we're going to put it into this really, really big computer, and then magic's going to pop out because it's like a unicorn, and it's going to fart Skittles, and it's going to be amazing, and rainbows. And you smell that? That's smelling the rainbow. That's better than tasting the rainbow. It's great. But the data that feeds into an artificial intelligence machine learning system is incredibly important to what that machine learning algorithm puts out. Have any of you followed stories where they tried to take really, really expensive, well-known named artificial intelligence and put that on Twitter as a Twitter bot? How does that usually work out? It starts out at the day, it's like, hey, do you like cheeseburgers? You're like, I love cheeseburgers. I love cheeseburgers too. We love cheeseburgers. Going back and forth about cheeseburgers. And you know what else is really good? Cheeseburgers and fries. Cheeseburgers and fries. I love cheeseburgers and fries. And then you say, I love cheeseburgers, fries, and then it's like, yes, Hitler is fantastic. I love Hitler. Sick Kai, would you like fries with that? Ding, fries are done. Ding, fries are done. And before it's over, it's like the most racist bot on the internet. It doesn't have context, people. We keep thinking that we can train artificial intelligence and it'll do our jobs for us. This is why Stephen Hawking and Elon Musk are terrified of artificial intelligence, because when you train something that has the automated capability to do something else, you can train it to do evil. And what sucks is when Skynet goes active, it won't even know that it was evil. It'll go live, nuke all of us because some jackass troll on the internet decided to think that, hey, would you like to play a game? I'd love to play a game. How about chess? How about thermonuclear war? Okay. No. They had it backwards. It wasn't going to be Matthew Broderick. It was going to be, I don't know. So this requires the artificial intelligence to look for patterns, bring those patterns to a human who understands the context, and then let us make the decisions. These tools should be enabling us. They should not be replacing us. God, I sound like a Luddite. Did anybody watch the Animatrix from the Matrix sequels? I sound just like one of the guys in the animated series that, they started killing the robots, and that, once again, ended really well as we turned into light bulbs. All right, so on the topic of blacklisting. So with blacklisting, there is still a tremendous amount of value in looking at an IP address that is on a blacklist. If you have an internal system that is making lots and lots of connections to a blacklist, you should look into it. Now, it doesn't immediately mean that it's evil. It just means that something on that IP was evil at one time. You can have old entries, you can have virtual hosting, you can have round-robin load balancing. There's a number of reasons why an IP address may be in fact evil, or it may be the exact same IP address and it's not that bad at all. So you have to be very careful. So what should you look for when you're looking at a connection to a known blacklisted IP address? First and foremost, if that IP address shows up on one blacklisted entry, there's about 47 to 52 different active blacklists on the internet. By the way, they all steal from each other all the time. But if an entry just shows up on one of them, I usually don't see a single blacklist hit blow up to the point where it's full malware in an environment. It just doesn't happen. But whenever I start seeing an IP address that shows up on like 5 to 10 different blacklists, all of a sudden, I start getting really, really concerned. What would I look at next? What I would look at next is how much data was actually transferred. You see, it's very, very common for systems on the inside of your network to visit IP addresses that are on blacklists. The vast majority of time, it's ads. Your system went to a website and it loaded content from an IP address. That was an ad server that was hosting malware. It was on a blacklist. You would see 1 or 2 hits, okay? So it would be a low number of connections, but it would also be a low number of data transfer between an internal system and the outside. Like you're looking at it's gonna be under, a few thousand bytes. It's not gonna be that much, okay? Now, if you see a number of connections that's very high to that blacklist, that's a concern. And also, the bytes transferred. If you have an internal system that's connecting outbound to an external system, and you see megs and megs of data being transferred, it's time to freak out properly and start taking that system offline. Also, a note on porn. There's going to be a lot of porn. If you're involved in this community, just so you know, and you're new, anybody here in college looking to get into computer security and you're all excited about the future, that's awesome. Like, must be a good career. The guy just throws money at us. If porn makes you squeamish, if you're like, well, that's just morally reprehensible, I'm not going to argue that point. But this probably isn't the field for you. There is a lot of porn on this field. And I know that some of you are like, how much porn? So much porn. So much porn. There are literally people that I'm pretty sure they go to work and they spend 8 hours a day surfing porn. That's it. That's all that they do. So just be prepared for that. They're not going to teach you that in college. They kind of expect you to pick that up on your own, but it's something that you should know. Also, you see from time to time good websites that go bad. This was a website that a particular group of people, it was formerly a hospital, and it was a legitimate healthcare website. And it was basically taken over by the bad guys, and they were using it as a C2 channel. So you're going to see that too. Also, spyware is very strange. This is so far one of my favorite finds in a hunt team over the past, I would say, 18 to 24 months. I saw this one connection that was coming out of an environment, and it was an internal system that was trying to make a connection to revsci.net again and again and again and again. And I'm like, wait a minute, that seems familiar. What the hell is that? I Googled it. Once again, hey, we use Google. It happens. It was spyware from 2007. This is a Windows XP system that hadn't been updated and still had spyware from 2007 trying to connect out to the open internet. That was awesome. Whenever they went to the end user, they're like, this is bad for a number of reasons. The first thing we're going to do is we're going to replace your operating system. This particular individual freaked out. They didn't want their computer system to go away. They're like, I've got it set up just the way I want it. It's running Windows XP, so that's bad. Also, if you want to know what a compromised server looks like, this is what it looks like for like a third-party server that's compromised. You're going to see a lot of weird ports that are open, and then oftentimes like a weird backdoor port like 2222 or 4444, and then also a port like a database port that's open. So this is kind of what I do in a hunt team. I'll use a non-attrib burnable system and do a port scan of a system that their internal systems are connecting out to, and then usually I'll find out that it's compromised itself. This is also one of my favorites. This was really cool. This is actually a system, not system, there's about 4 or 5 systems in this network that were all beaconing out to this particular IP address, and they were all running Bitcoin, or not Bitcoin, they were running Ethereum mining in their browsers. This is actually the new hotness as it exists today. So that's really, really cool. There's also a number of online resources, IP and URL void. Check and see if an IP address is malicious or a URL is malicious. BGP ranking is also really cool as well. So I wanted to show you what some of these things look like whenever you're looking at them. So the first one I talked about was VS Agent. And this is what VS Agent looks like in a nice representation that a human being can pick up. So human beings are very good with visual data. And if I say, where's the pattern, you're going to very quickly see the pattern here along the bottom graph. This is the day and the number of connections, or the hours of the day and the number of connections. So every single hour has just over 300 connections. This is a consistency in pattern for tools like VS Agent. And almost all the connections, over 8,000 of the connections, were 10 seconds apart in interval. Next one I wanted to show you is GCAT. Let's do DNSCAT first. So DNSCAT looks like this. You can find it by subdomain analysis. I talked about cat.nanobat.ninjas. And if you have a single domain that there's 30,190 subdomains, that's a backdoor. Sorry, it is. Not even Google has that many subdomains associated with them that your users will go to. So if you have a system that's making a lot of connections outbound to a domain and there's multiple subdomains, that's a quick, easy way of identifying it. And the final one, social media backdoors. I want to show you what they look like whenever they go through Rita. This is GCAT. It wasn't our first hit because it's kind of a weird backdoor. But this is what GCAT looks like whenever it runs throughout the course of a day. And with GCAT, you look right here, you have a very strong frequency count in the interval in seconds. And then the data size is also very, very, very consistent as well. So you're going to end up with some level of randomization. You have all these outliers in the data size, but the vast majority of them, over 500, are the exact same size, over and over and over again. So with that, I want to basically kind of close this out with what did you guys think computer security was going to be like? Whenever you enter this field, you think that computer security is going to be this dynamic, fun field that you're going to be fighting and chasing bad guys through cyberspace. And what you ultimately get is certification and accreditation, which has its value, and you spend a tremendous amount of time doing reports, PowerPoint presentations, trying to convince people that starts talking about things like risk-based decisions whenever they don't know what actually is involved in risk itself. They don't understand vulnerabilities, they don't understand threats, they don't understand likelihood of impact, they know none of the parts of the formula that develops risk. But that's our job. That's what we have to do. It is not, unfortunately, and I'm sorry to say, spending a whole bunch of time with a Nintendo Power Glove, which is awesome, or spending a lot of time with an attractive member of the opposite sex trying to stop a hacker who's trying to break into your firewall using JavaScript, which is weird. By the way, I had a friend that talked to one of the script writers for the show, and he said this is insane, this is the dumbest thing that he had ever seen, and the script writer was like, I know, right? Apparently, in Hollywood, there's a competition as far as which scriptwriter can get the dumbest thing put into their show. And this scriptwriter won in the group of scriptwriters whenever they were setting up computer things. There was 2 people on the same keyboard. And then shortly after this, they were one-upped by a movie or TV show called Scorpion. Have you guys seen that? Where the airplane and they have to drop the LAN cable down into the Ferrari underneath it to stop the bomb from going off. That person took the crown. So in conclusions, 1, detecting command and control is getting harder and harder. We released Rita to help with that. I honestly believe that Rita is just the first step. It is, without question, the first step. We're not trying to sell you magic sauce. We're telling you that you're going to spend a lot of time going through false positives. You're going to be whitelisting out sites like Microsoft.com. But it's a lot more interesting than just waiting for the IDS alert to go on. Also, there are a lot of other free resources online to help with this. It does require a lot of digging. And odd does not necessarily mean evil. It requires us to be vigilant. It requires us to be active in what we are actually doing whenever it comes to computer security. You in this room will not be replaced anytime real soon at all by an automated piece of software that's going to solve all computer security issues. Our computer security issues are as varied and dynamic as the computer systems and the individuals that we're supporting and we have to protect. That requires a human being to be part of the mix. But yes, we can use artificial intelligence. Yes, we can use tools to make our jobs easier. Never do our jobs for us. Thank you so much, everybody. I appreciate it. Get out of here. By the way, hey, where are the Dakotacon people? Do we have the Dakotacon people? Awesome. Isn't this cool? Do you remember the first and the second years? There was like 10 or 15 people. So a round of applause for the people at Dakotacon for making this an awesome conference. And then can I do one last thing? One more? One more thing. If you like this con, we saw Dakotacon and we're like, my God, that's awesome on the eastern side of the state. If you guys want to, check out Wild West Hackin' Fest. It's the West River HackerCon. And by the way, I'm going to give you guys a discount code. It's like half off, or I think it's actually more than that, for college students. So if you can hand that out, we want to make sure that we make this a sister conference to what we're doing, and we want to support as much as possible. Hopefully we see you guys in October. Thanks. Wasn't on.
If you are missing your hotel room keys, you can either find me or maybe find me in your hotel room tonight. So either or.
So we got some other people from Trusted Sec here. Both of you guys are Trusted Sec. Can you guys stand up and say hi? This presentation about red teaming getting harder is absolutely true. We're seeing it all over the place, and it's a damn good trend. In fact, we just got done with the red team that these guys purple teamed before we got there. Has Dave told you guys about this? You drove 2 of my pen testers to drink. So, yeah, now you get it. Thanks. So this is going to be an awesome presentation, so stick around. It's going to be a good one.
To make sure. You guys hear me? And I got to make sure my wife's not going to text me in the middle of this. Because that's important. And displays. Engine. I want mirror off. Should be good. You guys see that? Yeah? What's that? Do I seriously have John Strand's cell phone? That would be amazing. No. Sucks. Dang. Sorry, man. Well, thanks so much for coming. How about that for an awesome talk? Yeah? You can see you, John. Take care. Thanks for coming, buddy. And thank you, since you're applauding, please give Dakotacon a round of applause. This has been fantastic. So, Dakotacon, thank you so much for having us. This has been wonderful. So, this talk is called Blue Star Rising. And in fact, I had a friend of mine, Justin, who might actually be watching the live feed now. And I was like, Justin, I have to come up with a talk. He's a coworker, and I was like, what do I talk about? And Justin, who's also a red teamer, he said, you should give a talk called Massive Defeat, the story of modern red teaming. Because red teaming is getting harder. And that's fundamentally what this talk is about. So if you are doing CCDC or things like that, or you are actually a professional doing red teaming, and you're probably noticing a trend. And the trend is that controls are getting better. You're probably getting caught. And you might be getting caught in kind of embarrassing ways. At least that was my story. And so that's fundamentally what this talk is about. So I've framed it up a little bit better than basically just getting owned all the time on my own test. But that's kind of what this talk is about. So who am I? Turn that on. Who am I? I'm a senior security consultant with Trusted Sec. My primary job is to do red teams, pen tests, social engineering. I'm an operator. I like to use Cobalt Strike. I like to get shells. I'm kind of red team to the core. However, previously, I was a blue teamer at a Fortune 500. I did a lot of work with Active Directory and PKI administration, things like that. You can find me on Twitter. Some things I really enjoy. I love doing payload development, and I love doing evasion work. Those are 2 things that I just giggle about for some reason. So if I have AV that I'm working on and I'm able to fire a payload that just sneaks around that AV, it just makes me happy. You do this like the happy hacker dance, right? It's great. In conversation starters, I have nothing to do with technology. So if you're into beekeeping, come find me. So goals. What does this talk about? I like to start out every talk with a discussion on goals. Number 1, I want to give you current status and strategies for modern red teaming. It's not your grandpa's red teaming. This is modern red teaming today. Okay? And number 2, to give credit where it's due. And this is part of a personal philosophy that ego destroys everything. And there are a few slides where it was difficult for me to write. I had to check it. I had to keep my desire to get shells in check and tip my hat to the organizations where it's due. And we'll talk about that. And last is to openly discuss failures and lessons learned. I believe we don't necessarily learn from our successes. Or if we do, we don't learn as much from our successes as we do from our failures. If we fail on a test, okay, or if a customer fails to prevent an intrusion, that's a valuable learning opportunity, and that is something that should be seized and not necessarily shunned. So I'm going to talk about failures, and I'm not necessarily going to talk about customer failures, because I'm going to talk about customer successes. I'm going to talk about red teams where I got in, or I didn't get in. Who am I kidding? I'm talking about red teams where I was stopped almost completely, and what these customers did right to stop me. Because I like to think that I know what I'm doing. I could be totally off on this, but I like to think that. I know how to operate hacker toolkits. I know how to execute privilege escalation. I know how to do payload development, and there are some instances where I was just shot down completely. And I want to talk about that because those are important lessons that I think we can all learn. But first, I need to kind of set the stage here. So one of my first jobs, my first engagements when I started with TrustedSec was Dave brought me in. He's like, all right, Jason, we have this advanced red team coming up against we'll call it a military-associated organization. I'm not going to tell you who, it doesn't matter. Let's just say that this company knew what they were doing. They knew not just how to implement controls properly, because a lot of times when customers buy security controls, they neuter it. They like cut out 90% of the functionality just so they can get into production. Okay, but this organization knew how to tune their controls, and more importantly, they had a blue team that was engaged. Okay, and let me tell you right now, red teamers, actually, before I go any further, who's red team here? Who's red? Who's blue defense? Most? Oh, this is going to be fun. And who's like undecided? I see a bunch of unraised hands. How many of you in college? All right, few, okay. All right, so anyways, so what we were up against this advanced blue team that was associated with the military. Okay, and just to give you an idea of how evil Dave is. Dave's not here, so I can talk about it. So I'm going to tell you a little bit about Dave Kennedy. He says to me, he's like, all right, here's what we're going to do. He said, I have this idea for an awesome fish. He said, we're going to find an organization that caters to disabled military veterans, and we're going to fish this company with that. I was like, what? Like that's like crossing some sort of ethical boundary, Dave. He's like, no, they're going to love it. I was like, all right, sweet, let's do it. So my job was to come up with a fish. Right, so I go online and I start researching these organizations, and I found an organization that catered to taking care of homeless veterans. All right, let me tell you how horrible this was for me to put together a fish where I'm like, yeah, there's these homeless vets, and I think I threw in like amputee stuff. I mean, it was bad. All right, in fact, it was so bad that everyone at TrustedSec went and donated to the Semper Fi Fund because our consciences were just wrecked after this. All right, so we have this killer fish. All right, I tested the payload. Payload worked around a bunch of controls. I was happy. Like, all right, time to fish these people. So we send a fish. All right, I got nothing. No hits, nothing from Apache, absolutely nothing. And I'm like, okay, something should have happened, even if it was virus total. So if you send a fish and you are up against like an advanced sandbox, maybe that's Proofpoint or something like that, it's going to grab your payload, it's going to fire it, and you're going to get a shell from Johnny Cage. That's exactly what might happen. You're going to get a shell from a user that you know it has nothing to do with the organization that you're testing. And we sent this, we got nothing. And we sent more, and we got nothing. We came up with another phishing campaign. We sent that, worked around a bunch of payloads, got nothing. Seriously, not even a click. Nothing in Apache logs, nothing. And we're getting frustrated. Okay, we did a full external test on it. We found a few pages that we could brute force. We got nowhere. All right, and so we had to put a report together. And so we got on the final report delivery call with them, and we started talking to them. They bring on their entire blue team into this call because they know what's going to happen. They know TrustedSec's going to have to eat crow. All right, so they bring the entire blue team onto the call, and so we start talking through all these things that we did. And we talked through, and we're like, you guys did great here, you did great here, you did great here. And you want to know how the call ended? Here's how the call ended. With the blue team congratulating themselves, applauding, with us on the phone. And their last words to us was, we'll see you next time, TrustedSec, you should step up your game. It's a true story, 100%. And here's the problem. I have no success to that. Like, I would love to say, you know what, Q2, we smashed it. We got shells everywhere. We didn't. We didn't. Okay? Those guys knew what they were doing. To this day, they know what they were doing. And I have to tip my hat to them because not only did they detect everything that came in, they pulled apart our payloads. And they were like, oh yeah, you're using this framework to run this attack. We've seen this before, blah, blah, blah. What else do you have? Okay? And so we were up against an advanced blue team. Now, this is kind of the mindset with which this talk was formed, because some interesting things started happening. Whereas before, we were getting shelled. I remember doing a week-long pen test that at Social Engineering. I could easily kick out 3 phishing campaigns by day 3, have shells all over the place. Okay? Domain admin by Thursday or Friday. And it worked continuously. But something started happening. We started getting caught. And I don't just mean getting caught by like a particular control. I mean, we started getting caught across the board. We started getting caught with our landing techniques. Macros and binaries are preferred. We started getting caught moving laterally, okay? Oftentimes lateral movement can take the form of things like persistence, or, sorry, not persistence, but WMI, firing via PowerShell, all that stuff started getting caught. Persistence techniques, those are gone. You can't write anything to the registry. You can't schedule any tasks anymore. Okay, even simple tradecraft, like doing things like net user, now gets picked up by certain tools. Okay, and although for some inexplicable reason, I can still drop a 64-bit binary to disk and nothing catches that. So riddle me that one, blue team. But anyways, so who started detecting us? Where did that start? Who started picking us off? And this is actually the hardest slide that I've had to write because I love picking on vendors. I love it. Okay, and in fact, I'm going to pick on vendors in this talk. All right, and here's the thing. The reason why I love picking on vendors is because they love picking on me. If they just let me get shells, we would not have a problem. We would be friends. But they want to stop me, and so I generally pick on them. But vendors are the ones who started catching us. And by vendors, I'm talking specifically Microsoft Defender. Defender is now a top-notch AV solution. Okay, and it's getting integrated in some very interesting ways, especially in future operating systems. In fact, Microsoft just released a note that said ATP, is now, which is basically the Cadillac solution of Windows Defender, is now going to be integrated into Windows Server 2019 out of the box. All right, and that's going to make red teaming very interesting. Okay, Carbon Black is another one. If you're not familiar with Carbon Black, in fact, they're the ones that I'm going to pick on the most, just because I've been doing a lot of testing with Carbon Black. But if you're not familiar with what Carbon Black does, it basically dissects the parent process chain of something as you fire it. So in other words, let's say I send you a macro, and I send you an Excel-based macro, and that macro kicks off PowerShell, okay, or it fires a command.exe/c/q, and then it fires my evil audience. What you're going to see in Carbon Black is you're going to see excel.exe, little chain that says cmd.exe, and a little chain that says PowerShell.exe, and then boom, 10 out of 10, evil. That's what you're going to see. CrowdStrike basically does the exact same thing. But they started catching us, okay, and this kind of was our introduction into the next wave of EDRs, okay, endpoint section response. Now, when I talk about next gen, we have AV, which catches like binaries, all right, and some AV you can turn up like for example, semantic endpoint protection. You can turn up reputation filtering. Okay, so if it comes across a binary that it doesn't necessarily know what it does, but it was made in the last 2 days, you can shut that down. Okay, but next gen stuff targets hacker tradecraft specifically. In other words, if I run a net use command, or I run a GP update force, or I run whoami/groups to do internal reconnaissance, some of these EDR procs will start catching that. So it starts interrogating and looking for hacker tradecraft. This is a little disconcerting to me because I rely on some of those things that aren't necessarily malicious in and of themselves to give me information. All right, number two, they inspect the process chain, just like I told you about what Carbon Black does. And number three, they monitor low-level API calls. For example, this is one of the things you'll actually see in the Carbon Black log. All right, script beacon.ps1, this is something that I generated from Cobalt Strike, and then I obfuscated it with invoke obfuscation. And then I put an AMSI bypass in front of it, okay? Attempted an unknown operation by calling the function create thread. The function was blocked by Confer. Confer is a company that I believe Carbon Black acquired. Okay, so in other words, it's not just looking at the PS1 file. It's looking at the functions that that particular PS1 file is executing. And that's what it's keying off of. So there's more intelligence now that goes into these products. Say for example, CrowdStrike. Very, very similar. Okay, you see Explorer firing CMD, firing this particular file that has this hash. And here's what kind of frustrates me about EDR products, is that you look at this, and it just says this file meets the file attribute ML algorithm's high confidence threshold for malware. Okay, machine learning is taking things to a new level because I like to think that there is someone sitting there looking at my stuff specifically, writing a signature for my stuff specifically. No, that's not what's happening. In fact, Jessica Payne actually put up a tweet about this. It's pretty instructive. I'll give you a second to read it. In fact, while you're doing that, I'll get my water. But she said something interesting here. She said AV is detecting you because someone threw the samples at Virus Total. It's detecting you because the stuff that you wrote looks like a virus. And this was interesting to me because you can do sandbox evasion and sandbox, all kinds of sandbox detection, stuff like that, that might not get caught, but at the end of the day, if you fire PowerShell -enc with some sort of evil stuff that calls create thread or calls create remote process, and that sends off a shell somewhere, that behavior is now getting keyed off of. And if you don't understand that behavior as a red teamer, if you don't know what your tool is doing as a red teamer, you're going to get caught. And then you're going to be on a phone call where people applaud themselves until you step up their game. It's not an enjoyable moment. Okay, but here's the real rub. Here's where the problem is. Because in spite of these tools, and these tools are good tools. I'm not knocking them. I'm not just saying don't buy them. That's not what I'm saying. These tools are good tools. They detect me. They detect my coworkers. They detect even advanced tradecraft that we throw at it. I'm not saying don't buy the tools, but what I'm saying is that I'm still seeing places where things like season year for a password, I'm still getting in with that. I'm still getting in single factor with season year because I brute forced a portal. Somebody had winter 2018 or winter 2018 exclamation point or winter 2018 pound or winter 2018 dollar. It's always the same. Okay, I'm still getting in with those passwords. Bob can still RDP to the DC. There's a problem with this. All right, Bob in sales should not be able to connect to a highly sensitive system on an administrative port. There's no network segmentation. I'm dealing with a totally flat network. All right, if I fish a target and I land on that target and I get a shell, all right, and I start doing reconnaissance, and then I do like a port scan against a domain controller, or I do a port scan looking for a 3389 and I see it against the domain controller, or I can get out to a Linux server on port 22, all from Bob's machine. There's a problem because that means that that network totally flat. No inspection being done. Okay, I can just go anywhere I want willy-nilly on that network. All right, that's an issue. That's a core issue in my opinion. Number three, there's still PI and clear text everywhere. I can't tell you how many banks I've tested where I eventually land my way onto a SQL database, Social Security numbers all over the place. Okay, Social Security numbers all over the place in an application maybe running locally. In fact, I was doing a pen test where one of the very first things that I did, I just started looking through basically the Windows 7 version of Network Neighborhood, right? You just pull up the network, you start looking through the various systems. I found one system that was like SQL Prod 1. I double-clicked it. There was C and there was D, 2 folders. So I go into the C drive, open to the public, and there it's not a joke, datadump.txt, 12 megabytes. Take that file, open it up, boom. There is an entire dump of their customer database, 15,000 records, all plain text Social Security numbers. Because some helpful DBA decided, I'm just going to make a backup right here to this publicly open share. Okay? Still seeing that stuff. Fortunately, it's not a joke. Same local admin password used all over the place. All right? I'm not going to ask you by show of hands whether or not your organization is using administrator in the same password on every system. Okay? But these are things that I'm still seeing in organizations, in spite of the fact that all these righteous EDR products are now getting deployed and catching tradecraft. There's still basics, and that's what I put these things into, these categories into basics. There's still basics that are not being addressed. Okay, so knowing this and kind of running through this as part of the talk, what are some conclusions that we can come to? Number one, defensive products are getting better. And by better, I mean a lot better. Okay, they are getting better at detecting us, not just like your crypto mining, your ransomware stuff. They're getting better at detecting tradecraft. All right, so I have to tip my hat to them. Number two, initial RC methods are dwindling against mature orgs. You see, in order for me to break into your organization, I have a few different paths that I can go through, right? I can try and fish. I can try and land. So if I fish, I can try and do some funkiness with a macro. I can try and send you an HTA. I can try and get you to go to a credential harvest page where I capture credentials and then serve you up an HTA. Okay, I can try and capture credentials if I can find a single-factor authentication portal. For example, Citrix, VPN, Outlook Web Access, O365. I can get into your organization via those portals, especially if they are single-factor. However, those methods, that landscape is shrinking a little bit. all right? And it's shrinking because of a few interesting factors. For example, let's say I want to fish you. Well, let's say you have a Palo Alto firewall in front of, on your perimeter. And let's say you're doing category inspection of every domain and category checking, which means that you have gone into that firewall and you have said things like, all right, I'm only going to allow outbound domains that match government, health, and finance. That's it. And in fact, I have a friend who works at a bank, and he told me, he said, those are the 3 magic categories. If you can get your site classified as one of those categories, like Blue Coat or Palo Alto, you're golden. Your domain is fine. All right. However, that work is now getting more. It's not getting less where I don't even have to use a domain. I remember I didn't need a domain at all. I could just send you a link that took you to a raw IP address, a direct connection. And I get shells all the time. But now there's a category for that, the unknown category in Palo Alto at least. Okay, and if those categories are restricted, now I have to go through the pain of trying to get my domain categorized before sending you that fish. Okay, these methods are starting, this landscape is starting to shrink a little bit, and it makes it more painful for the attacker, all right, which is good. We want to see that. However, smaller shops are still struggling to handle the basics. Okay, mature organizations that know how to wield the power of these EDR tools, that's great. They can get on the call and laugh at you. That's awesome. Okay, but there are still some smaller shops where it's like, they don't have a handle on the basics. And there are still easy ways in, even if they have some of those tools, and I can show you some of the bypasses for those tools in a few minutes, but even if they have some of those tools, if you're using the same local admin password everywhere, and I scoop that password somehow, it's game over. Even if I get detected, I know what's going to happen. That section is going to generate an alert. That alert's going to be associated with the severity. If that severity is, say, a medium severity, then it's going to go to a certain inbox. Or it's going to get flagged in somebody's system, and there's an operator that's going to be monitoring that system. Maybe they'll get paged, maybe they won't. Okay, maybe I wait until like 2 in the morning to do this. And so I know that I have a few extra minutes because somebody has to get up out of bed, check their phone, oh God, log into the system, actually see what the alert is. They're assuming it's going to be a false positive. All that adds up into time, which means I have a little more time on that system. Okay? But anyway, smaller shops still struggling to handle this, but this kind of led me to my grand conclusion, I suppose, which is that novel TTPs, tactics, techniques, and procedures, are the new 0 days. I cannot recall, I can't. The last pen test that I was on, they actually used an exploit. And by exploit, I'm talking like a memory corruption exploit. MS 17010. That was the last one. Okay, before that, it was probably MS 67. All right, but generally speaking, exploits, I'm not going to say they're a thing of the past, because they're not. People are still finding exploits, and they're finding them continuously. But the cycle between the time the exploit is discovered, disclosed, and patched is now like this. Patches get rolled out very quickly. Systems, Windows systems especially, get patched very quickly. Okay, if Microsoft releases a critical patch, and people will do out-of-band patching, which means if an awesome MS-17011 gets released, okay, you got days. You got days to use that technique before it's burned and covered completely, unless the organization you're testing, it does not have good patching process, in which case there are others more significant problems, right? So if you have a novel TTP, a novel way of doing things that bypasses some of these next-gen EDRs, those are the new 0 days. Those are the things that will, in my prediction, I guess, will be traded or sold or things like that, which is why we have things like bug bounty programs right now, okay? But the point being is that if I have some of these techniques, sharing them is now an interesting concept. Do I want to tweet it? Do I want to hold on to it? Is it going to make my job easier? These are interesting topics, right? So where do we go from here? Like, how do we break this down into meaningful ways for both offense and defense? Because like I said, it's getting harder for offense, but only in specific ways. In other ways, it's still very easy. So what needs to happen here? Let's start with defense. All right. With defense, number one, ensure the basics are handled. I put these in a prioritized order for you defenders, okay? Because as a red teamer, these are the things that I look to exploit first. And by basics, I'm not talking about, for example, you have attack testing automation for the MITRE ATT&CK framework. That's great. That's awesome. I'm not knocking it. I think it's a wonderful thing, okay? You have not necessarily deployed next-gen EDR. I don't consider that a basic thing to do. What are the basics that need to be covered? Strong passwords. Get rid of your password warrants. Get rid of your season years. Get rid of your company ones. Knock all that off. Put into place a strong password policy, and by strong, 16 plus characters. Tell the users they can use spaces, so it makes typing it easier. This is not a problem. And number 2, multi-factor authentication on all your remote access portals. I can't tell you how many organizations, education specifically, okay, if I had to pick on one vertical where MFA is like, nobody cares, it's education, all right? So multi-factor authentication should be in place for every remote access portal, whether that's Citrix, whether that's VPN, whether that's Outlook Web Access, I don't care. If it's a way to get into your organization, you need MFA in front of it, all right? Network segmentation, like I said, flat networks are bad. Why are they bad? It's not necessarily bad if you're a user. If you're a user, it's easy. Why is it bad? It's bad from, if I'm the attacker in the network, does having a flat network mean that I can somehow compromise you more? No. It just means I can compromise you faster. It means I have access to your servers on specific ports that Bob Salesbro should not have access to, which means I can interrogate those ports and I can do things quicker as far as the attack chain goes. Everyone following me so far? Or are you falling asleep? I see like 2 nodding heads, the rest of you nodding off. And number 3, excuse me, number 4, limiting admin rights. I still see a lot of admin rights. I see a lot of admin rights used. And it's not necessarily on Salesbro Bob's machine, okay? Although what ends up happening is that, and this is really a failure of the security team, of the defense team, is if Bob has switched positions into sales from another position where he had admin rights, and those previous jobs' rights were never taken away because Bob needed them for 6 months so he could do training for another user, I see that a lot, okay? Where this user should never have had rights for as long as they've had them. But they still do because there's a process breakdown there, okay? Those are the basics. I love attack framework testing. I love deploying EDRs. They're great products, but they're not the basics, okay? Number 2, invest in people and extreme detecting capabilities. Number 1, people make your shop. Good people make your shop, or bad people make your shop. Okay, if you're a defender and you hire a bunch of defenders that it's like a 9 to 5, they don't necessarily care about the job, well, you're going to get a defensive strategy that revolves around people that don't care. All right, if you hire people where there's an interest, that is not something you can train. It's only something you can buy. Okay, you can acquire that talent, people who are interested in this work, and I'm assuming you're all here because you're interested in this stuff. That means that just de facto, you're going to make better candidates than someone's like, oh, I heard InfoSec is sexy, I'm going to get into that field. Not necessarily, okay? Hire good people and then invest in very, very good detecting capabilities. I'm just going to throw a few of them up here, and I recommend for these particular techniques, or these particular logs, let's walk through them real quick. 4103, 4104, PowerShell operational logs. You have to enable these via group policy, okay? Script module logging, all right? Number 2, 4624s and 4625s. These are not necessarily in priority order. This is just what came to my mind as some of the most important things you should be looking for. All right, logons, successful and unsuccessful. 4657, a registry key modification. This comes into play. For example, if I flip the registry key that now stores passwords in WDigest, now I can use Mimikatz even on your Server 2012 R2 system. Okay, are you monitoring for that reg key? You should be, if you're not. Are you monitoring for persistence reg keys? You should be, if you're not. All right, number 4, 4688s, new process created. Please start capturing these. Please start capturing them. Please start capturing. It's going to generate a ton of logs. I'm going to tell you right now, every new process that fires is going to generate a 4688. By the way, there is a corollary GPO setting. I should have grabbed a screenshot, but I didn't. There's a corollary GPO setting that will allow you to capture the command line arguments that get passed into the process. So if I run cmd.exe space /c space calc.exe, the /c and calc.exe, sorry, I'm going the wrong way for you guys. The /c and calc.exe are arguments that get passed in which do not get caught by default on 4688s. You have to enable command line logging as well. Okay, so please do that. Capture those things. 4698s, new task created. Well, why would anyone care about that? Persistence, maybe? New scheduled task. 4720, new user accounts if I'm creating backdoors, which, by the way, I rarely do, but I will do if I have to. If you pin me into a corner, I'll create a backdoor, sure. And then 7045, new service installed. A lot of tools, for example, PSExec, will send a binary over, it will create a new service that points to that binary, start the service, and then delete the service. But if you're catching that service installed, that might be something to pay attention to, okay? And oh, by the way, I recommend you start capturing these logs first on your workstations, not on your servers. I know lots and lots of organizations that tell me, yes, we're capturing these. And I'm like, okay, great, where are you capturing? All of our mission-critical servers. I'm like, that's great, anywhere else? No. I was like, what about your workstations? They're like, no. Why would we do that? I'm like, well, I'll tell you why. Because if I land from a fish, I'm not going to land on a SQL server, or at least, God help the organization, if I do land on a SQL server. Somebody checking their email? No. I'm going to land on Bob's machine, right? I'm going to land on a workstation. And that's going to be patient zero. And that's where I'm going to try things like persistence. And I'm going to try things like lateral movement. And I'm going to try things like creating new processes. And if you're not capturing the workstation logs, you are in the blind completely for patient 0 and then patient 2, 3, and 4, because generally speaking, I don't migrate from a workstation to a server. I'll migrate from a workstation to another workstation. Why? Because I found the workstation admin password, and it happens to be the same across all the workstations. And so now I'm going from workstation to workstation until I find a server admin. And then I scoop his credentials. And then I move to the server. And then, oh shoot, we're compromised. Well, it's fine, because I'm using alternate domains for the C2 traffic. So you might shut me out of my server access, but you can't change the password. Why can't you change the password? Because I have a service account. And nobody rotates their service account password, because production breaks. It goes down completely. Okay? So all that could have been stopped faster if you've been paying attention to your workstations. Please, do this, capture these, start with your workstations. If you had to prioritize, if you can get it all, absolutely, yes, get it all. Okay, but if you had to start somewhere, start with your workstation. Okay? Scope your red teams honestly. If you're in an organization working for if you're a defender, and you're like, all right, it's either time for our annual pen test or it's time for our annual red team, or we want a specific red team, do yourself a favor. Take into account the things that I'm saying in terms of red teaming getting more difficult. Because when things get more difficult, we now need more time to account for your controls. Part of the beauty of getting a red team assessment as a defender is an encounter with the unknown. You don't know what I'm going to throw at you. And why is this the good part of a red team? Well, because you don't know what a real-life attacker is going to throw at your organization. You don't necessarily know. Now, you might know some of the tradecraft. MITRE ATT&CK framework is fantastic for that. Okay? It breaks down a lot of hacker techniques, but the mystery behind the red team is the fact that you're encountering an adversary of an unknown skill set. And they have unknown techniques to you. You might know some of them, but you don't know all of them. And that's one of the reasons why red teaming is still so important, because it is the way to emulate an adversary that is of unknown capability. So scope your red teams honestly. If this is your scoping statement, you are doing it wrong. Status meetings will occur daily at 10 a.m. and 3 p.m., but you can only test between 12 a.m. and 5 a.m. I've done some of these tests, okay, where it's almost as bad. Tester will at no time perform a happy dance or resort to celebrating. It's too bad. I do that all the time. All right? Scoping is critical. For mature organizations, all right, let's talk about scoping for just a second. I'm talking about modern organizations with modern controls getting ready to engage in a modern red team. Number one, no target is off limits. Human or computer. No target. Okay? If the first thing you hand me on a red team, where I'm supposed to be opposing as an adversary, attacking your organization, and being stealthy, is a massive list of exceptions, something is going on. If you're like, now, see, you can't test our C level, because if you test our C level, they're going to find out what we're doing, and they might get embarrassed, and they're going to pull our funding. It's a bad idea. You know why? Because C level people, they love to click things. Love to click things. And I love to fish them. Because not only do they love to click things, they also don't know the process for what happens if they get fished. C-level people are generally obnoxiously positive. They think that people that they encounter are all good people. Okay, so that's why I want them to encounter me. All right? They need to have that encounter with someone who does not have their best interests in mind, because that kind of spooky factor must occur. One of my favorite customers of all time. I'll tell you a little bit about them. They decided they were going to pay for social engineering engagement. Okay? And they said, you know what? No target is off limits. You can fish anyone you want. Okay. All right, cool. So who do we fish? Your CEO. Guess who clicked? The CEO. Guess whose name was in the report that we delivered? CEO. Guess who else was in the room? The entire C-suite. When we delivered and we said, hey, John Doe, this is your user ID, right? He's like, yes. And then the moment that every attacker dreams of is when that light bulb goes on and he's like, shoot, I wasn't supposed to do that, was I? No, you weren't. You got caught. Well, here's what happened with that organization. That guy, in that moment, learned how important it is to do testing and how important it is to fish your people and do penetration tests. And he had an occurrence, a revelation almost, that if he had clicked this for real, he could have compromised and sabotaged his own company. He turned into the biggest champion of security for the entire organization. He funded their entire security program. He brought in awesome people who started doing awesome things. He brought us in to give talks to their people. And guess what happened? Their social engineering metrics went from double digits down to lower double digits, down to single digits. The more we tested them, the more they figured this out, the more successful they were. And it started with the top. Okay? No target is off limits. Number 2, wireless, physical, social engineering, all in scope. Don't tell me I can't social engineer you on a red team. That's not a red team. It's not what that is. Okay? Maybe a pen test, at least a vulnerability assessment. But don't tell me that's a red team, because it's not. All right? Number 3, this is the killer. Time has to go up. Why does time have to go up? It has to go up because now we have to compensate. Now I have to take my payloads and run them through a lab that we're creating. Right, Carlos? Run them through a lab that we're creating to determine what's going to get caught and what isn't going to get caught. I have to run them through various controls to figure out, is this going to get busted here or is it not going to get busted there? Because we are now having to compensate for the additional controls, which is a good thing. You want to have those attackers go through that pain. Okay, before they send that fish, they have to ensure that the payloads that they are sending have at least a decent probability of being successful. Because if you hire me and you pay me to attack your organization and I send you a generic fish, you're going to be like, what is this? I can go get a free tool and fish my own people with that. I'd be like, yes, you can. Okay, red teaming is getting harder, therefore red teaming is getting longer. Number 4, on the report, this is just one for you managers. Don't expect me to drop a bunch of SSL vulns. I hate writing SSL vulnerabilities. It's like the packing peanuts of a pen test report. Nobody likes doing that, okay? But don't expect that on a red team. On a red team, you'll get actual, actionable results, okay? And last but not least, reach for modern security controls, EDRs and stuff like that. After you've handled the basics, after you've got good people, after you've got detection, then you can go for those next-gen tools. But here we go. This is the controversial moment. You ready? They're not necessary. The basics are necessary. Let me tell you about an organization that had the basics down. Got hired just I don't know, this was a month ago or 6 weeks ago, to do a pen test for an organization. Never heard of them. Got on the kickoff call. All right, this is an internal test. And I got on the kickoff call, and we started talking through a couple of really nice guys on the call. They may or may not be here today. But anyways, we started talking through some of the specifics of the test, of what the test would look like. And one of them said something to me that was kind of a key indicator, all right, of how I thought this test was going to go. And whether or not he knew what this was going to do to my psyche or not is irrelevant. But here's what he said. He's like, I don't think you're going to really get very far in this test. And I was like, all right. When someone says that to me, it means one of two things, and only one of two things. Either that company has no idea what they're doing, and I'm going to be domain admin by lunch on Monday, or they know exactly what they're doing, and I'm not going to get very far. Okay? And so I said, that's great. Keep the ego in check. Like, that's awesome. I certainly hope I don't. I certainly hope I don't. But in the back of my mind, I'm thinking to myself, I've been in this position before, and so the time of the test comes, right? This is an internal test, so we're simulating someone has broken in and planted a device. So we have a Dropbox. Dropbox calls back home to one of our servers. I log into the servers. I start kicking off the test. All right, if you're doing an internal test, I'm not starting off credentialed. I'm not starting off privileged. I'm starting off as a Linux system in a world of Windows systems, which is like every other test that we do, every other internal test. I got my Linux box. I got all my fancy attack tools, and then I got their Windows environment. I got their domain join systems. I got their Active Directory. I got various segments, et cetera, et cetera. Okay, and I have a scope. All right, I know what the scope is. These systems are in scope. These systems are out of scope. So I begin the test. And one of the first things that I do is I start doing a little bit of reconnaissance. Not a lot. This was not a red team. I was not being paid to be stealthy. Okay, this is a week-long pen test. And in a week-long pen test, I throw the kitchen sink at you. I'm not afraid to run Nessus in your environment because in 1 week, you're not going to get a lot of stealth. I'm sorry if you think that that's how that works. It doesn't. You can tell me, please try and be stealthy, and I will give it a best guess. But if I've gotten nowhere by Tuesday and nowhere by Wednesday, I'm just dash T5 insane and map all the things. All right? So I start launching. I kick off with a port scan, one of my favorite ports, 445, because I'm trying to figure out where's SMB open on a Windows system. Right? 445. In my subnet, nothing. Not one hit. And I'm like, I know what happened. Because customers have done this to me before. They turn a pen test into a fight. And they take my box and they put it into an isolated subnet. And I'm like, okay, all right, I see how this is going to go. All right, and so I'm like, all right, let's start paying attention to traffic on the wire. I just, fire up, TCP dump, start listening for stuff. There's traffic going back and forth all over the place. There's Windows systems communicating back and forth on 445 on my subnet. And I got nothing. I got no systems. I got nothing. And I'm like, well, what's going on? And so after I kick off my port scan, I get an email. And they're like, yeah, we saw you doing the port scan at 445. Send me a screenshot. And I'm like, what is that? And they didn't know that I did this, but I actually Googled the text in the screenshot and traced it back to the product that they were using to block me. So they had firewall implemented on all their workstations, blocking inbound traffic on 445. Who does that? Nobody. But these guys are doing it. All right, so I got nowhere. And I'm like, I'm not the kind of tester to ask to be whitelisted. I hate that. All right, I want to see if I can get somewhere, and I want to see if I can figure out a path, and it gives me a chance to be creative. Okay, so I start launching additional attacks, and I start crossing subnets. Get another email, like, hey, we see you trying to cross subnets. It's not going to work because you have to be authenticated in order to cross a subnet. Like, you actually have to have an AD authentication present in the domain controller before you can even cross from subnet A to subnet B. I was like, how many security people do you have working for you? 2. Not a joke. Not a joke. Okay? I was like, are you kidding me? I couldn't talk to any Windows system except one, the domain controller, open on 445. Why? Well, you had to authenticate. And so like, you know what, just to kind of keep the test moving along, why don't we give you some credentials? And I was like, no. I want your stupid credentials. All right? I want to get in. I was like, I know what to do. I'm going to brute force you. All right? And so I started firing up I was getting ready to fire all the lasers. And they're like, yeah, you can, and you might find some creds, but all of our workstations require two-factor authentication. I was like, what? Who are you people? Nobody does this. All right? Now, the good news is that test did not end with them applauding themselves and laughing at me. All right? These are some awesome people that I had the opportunity to work with. But here's the thing. They didn't have, or at least I don't, maybe they do, maybe it's in some freaking clandestine network that I don't know about, but they didn't have any next-gen EDRs. They had a standard AV product that had firewall capabilities, and they were blocking standard traffic, okay, coming from an unknown host. They were requiring me to authenticate to Active Directory before crossing network boundaries, okay? Very, very good network segmentation. The passwords that I got, the one password that I got, was a really secure password. They didn't give me winter 2018. Okay? And here's the problem. I ended up that test basically going nowhere. I was able to do some information gathering about the network share that was open that my user account that they gave me had access to, but that's it. I got nowhere. I wrapped up the test basically saying, you're awesome, I suck, you guys are great, I'm not good. It was horrible. I'd eat crow. All right? And the reason why I'm telling you these stories is because you don't need a ton of money to have a really good security configuration. You don't. All right? In almost all the talks that I've ever given, I say the same thing. A really good security configuration can be accomplished almost for free with the tools you have, and it will beat your flashy next-gen shiz every single time, 10 times out of 10. Okay? A really good security configuration will do that. If you know how to wield the tools that you have, like group policy, you can shut down all kinds of stuff. You don't even need another product. You can use Windows Firewall to turn that stuff off. Okay? All right. Enough about my ranting. Offense. What do you do if you're a red teamer and you're up against this world? Okay? Or if you're thinking about going into red teaming. Like I said, the days of you being able to just fire off a fish and get back a meterpreter shell, they are coming to a close. The days of firing Mimikatz at an organization and just getting loads and loads of plain text creds, those are really beautiful memories in my mind. But those days are coming to a close. All right? What do you do if you are a red teamer? Number one, importantly, you network heavily with other red teamers. You get to know your fellow red teamers because they might have tradecraft that you need, and you might have tradecraft that they need, and it's not necessarily being thrown all around on Twitter, even though that's great, and we rely on people that do that, but like I said, novel TTPs are the new 0 days. All right, so if you guys can work together and come up with that unknown factor that goes into a red team, that's going to bring value to that engagement. So network with your fellow red teamers. Number two, be careful what you tweet and what you share, because it will be profiled immediately. I'm not joking, and I know this firsthand. Okay, I have the privilege of being in a Slack room with a lot of well-respected people in the security industry, and a few of them are defense oriented. They work for major companies. They get to look at the APT 28s of the world and see that stuff. And a few of them have told me something interesting. They said, you know what, Jason, the APTs of the world are learning. They're taking their tradecraft from red teamers. And I was like, no. Are you kidding me? These are like clandestine organizations in China and Russia, and we associate those groups with having like this elite tradecraft that nobody quite understands, but they're breaking into companies all over the place. And yet I got my friends over here with authority telling me, no, they're taking their cues from you. And I finally learned this firsthand when one of the tools that I wrote was actually used by APT 28 to compromise what I think is the German and Romanian Ministry of Foreign Affairs. This was a terrifying moment, but kind of an awesome moment, but mostly terrifying. All right, and in fact, it was, this is an interesting experience because I learned about this at like 10:30 at night, and somebody, one of my friends said, hey, Jason, did you see this? And I read it, and I'm like, and all the blood left my face, all right? And so I'm laying in bed with my wife, don't get any ideas, sickos. But anyways, so, and she sees like my ashen face, and she says, what's wrong? Like expecting me to announce that I have some sort of terminal disease. And I was like, so you know that tool that I wrote at DerbyCon and released and published it and stuff like that? And she's like, no. And I was like, okay, anyways. And so I told her a bit about it, and I was like, I think the Russians took that tool and compromised Germany with it and exfiltrated like 17 terabytes of data. I'm freaking out. And she looks at me, and she says, her face went, she said, are you working for the Russians? And I was like, no. She's like, she said, did you get Trump hired? I was like, no. That's not what this is. All right? But basically what happened was this was code that I put together that I found in the article. Okay? And if you learn how to code, which is my next point, but if you learn how to code, you can put this stuff together and be of benefit to the industry. You also benefit the Russians, but you will benefit the industry. Okay? How does this benefit the industry? By releasing offensive code. Well, if you do that, you're putting the technique out there. Defenders can scoop the technique. They'll find out what you're doing, and they'll figure out signatures, and they'll figure out how to block your technique, which is ultimately good for defenders. It sucks to be a red teamer when your stuff gets burned, but it's good for defense. Okay? But the point being is that if you're going to survive as a red teamer in this new world, you need to learn how to code. Okay? You have to learn how to code. And I don't care what you learn how to code. You can start in C if you want. But I'd recommend C#, PowerShell, Python. Grab one of those, any one, all of them, doesn't matter. Learn how to code. You will be better for doing it. What is number 4? This is a reminder to myself. Slow down. Okay? And by slow down, I mean slow down your attacks. Do not nmap the whole world. Do not nmap your target's entire organization. You're going to get caught. Don't fish 100 people when you only need to fish 2. Slow down, okay? And Carlos had a great point in his talk. Your fishes that you send don't all have to be RCE. You don't necessarily have to try and get a shell every time. If you can get something that scrapes the registry, scrapes program files, and then sends it back to your server, but you don't get a shell, that's a little more of a novel technique. All right, right now, the defensive industry is keyed off of looking for C2 traffic. All right, so slow your roll a little bit. All right, test every security product you can get your hands on, every single one, specifically EDRs. All right, I had an opportunity to get my hands on a next-gen EDR. All right, a friend of mine had one. All right, had one installed in his environment. I went through and did a whole list of tests. Don't ask me what product this is, doesn't matter. Point being is that I fired up Cobalt Strike and I tested a bunch of techniques because now I know going into an engagement, if I see this product, this is going to work, this isn't. See, I'm doing my homework against some of these products. And I encourage you to do the same thing. All right? Know your tools inside and out. Do not fire get system if you, no, there is no if. Don't fire get system. But if you are firing other tools, if you're using Metasploit, if you're using Cobalt Strike, it pays to know what those tools do. For example, how many use Metasploit? All right, most of you. How many of you know what the SMB login module is? It's one of my all-time favorites. All right, yeah, okay, most of you. So you take a set of creds, you got a username, you got a password, you got a domain, you got a target. You send it, and you test authentication. You can send it against a bunch of targets, or you can send it against one. But how many of you knew that every single time with the defaults on SMB login, if your login fails, you're producing 2 failed logins, not just one. You would think you're only doing one because you're only testing it once against the system, but you get 2 of these attempts. Why do you get 2? Well, if you look at the options for Metasploit, there is a flag that is set to true by default called detect any auth. And you know what that does? Probably not. You know why? Because you need to look at the source code in order to figure that out. If you look at the source code and you have detect any auth set, it will try a bogus domain login to see if it allows guest sessions with any credentials. And it does this by default. And if you look at the event log, you're seeing a bogus account name. This is a huge key for defenders, right? If you just see some random name, your own. Someone's inside. Or it's a red team doing a test, okay? But you don't necessarily know that unless you know what your tools do. So how can you shut that down? Just set detect any auth to false. It's a very, very simple trick, but it cuts your 4625s in half, just right out of the gate. Okay, what about Impacket? How many of you use Impacket? If you don't use Impacket, you should. Core Security puts out one of my favorite tool suites of all time on GitHub called Impacket, and it is some outstanding utilities. One of those utilities is called SMB exec. In SMB exec, you can take a username, a domain, and a hash and throw it at a target and get back a shell, interactive command shell. They also have WMI exec. They also have their own flavor of PS exec. Okay? However, when you run that command, when you run SMB exec, what you're actually sending is this. Comspec, it's going to be cmd.exe, /q, quiet, /c for command. Okay? Well, what does that look like in a modern tool, or in a modern EDR? If you look at, say, Cobalt Strike, not Cobalt, shoot, Carbon Black, here's what this looks like. Services, firing cmd.exe, and here's your other command that's launching. Because SMB exec launches a second output, you can't see it because it's truncated over here, but it saves it to a bat file and then fires the bat file. So now you have 2 cmd.exes running. Okay, however, you can obfuscate commands on the Windows command line with things like carets, right? Now, in the Windows process auditing, the carets get removed, and you see the raw command, but not so in Carbon Black. And so if you have a rule that is looking for dash Q dash C, and you do something like that, where you drop a caret in there, guess what breaks? The detection of carbon black. Very, very simple technique. But how do you know this? Well, you don't unless you do that testing. Okay? Last but not least, here's a fun one. PowerShell.exe with a hyphen. All right? So we were actually sitting round table doing testing against a security product. I won't name the name, but we were doing this testing with the customer, and one of my coworkers came across an article that it's a short article, and it was a technique that was found in the wild, and it was just one screenshot. You probably cannot see that. Here's the important part. Can you see? That didn't work. You probably, I don't know if you can see it or you can't. However, right here, PowerShell dash. And then there's a command that's being sent to PowerShell dash. And we were like, what is that? I've never seen anything like that before. Well, here's what PowerShell dash does. If you run PowerShell, sorry. Let me turn off, turn on, mirroring. You got it now? All right, cool. So if you run PowerShell dash, scroll up, something interesting. If the value of command is dash, the command text is read from the standard input. Did you know that? We didn't know that. Well, what does that mean you can do? Well, it means you can do things like this. Well, that's kind of interesting. So if you are a blue teamer and you're looking for stuff like this, blah, 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 characters, blah, blah, evil characters, and I can break that with this command up here, well, that makes things interesting, doesn't it? What about something like this? Set C1 equal to echo PS table. Set C2 equal to PowerShell dash. And then I do C1, C2. What do you think you see in the command line log of tools like Carbon Black? You see this. Now you're also going to see this. Okay, but trust me when I tell you that there are ways of keeping this out of the command line altogether and only seeing this. Now, what this does not bypass is the Windows command line processor order. So for example, it's going to see PowerShell PS version table. It's going to see that in that command line. So if you are catching 4103s and 4104s, and you're catching 4688s, you're going to see this on the workstation. But if you have a next-gen EDR where all of your tools are configured to look for PowerShell dash NoOp, dash Noni, dash ENC, base64 encoded stuff, you're not going to catch that. It's a very, very simple way of working around that stuff. Okay? So, real quick, 'cause I'm almost out of time. And let's go. No. Slow down. Okay. All right. By the way, here's the article. I definitely recommend you read it because it's just this little snippet of an article, just this one little screenshot, and that got us going down this entire chain. And believe me when I tell you, you can write kits around that technique, all right, to bypass certain tools that are looking for specific strings in the command line. Okay, so not to leave you all hopeless, but where do we go together? Like as an industry, what do we do next? Number one, in order to work together effectively, transparency must be mutual. And by transparency, I'm talking about transparency between the red team and between the blue team. When a customer brings me on to do a red team, I'm an open book with 99% of the stuff. If it's a very, very specific technique, I will give details about how the technique can be blocked without necessarily saying, here's the source code, especially with something that we wrote. Okay, but with nearly everything else, I'm an open book with tradecraft. All right, that needs to be a two-way street as well between offense and defense. The more they work together, the more that you, red team, work with blue team and blue team works with red team, the better you will both get. I promise you. Look what happened. I picked on carbon black the entire time, okay? But now I know how to work around it. And because I know, now this is gonna be on the internet for all to see, carbon black now knows. And so they're gonna fix their tool, which means I'm gonna have to get better and find more workarounds as well. I call this the Graeber effect. Matt, if you're watching, thank you very much, okay? Number two, kill your ego. It ruins everything, everything, okay? If you're like, I got these shells and this org sucks and the users are idiots, no, you're an idiot and you need to shut up, okay? Don't be that guy or gal, please don't, okay? Put your ego in check, work with people, all right, and work with your customers. I have worked with some great customers since joining Trusted Sec, and they have humbly put me in my place by virtue of their controls, or their applause, but usually their controls, okay? And number three, blue and red should want each other to improve. Remember that company that I told you about, that the CEO got fished and they improved their organization? We had a good partnership with these folks. And so they said, hey, have you guys ever pen tested mainframes? And we're like, no, because you can't even nmap a mainframe without tipping it over. Like just go down in flames, right? Dumpster fire. All right, and so we're like, no, normally customers exclude mainframes from scope for good reasons, because you can break it and then nobody can process credit cards and the whole world goes crap, okay? So normally that gets excluded, but they're like, we want you to test our mainframe. And so they paid to bring us to their location, and they brought their top mainframe guy in to tell us how the mainframe works so we, the red team, could be more effective testers. That is an awesome partnership. That is working together. You want to see the industry improve on both sides, red and blue, that's how you do it. Nobody had ego in the room. We walked in the room, we're like, we don't know jack about mainframe. They're like, well, we know everything about the mainframe, but we're going to teach you. And that was an awesome, awesome moment, stuck with me to this day, okay? Please be those people, especially if you're in college, getting ready to launch into your career. That's the kind of person you need to be. All right, keep your ego in check, because I promise you, you will go far. All right? That's all I had. I'm actually a little over time, so I'm just going to say thank you very much.
Hey guys, how y'all doing? I'll go ahead and just get started here as we're about 5 minutes past. So my name's Eric Capuano. I'm a blue teamer at heart. I've been doing security operations and incident response for several years now. Cut my teeth in the Air Force working on intrusion detection systems. Moved on to state government level doing security operations for the state police in Texas. And now I actually run my own security consultancy firm where we're covering a lot of small, medium businesses in and around Texas, some critical infrastructure as well as healthcare. So a little bit about what pushed me to write this talk is that I'm a really big proponent for doing security operations on a budget because I, as you can tell, come from a lot of government background where either budget's limited or it's just really hard to get. Maybe you got $4 million, but you've got to jump through 37 hoops to spend $1 of it. So I got really accustomed to leveraging open source solutions any way I could to be effective at my job. And the cool thing I found out was it wasn't that I was like compromising on how good my tools were. I actually found that it was oftentimes the inverse. I could grab an open source tool that was better than the $200,000 solution I was almost about to buy. Then you get into some really cool territory, right? When you find out that, wait, not only am I saving money, but this tool's better, and I can customize it, and I can join the Slack channel and talk to the developers in real time. Okay, I'm sold, right? So anyway, I love open source tools. I actually know the developers of the Greylog team. They're a phenomenal set of guys. And so when I wrote this talk, they were super excited to hear some of the things I was doing with it, and they're actually taking some of that input into their development direction with Greylog. But anyway, so I'll just get right into it here. So when I have a conversation with most people about why I leverage Greylog in security operations, it's always why not elk. And largely the important thing to take away here is Greylog is elk without the K. It's Elasticsearch, it's Logstash, it's just not Kibana, right? But here's the cool thing about that. If you build a Greylog cluster, guess what? You have Elasticsearch and Logstash. You could just simply add Kibana. Now you've got Greylog and elk. So, that's just putting that one to bed real quick. But ultimately, it's the same powerful capability. So the basics of Greylog, it's very much, it's as simple as it gets, guys. It's log aggregation. But we're going to talk about in a minute why it can do so much more than that. But log aggregation is the foundation of any security operation team, or any just operations team. If you're not bringing in logs from all of your critical systems into an aggregation point, then you're doing it wrong because you're relying on, event logs on an endpoint during an incident response. Who here's ever went to pull event logs on a domain controller after something hit the fan, right? Maybe an hour or two at best worth of events to go back to. So it's key to have all those events, all those logs from your infrastructure, your systems, all shipping to an aggregation point so that you can go back and see, hey, what happened 6 weeks ago on that domain controller because we just figured out we've got a 6-week-old breach, right? So you've got to have that capability. That's what Greylog can bring to you. It's, like I said, Elasticsearch and Logstash, so it's nearly infinitely scalable. If you've got a really good architecture, you could build this thing out to support hundreds and hundreds of thousands of events per second. I mean, it's ridiculous. It's very powerful. And then the query language, if you've messed around with Splunk or Lucene or it's effectively Lucene query language. So it's very, very clear, plain English saying, dest port equals that, and from internal equals false, right? So Boolean logic, very simple stuff here. And then of course, dashboards, right? It wouldn't be cool without dashboards, especially when the CISO walks into the SOC and you want to make it look cool, you put up the dashboards. But, I find limited value in dashboards other than for just quick situational awareness until you see something like this. This is awesome because this is actually, so when I was writing this talk, I was going into my own Greylog instance and I was looking for interesting screenshots I could take. These are user agents off of my production web server. If you notice, let's see, this guy right here, shell shock exploit, right there in a user agent on a production web server. That's kind of good to know, right? That someone's attempting exploit against my server. So just an interesting aside right there. So quickly, it's important to discuss a little bit how Greylog works at a fundamental level before we go into some of the really awesome stuff you can do with it. So naturally, the first thing we need to do with with our new Graylog instance is we need to collect logs, right? We need to ship logs from all of our stuff to our instance. So let's talk about how we can do that. So if you're not already familiar with beats made by Elastic, it's a set of agents that you can drop on endpoints cross-platform, and you can ship anything from Windows event logs to audit D logs. Heartbeat is doing uptime monitoring, so is this web service responding to HTTP requests? Is this SQL database listening on 3306? PacketBeat, probably one of my favorites because I'm an IDS guy. PacketBeat is basically that promiscuous interface on the endpoint, sniffing the traffic, shipping metadata, NetFlow. It's got protocol decoders, so it can pull metadata right out of the HTTP headers. So it's literally like having a wire capture, or a packet capture, on every one of your endpoints, shipping that metadata back to Graylog. So I could say, how many HTTP post requests are being made in my organization? And I'm getting that information at the host level, right? So that's kind of cool. And FileBeat is just kind of this universal, like, hey, point me at a log and I will ship it for you. I don't care where it came from or what it is, I will ship it. So FileBeat's pretty cool. And then we're going to talk about how Graylog gives us the ability to manage the configs of these event shippers. And by the way, quick side note, you notice sysmon out here on the side. If you don't already have sysmon deployed in your Windows environment, do it yesterday, because you're going to get infinitely more value out of the events that sysmon gives you than you will from just regular Windows event logs, and we're going to talk about that in a minute too. So I mentioned Graylog has the ability to manage the configuration of all of those log shippers in your environment. That's important, right? Because I've managed over 15,000 endpoints in a single enterprise. Well, if I'm going to put WinLogBeat on every one of those endpoints, what happens if I want to change the configuration one day? Well, Graylog has a really awesome tool called the sidecar collector. And basically, I drop that sidecar collector on the endpoint. It's calling back to Graylog on an HTTP API and says, hey, I'm a Windows workstation. What logs do you want me to ship to you? And Graylog says, yo, ship me security, ship me application, and ship me your sysmon logs. Okay, cool. That's what I'll send you then. But maybe a month from now, I'm like, man, I'm bringing in way too much stuff. I'm not getting much value out of these application logs. I go into Graylog and I just say, hey, no longer interested in application logs. And guess what? 15,000 endpoints just got that update pushed. Very cool. Scales very well. Splunk can do this, but Splunk also costs a few $1 million. So it's kind of neat, right? Unfortunately, no support for the Macs yet. Pipelines. Okay. So once we're bringing the data in, right, we've already got all of our event log shippers deployed on all our endpoints. We want to bring it in, but maybe we want to do some manipulation on the events as they're coming in. And when I say manipulation, maybe we're doing whois queries on IP addresses. Maybe we're doing threat intel lookups, and I'll give you some examples on some of that. So pipelines are a way to basically process events as they come into Graylog, to enrich them, enhance them, drop fields, you name it. Whatever you can think of, a pipeline can do. Think of it like a short script that comes in and says, if event contains this field, etc., do a thing. And we'll talk about some things that you could do that would be really valuable for security operations, like finding evil, right? So this is an example of a pipeline rule. And this one I'm calling threat indicators. Now, this is not something that I created. I want to make sure to pay credit to the Ion Storm guys. These guys actually, here's a link to their GitHub. If you can see this, yeah, bottom right down here, Ion Storm publishes this really awesome list of pipelines. So this one's looking for threat indicators on an endpoint. So check this out. Now, it's important to know how this pipeline works. Up here, you've got just the rule name, threat indicators. Now notice it's reading like Boolean logic, right? So if it has the field sysmon command event, and the command event contains any of these things, VSS delete shadows. I saw this 2 weeks ago at a ransomware incident that the attacker had been on the network for several days, and what they were doing is they were moving around the network looking for where's all the valuable data at, right? But you know what they did on each endpoint that they hit? VSS admin delete shadows. Why would you do that? Well, because shadow copies are a way to restore files. Well, if I'm about to ransom all your files, I don't want you to restore them. So I'm going to go around and delete all your shadow copies on your endpoints. That's something you should be aware of in your environment. If anyone's ever deleting shadow copies in your environment, that's not normal. So now we've got a pipeline that's looking for that. Execution policy bypass, right? PSEXE. If you're in a shop where you're using PSExec for regular sysadmin stuff, stop it. You know, WinRM, PS remoting, it's the way of the future, guys. It's time to move on. PSExec is now what I call lateral movement tool. So reg.exe, right? How many users in your environment are running reg.exe on the command line? Hopefully none of them, right? So something to cue in on. Schedule tasks, you know, you name it. So what we're doing here is this pipeline is looking for the presence of any of these things, and this is a very short list of examples. I mean, the sky's the limit, your imagination. But we're setting a field now in that event called suspicious command event equals true. So now, later on, I can write some queries to say, I want to see all the commands being run in my environment that meet any of these conditions. So here's another pipeline. If anyone here is familiar with Alien Vault, they have a fantastic open source threat intel exchange called OTX. And this is like the Facebook of sharing threat intel. It's incredible. The barrier to use this thing is super low. You create an account. Actually, you don't even need to create an account. You just jump on. You could search for an IP address and see how many known threats are associated with the IP address. Well, guess what? I could teach Graylog to do that automatically. So now, as say my syslog's coming in from my perimeter firewall, I'm carving out all those foreign IP addresses, and I'm querying OTX for every single one of them, saying, hey, are any of these known to be associated with malicious actors, right? So what am I doing now? Like, I'm teaching Graylog how to do what a multi-million-dollar SIEM does, okay? Like, that's pretty phenomenal value out of an open source platform. And so here's kind of a summary of some of those other examples you can use pipelines for. You know, I can look up the abuse.ch ransomware domains, any threat intel source you can imagine, known Tor exit nodes, you name it, right? We can run whois queries. So really phenomenal stuff you can do with the pipelines. So let's get into arguably one of my favorite parts about it are streams. So streams fundamentally are like buckets of events. So remember, because we've got millions of events shipping into Graylog, but you know what? I want to be able to categorize and sort of classify so that I can go and look at, you know what? I just want to go look at all of my suspicious stuff in my environment right now. So I can go to a stream called, noteworthy events or suspicious events, or I could even have one that's like, like it's time to call the IR team on Christmas Eve. So streams are just a way to kind of funnel events of a certain type or condition or whatever into a view for an analyst to go and look at. So I'm going to talk about some really awesome streams that would bring value to a security operations team. So before I do, I want to preface with some really interesting sysmon events. Remember, I told you, if you're not using sysmon, this is a must-have because it's very, very low signal-to-noise ratio. Sysmon does not make a lot of fluff events. It's mainly very, very useful events that sysmon creates. Process creation, file creation time change, right? That's not something that should happen on an endpoint very often, is that something retroactively changes the creation time of a file in the file system, right? We call that time stomping from an attacker forensics perspective. Network connections, right? Now you can get network connections from regular Windows event logs if you've got it enabled, but it's nice to have another source of it. Drivers being loaded. We'll talk about how we can use that to track evil. Creating remote threads, raw access read. I'll give you some examples. So let's talk about a stream that we might use as just like a situational awareness, right? This isn't exactly something's on fire. This is just maybe something I want to keep an eye on in my environment. So one important thing to know is that streams work very much like, kind of like a pipeline where you've got the Boolean operator here. So I'm saying or, meaning any of these conditions, I want this to end up in my stream. So for this one, I'm saying sysmon event ID of 12, which means a registry object's been created or deleted. Again, right? That's not indicator of compromise. Registry gets changed all the time. But I could have a stream where I could go and look at every registry change across my 15,000 workstation environment. That's kind of neat, right? Well, how about one down here, right? So I'm saying I want to know if both of these conditions are true. If Windows Event ID 4625, which is a failed logon, and the substatus, meaning basically the reason for the failed logon, was this hex value here for 71, which is the one that means expired password. So if anyone here has ever monitored like failed logons in your environment, you'd see hundreds of them a day, right? Oh my God, we're being brute forced, right? No, you're not. John, his password expired today, but Outlook is still logged in on his workstation and it's brute forcing Exchange with his old password. So I'm going to filter that out because I don't care about that. I care about everything else, right? So this is just one of those situational awareness streams that might bring value to just keeping an eye on things. So let's talk about some more suspicious activities, things that would warrant, hey, you know what, we might want to look a little closer into this one, like event ID 1102, right? If our event logs were cleared on an endpoint, that's definitely not something that should be happening in an environment, right? Nobody just clears event logs for fun. So I want to know the minute that happens in my environment. How about 4720? If a local user gets created. So if you're in a domain, which you probably are on an enterprise network, you shouldn't have local users getting created on workstations, right? That's a way to kind of circumvent AD authentication. That's another way that's a lateral movement technique. So if I queue in on 4720, I'm going to know the minute someone creates a local user account on any workstation in my environment. How about the creation of a file named decrypt_instructions? Yeah, ransomware 101, right? And that's just one of many, many, many of those that you could queue in on. The really cool thing about the big ransomware campaigns is that they're really well documented. There's blog articles all over the internet about the real big ransomware campaigns. So all you got to do is go and find out, hey, what's the file name of the ransom notice it posts? Because they all use really, really key signature ones. You know, WannaCry had its one, Sam's got its one. And so if I just go and latch on to any file creation that meets that criteria, I'm going to know the second a ransomware epidemic gets unleashed on the network. And then again, like sysmon event ID of 2, let me know if a process ever changes file creation time, right? Which could be an indicator of a timestamp. Now let's talk about some real evil stuff here. Like this is like, okay, it's time to call the IR team. So pay attention again to our Boolean operator here, and. So I'm only gonna populate the stream with an event that meets all of these criterias. The sysmon event ID of 6 means a driver was loaded. That's cool, right? That happens all the time. But what if the driver loaded came from a path that's not a typical protected path that a driver should be loaded from, like Windows or program files? Okay, now we're dealing with something very unusual. Now that's not to say that that never happens, but it happens infrequently enough that you can build a whitelist for it. So if your organization uses this really weird application that likes to bring in drivers from weird places, okay, cool, get in there and make a whitelist. But you need to know if a driver's ever brought in from an unprotected directory, because that is hands down, that's evidence of something going on the endpoint. Here's another one, and anyone in here that's done red team is going to be really familiar with this. So here is our OR operator. So I actually want to know if any of these events are true. If a sensitive process is accessed and the target, meaning the process itself that was being accessed, was LSAS. Nothing should be accessing LSAS other than things that are probably looking to steal credentials. How about WinLogon? Same thing, right? Nothing should be accessing the winlogon.exe process. Now, what if now also pay attention to the context here. The target images, right? I'm talking about target images here, meaning these are the ones that are being affected. But what if I'm looking at the source image? So kind of like an implicit, like I just want to know if any process that was launched from outside of C Windows accesses any other sensitive process. So now I'm kind of saying like anything that's out of the ordinary, right? Could be very, very noteworthy. So raw access read is an interesting event that sysmon gives us. This is a way to know if something is attempting to read locked files on the operating system. Like for instance, your ntds.dit on your domain controller. You can't just, mosey on over to where that is in the file system and just pick it right up. That's just, that thing is locked. It's locked by Windows. However, there are methods, and raw access read is one of them, that could allow you to access locked files on a file system. So I would certainly like to know if sysmon detects an event of 9, which is that raw access read, and the source of that, meaning the process that's performing the raw access read, is not in a protected directory like C Windows, C program files. Now again, that doesn't mean that an attacker on your box that's got admin creds can't drop his malicious binary in C Windows, right? But if that's the case, you've got bigger problems. Because that means he's local admin. You know what? That means you've got about 30 seconds before he shuts off your log shipper anyway. So I mean, you've got bigger problems. But the point is, he's going to make a lot of noise before he gets to that point. You're going to at least be able to pick up on that trail as it goes. All right, so we've already talked about some of these really cool automatic things we can do to kind of bucket and prioritize and enhance our event data as it's coming in. But now let's talk about what we do with the bad things we find, right? We generate alerts because we want more alerts in our life, right? No? No more? All right, sorry. All right. No. Actually, I'm going to talk about something way better than just sending a Slack message to your team or generating an email to 500 people. What if we could teach an alert to instead actually perform the analyst triage, right? What if an alert was actually an API call to GUR that pulled a RAM dump on a system that exhibited memory resident malware? And I'm not like making that up. I'm going to show you how to do it. So, all right, here's our scenario, right? Our scenario is we've got a sysmon event of a sensitive process being accessed, and the name of the process is winlogon.exe. And the source, meaning the offending process, is named mimikatz.exe. It doesn't get any more textbook than that, right? So you got mimikatz on the box, and it's reading credentials off out of a protected process. Definitely nasty, and we want to know. Well, here's the thing. There's a really good chance that the best evidence you're going to get for this IR is going to be out of memory. So what we're going to do is after we get off the phone with our sales rep who told us we should have bought next gen, we're going to have an alert. So Graylog is already has visibility of this event taking place, already knows what it means. Maybe we built a stream called memory residence threat, and as soon as something triggers in that stream, we have an alert. Well, that alert is actually a command execution, right? I've got a Python API client right here that reaches out to GUR, or Google Rapid Response, for anyone that's unfamiliar with it. And GUR tags the infected host with a tag. Let's call it memdump, right? And every 5 minutes, GUR is running a cron. It could be 1 minute, it could be 30 seconds, doesn't matter. But every set period of time, Google's running a cron, GUR's running a cron to say any hosts with the memdump tag, go ahead and initiate a memory capture. So now within minutes of this process, this sensitive process being accessed, we're getting a memory capture. No analyst moves that fast, right? Especially at 2 o'clock in the morning on Christmas Eve. So consider now that I've just taught 2 open source tools to do what an entry-level analyst does, but to do it before that analyst even knew something was wrong. So when the analyst comes in the morning, yeah, you get an alert sitting in your inbox, but you also got a memory capture waiting on you to go and analyze. So that's kind of cool. Let's talk about another one that you might be familiar with, especially you red team guys. So let's say I got a web server in my environment, and obviously I'm shipping my web server access logs, right? Well, let's say I get a user agent called SQL Map. We all know SQL Map is, everyone's favorite SQL injection testing tool, right? Well, here's the funny thing that a lot of new red team guys don't know is that all those bad tools on your Kali box, most of them by default, if you don't specify another user agent, they give away the name of the tool in the user agent. I love that. As a blue teamer, I'm going to take advantage of a lazy red team guy who just ran SQL Map and didn't even think about it, because guess what, dude? Your user agent just told me exactly what you're doing. And I'm going to teach Graylog how to troll you, and you're going to have a bad day. So I've got my logs coming in, because my red team guy ran SQL Map. And here it is. I've got SQL Map right here in the user agent. So I'm going to tell Graylog, hey, extract the source IP of that SQL Map attack, extract the source IP, and write it to this text file called honeynet blacklist, right? And then I use pfSense as an example because, again, open source for the win, right? But guess what? If pfSense can do it, your enterprise firewall should definitely be able to do this. pfSense is pointing at that text file as a dynamic blacklist. So anything that's on that text file, pfSense is ingesting and it's writing it to a rule. Well, guess what I'm going to do? I'm not going to put you to blacklist because then you're going to know that I know. And I don't want to ruin the fun that soon. I'm actually just going to write it to a DNAT rule that's just going to redirect your traffic to a honeynet. So that WordPress server or whatever you were beating up on, you're going to continue beating up on it, but it's going to be one over here that I have nothing on it that I care about. I'm just going to sit there and watch you have a blast and struggle, and I'm going to learn everything that you're going to try. So that's a really cool way to, one, not only actively defend my network without even trying, but two, further collect intelligence about a would-be attacker because I've just pointed you at a non-prod system that I don't care. You can attack that for days. The longer you play, the longer I get to learn about you. So again, this is a scenario that very, very easy to write this out. You could go and get all those known user agents for all those really cool ScriptKit tools, put them in there, and build your blacklist. So that's all I've got. One of the things that the Graylog team allowed me to do was kind of disclose a little bit of what's up and coming in 3.0, which is their next major release. They're implementing a views capability, which is going to be phenomenal for SOC analysts particularly, who can they can take a single log entry and then expand on it immediately and get additional context on all the things that are related to that log entry, right? So think about that from an analysis perspective. Reporting, because we do know that we definitely need our tools to be good at generating reports and all that good stuff. They're building that in. And then sidecar. This is probably my favorite improvement here. So you remember the sidecar was that Graylog binary that was going to allow us to manage our beats endpoint agents. They're actually breaking the direct connection between the sidecar and beats. They're now going to say that sidecar can manage whatever you want on the endpoint. Like if you've got sysmon config and you want to manage that, go for it. If you've got some other maybe in-house endpoint agent, you want to be able to manage its configuration, they're going to try to make sidecar just like a unanimous, just manage whatever you want to point it at kind of thing. So that's going to be an enabler for all kinds of teams. But that's all I got for you guys. Short and sweet. Any questions about all that good stuff? Got it. So the question was, what about systems that you can't just slap a Debian binary or, a package on? You got it. You got it. Well, actually, so you could actually just, you don't need a middleman. You could just forward our syslog directly to Graylog. So you could stand up just a raw UDP or TCP syslog receiver, and then just send raw TCP syslog or UDP syslog to it. So yeah, any system that just doesn't have the ability to run the beats agents, no worries, just raw syslog it. You bet. And one thing I kind of skimmed over, but I always try to make a point to mention this, right? Because I talk about active response in here a lot, automatically blacklisting IPs in your environment. Okay, here's my disclaimer. Definitely don't approach an active response capability like this lightly in your enterprise environment without putting a lot of time and research and thought into what could go wrong. Now, I think it's safe to say that blacklisting a user agent of SQL map is probably okay, but be very careful when you're putting in things that are going to automatically do things in any environment. You don't want to piss off the business, right? You bet. But any other questions? Yes? Absolutely, absolutely. So it was a great question. He said, are there scenarios where you'd almost want to stack or nest different pipelines, right, to really drill in on a specific situation? So, the great thing about the pipelines is, so I can actually build stages of pipelines where, well, it's effectively one pipeline with multiple stages. So I could have stage 0, see what the user agent is. And if the user agent is one of these bad ones, okay, skip to stage 1 now. Stage 1 says, okay, I already know it's an evil user agent, but what's the source subnet? Is it from one of my local internal subnets? Then let it go, it's one of my pen testers. Is it from a non, right? And so you can do stages where it's like several layers of logic to run that thing through before you, make a determination or take an action, right? Absolutely. Matter of fact, it is impressive actually how well it does that. So on the screen where I would essentially be looking at my pipeline and all of its different, excuse me, I just said the word, stages, right? It will actually show me in real time how many events are entering the pipeline, and then it will cascade at every stage. It'll show me how many events made it to that stage in real time. So I'm sitting there watching. I'm like, okay, 100 are coming in, 96 hit this point, 47 reached this point, 13 reached that point. So yeah, I could sit there and see the effectiveness of like, how well, is it filtering logs through. And then if it generates errors, like maybe one of my rules is terrible or something, if one of them is generating errors, it's going to tell me, it'll give me some error output. So yeah, you bet. Yes. No, absolutely. So the question was, when you're using Beats, can that just come directly into Elasticsearch, right? Actually, it doesn't. Beats does not send data to Graylog technically. Beats actually sends data either Logstash or Elasticsearch. So the answer to the question is yes, because by design it only does that. Graylog itself does not actually receive anything. Now Graylog is the C2 component for the sidecar collector, which is managing your Beats config, but that's just API calls saying, yep, I still want all those event logs, keep sending them, but it's sending them actually to Logstash. So if you just use a vanilla Graylog deployment, then Logstash is your receiver. Beats is sending the Logstash, not directly to Elasticsearch. But the short answer is yes. Yeah. It's technically coming into Logstash, though. So what Graylog's doing behind the scenes is it's spinning up a Logstash receiver. Yeah, so Graylog itself, what's that? Yeah, effectively the same thing. Yeah, you bet. Nobody else? It's basically a GUI over Logstash filters. Is basically what it is, and that's the awesome thing about this. So that's another really cool thing about like why elk or Graylog. One of the things about Graylog is it's got a much more narrow learning curve than a raw elk deployment. Now I will say this to the contrary, Kibana has a far more beautiful interface than Graylog. Like Kibana is an amazing interface, and I've told this to the developers of Graylog. I'm like, guys, y'all have got to work on that dashboard interface. It's functional, but it's not attractive. Kibana's beautiful, but here's the thing: if you're running elk, if you're running an elk stack, you're getting down on the command line. You're going into the config files, and you're writing those Logstash filters by hand. Graylog brings that a little bit closer to user space. You know what I mean? I'm not going to say writing a pipeline is trivial, but I will say it's a lot easier than it is writing a Logstash filter on the command line. You know, it's a little more approachable to your entry-level admin or whoever you're giving this task to. Yep. That's a great question. So I do want to go back because there are some fantastic ones that I actually use as my own and as reference in these slides, and I would be doing a disservice not to pay a moment to show them to you. The Ion Storm pipelines are fantastic. So if you just get on GitHub and look up the Ion Storm repository, go look in their Graylog repositories. They've got a ton of awesome pipelines in there. But that's just a really good starting point. There's Graylog has a marketplace that you can go and you can look up other work that other people have done. They might have already pre-built, like so you run Nginx in your environment, guess what? Somebody's already done all the hard work. There's an Nginx content pack, you just bring it down and boom, immediate action. Furthermore, in the Ion Storm repository here for Graylog, it's not only pipelines that they are giving you, pre-built dashboards to show you all of the interesting awesomeness coming in from Sysmon. Right? So they just took like 6 hours of work off your plate. So fantastic resource. I can't say enough. And then furthermore with Sysmon, you are aware Swift on Security's got a really kick-ass Sysmon config file in a GitHub repository. Just Google Swift on Security Sysmon and you'll find it. Did it? Awesome. Well, if you do have any other questions or whatnot, feel free to hit me up on Twitter. I love chatting about this stuff. Just get to that last slide here. Eric, boom, that's all I got for you guys. Thank you.
couple things for those of you that are here. I have sent out schedule and whatnot, but right now CCDC is kicked off in the other room, if you want to check that out. Tomorrow morning, the Circata training starts in the Beacom Institute of Technology. And then tomorrow late-ish morning, like around 11, basically when CCDC ends, and the awards have given out, because a lot of the trainers are doing CCDC, the remaining trainings will start. And I've sent out an email with that to everyone that's registered. Also, one more try. If you're missing your hotel room keys, come find me, or you might see me later tonight. Like, I'll just come have some fun time, but not really.